Hello everyone. Welcome to another video tutorial by Simplilearn. Today, we are going to learn Python programming in detail. If you are a beginner and have interest in learning Python from scratch, then this is the right video for you. We have our experienced instructor Anish, who will take you through this video. But before we begin, make sure to subscribe to the Simplilearn channel and hit the bell icon to never miss an update from Simplilearn. First, you will get an introduction to Python and understand how to install Python and use Anaconda. You will then learn the basics of Python such as variables, data types, data structures such as list, tuples and dictionaries. Moving further, you will get an idea about using conditional statements, if and if else. Next, you will learn while loops and for loops. You will then see the concepts of file handling and deep dive into learning object-oriented programming. You will also understand how to write functions in Python. Finally, you will work on 3 interesting Python projects to improve your programming skills. So let's get started.
Hello everyone and welcome to our course on Python programming. My name is Anish Karan and I will help you learn the fundamentals of Python programming and what programming in Python really means and what it is all about. I am sure there are plenty of you over here that are watching this video that have their own reasons and multiple reasons to start learning programming and programming in Python in particular. Our goal over the duration of this course is to ensure that you are able to learn Python and learn Python programming to a level in which you can tackle whatever problems you have and whatever projects you set out to do in the future. Now, I'm sure you must have heard that there are some of the most upcoming fields and some of the high prospect domains in the market right now, such as data science, AI, machine learning, require Python programming. And our goal in this course is to get you to a level where you can start tackling and creating solutions to whatever problems you may occur, whether it be in your job or in your studies or anywhere else or any personal projects that you may take up in the future. Now, before we actually get started on the actual concepts and the fundamentals of Python, I want to show you over the next 2 or 3 videos exactly how Python came to be, what was the philosophy behind creating this language, and basically a brief introduction behind Python and Python programming. So Python programming was developed first by a Dutch programmer by the name of Guido van Rossum, and Python was first released by him in the year 1991. Now, the design philosophy behind Python was to create a language which was much easier to read and much easier to actually code in compared to or in contrast to the languages that were prevalent back in those days, such as the language C. Now, formally, Python is an interpreted high-level general-purpose programming. And what this means is that Python is a language that can be used for a wide variety of applications, as we will see later. The high-level part of this definition basically tells us that Python is written in a language that is very abstract, at a much higher abstract level compared to the instructions that a computer can actually read. So in layman's term, you can say that Python is very close to the actual language that we humans use, and that's the way Python has been designed. And the difference between a high-level programming language and a low-level programming language is that low-level languages are essentially machine language instructions that are the actual instructions that a computer can actually understand. A high-level language like Python is something that we humans understand better and we can write in it better. Now, the term interpreted over here essentially means that we don't need to compile our instructions that we give in Python. Now, as I mentioned earlier, that the computers or any system that involves computing needs low-level language to be fed to it so that the computer can actually understand, because computers cannot understand the way we write our code. And this process of converting from high level to low level is called compilation. And in most languages such as C, there's a special process involved called compilation, which we do after we create our blocks of code or scripts or whatever. Now, when we say Python is an interpreted language, what this means is that we can actually work on Python and see the results right at the get-go. We can skip this step of compilation because our system that runs Python actually does all of that conversion from high level to a low level language as we type our code. And this actually speeds up the process very well for us and makes programming in Python and other interpreted languages as well. Much easier for us. Python is of course an open source language. It's the most bare implementation of Python, known as CPython, is actually even currently being maintained by a foundation known as the Python Software Foundation. So essentially Python is being maintained, developed by a group of very talented developers, and it's open to pretty much anyone to work with and to create libraries for. This allows Python to be an amazing language in the modern world, because in the modern world we have different issues and different problems in different spheres and domains that we would need to update our libraries or update our packages that we use in our programming language on a very regular basis. And so Python, being an open source language, allows us to keep updating and keep up with the times, essentially, when it comes to solving problems. Now let's go over some of the features of Python, and these features are actually why it's considered that using Python is advantageous over using other languages. So let's start with some of these points. Now, as we mentioned, Python is it's a very readable program. Code readability is very important. It's one of the design philosophies behind this when it was being developed. It's very easy to learn, which is why Python is an entry point for many people that are just beginning to learn programming. And as I mentioned earlier, it's a high-level language. In Python, since Python is open source, as I had already mentioned, so it benefits from all the benefits you get from any open source technology. Now, it's also portable. So what this means is that if we create a code in Python and we create it in a particular system, say on Windows, we don't need to make any changes if we wanted to use the same script or that same piece of code on some other system, say on a Linux system or a Mac system. Python itself comes with a very large standard library. This facilitates us a lot, because we don't need to create our own libraries or modules or have to download very specific libraries. Most of the problems that we do encounter quite commonly can already be solved by the standard libraries that have already been provided by the developers of Python right from the beginning. Now later on during the course, we will encounter what is the meaning of a data structure. A data structure is essentially manipulation of an object of data, and as you will see later, Python has one of the most user-friendly data structures that can be found in any language, especially compared to some of its contemporaries. Now, Python is a dynamically programmed language, and this is very important. And what this means is that in most compiler-based languages, there are certain processes that can only happen during the compilation stage. So what a dynamic programming language does is it takes all those compilation-specific tasks and processes, and it does it for us as we actually type the code. So we don't need to waste time or spend extra time to do something that would otherwise be needed to be only done in compilation. We would have to set out specific runtime just for that. So this allows us to create our programs and solutions much faster, and allows us to debug much easier. And so it's a very important feature about Python. Now, quickly, I will just go over some of the areas of Python where, like, areas of or different domains where Python is very heavily implemented. And the first few ones that come to mind are like web development and AI and machine learning. So you have technologies like Django and Flask that are built on top of Python that are used extensively for web development. When it comes to something like artificial intelligence or machine learning, you have distributions such as Anaconda, you have Pandas, and many other libraries like SciPy and NumPy that are used extensively to tackle problems in this domain. And similarly, Python finds use in most of the scientific work that goes on nowadays because of, again, some of the libraries that I have already mentioned, such as SciPy. Interestingly, if you are into game development or gaming in general, you would see that Python actually has certain libraries and certain technologies that facilitate game development very, very well. One very popular game, if in case you are into gaming, is a World of Tanks that is built on Python. Some of the other applications are, of course, desktop, creating desktop GUIs, image processing, graphic design applications, and something that is very relevant to me and of course you as well is creation of education programs and training courses. There are many technologies in the environment of Python that were almost designed for the specific purpose of being able to present certain concepts or to be able to teach certain classes. And I can't think of too many programs or too many environments outside of Python that are better to solve these education and training course related problems and situations. So I will show you how to install Python on Windows since I have a Windows system. However, I will also point out the way you would have to install Python on Mac OS or Linux or even on mobile. So yeah, let's get started. So to install Python on your Windows computer, it's as simple as going to the website python.org and selecting the downloads section. When you do click on downloads, you get redirected to this website this web page that I'm on out here. By default, it will ask you if you want to download Python 3.9, which is the latest version. But of course, if you, for whatever reason, if you needed a particular version of Python, you can download that as well by just scrolling down and choosing the option that you want. Now, it's important to note that whatever option you choose, of course, I would recommend the latest one, but no matter what option you choose, I would recommend you choose a version of Python 3 point something, because previous versions of Python, namely Python 2.7 and basically every version of Python 2 point something it will not receive any more maintenance and updates because the developers have decided that Python they are trying to shift towards maintaining and updating Python 3 point whatever completely right now. So yeah, let's not delay this any further and let's just download Python 3.9. So once you select the option out here, you'll get an installer. All you have to do is click on that and it'll give you two options: to customize installation or install now. I would of course recommend just to install now. Since you're a beginner, do not worry about what a custom installation is. If you have multiple drives in your system, by default the Python will be downloaded into the drive where your Windows is actually installed, your main drive. So as you can see, now that once my setup is done, it should give me a pop-up soon. So my setup is done for Python, and this is essentially how you would download Python on your Windows system. But what if you had Mac OS or if you were using Linux? Well, for Mac, it's actually almost as simple. You just go, if you see out here below this download button, Python option, you get the website asking you, are you looking for Python on a different OS? And it gives you the options of Linux, Mac, and even other OSs. But for Mac, if you wanted, you would just open this tab, and just like the Windows option, you would choose a version and you would choose an installer for that version. So if I wanted, say, Python, the latest one, I would just download this installer and I would install on my Mac system. Now, when it comes to Linux, I cannot show you exactly how you would install it. There are certain commands that you have to execute, but essentially, again, if you would just choose the Linux option out here, it would take you to a page with different installers and essentially packages for Linux systems in specific. What I would recommend to you if you are a Linux user and you need Python is to go over to the realpython.com website, and they have a very good essentially instructions on how to install Python. And since I don't have a Linux system, I cannot directly show you how to install Python on Linux. So yeah, if you do have Linux, please head over to this website, and this should be of a lot of help to you. Now, as I had mentioned, you can actually install Python on your mobile devices as well. So if you were, say, an iOS user, you would go to the iOS App Store and download an app called the Pythonista app for iOS. It essentially is like a full-fledged Python environment where you can develop in Python on your iPhone or even iPad. And if you were an Android user, you would go and download an app called the PyDroid 3. There's a free version and a paid version for this app. And of course, the difference between the free and paid is that the paid supports code analysis and code prediction. These are certain details you don't have to worry about right now. And honestly, if I wouldn't worry too much about installing Python on your mobile devices currently, since I am assuming most people would be learning programming in Python on their PCs or laptops. now that we've mentioned how to install Python, what I had actually shown you was installing what is called an implementation of Python on your system. An implementation is essentially a program or a software or an environment that allows you to actually work in Python. So what I showed you was how to install the by default or the most basic or reference implementation that has been created by the developers, which is actually called CPython. Even though you would not have seen the letter C or the prefix C, but yeah, that implementation that I had downloaded myself and I had shown you to download is actually the CPython implementation, which is Python built on top of C, the C language essentially. There are other implementations such as IronPython, which uses the .NET framework, and JPython that uses Java virtual machines that you could use if you were interested. But again, these are things that I would not worry about too much right now. So now that we have tackled on how to install your implementation of Python, I want to introduce what is called a distribution to you. This distribution is called Anaconda. Anaconda is a very important distribution, especially if you are looking to use Python in data science and machine learning and AI, which I am assuming is the motivation for many of the people that are actually watching this video, that they actually want to move into data science and they need to learn Python as a foundation towards moving towards data science. And if that is your goal, or in any case, whatever your goal may be, I would recommend that you install Anaconda distribution. Now, do not get confused between Anaconda and Python. Anaconda is Python with in the form of a bundle, and this bundle contains not only the basic Python implementation that I had shown you to download, but it contains a lot of extra libraries and technologies and softwares as well. So, of course, this means that would you need to download both? Of course not. If you downloaded Python, you do not need Anaconda to work on Python. And if you have already downloaded Anaconda, which I will show you how to do it in some time, if you have already downloaded Anaconda, you don't need to download Python separately. So I'll just speak about Anaconda a little briefly. So as I said, it's a distribution. It contains a bundle which includes the basic Python implementation and a lot of technologies and softwares and applications that essentially help us to use Python in specifically managing big data applications and data science related projects. So now I will show you actually how to install Anaconda on your system. It's as simple. It's actually as simple as downloading just this thing. So if I did a quick Google of Anaconda, so the website that I'm looking for is anaconda.com, and I'm looking at products and I'm looking at individual edition. There are other editions as well, like commercial, team edition. These are for companies usually, or for more professional sort of projects. So of course we are looking at the individual edition, and if you selected this page, you would be taken to this particular web page where it'll ask you if you want to download. And again, there are options depending on which machine you're using. If you're using a Linux, you would choose one of these two. If you are using Mac OS, you would use one of these two. And since I am a Windows user and I have a 64-bit system, this is the option I would use. So again, it will first download an installer for you. And as you can see, my installer has been downloaded. So upon opening it, it will open up this installation thing. You can just click next on most of these. Again, if you want to specify your destination folder, you can change it here. Mine will be with a default folder in the C drive, and you can leave this unticked. You can change these options much later. So this is how you install Anaconda on Windows, and it's pretty much the same on other systems as well. Now once it's done, I will show you what are some of the things that Anaconda contains that are not there if you installed Python, like the way I had shown you earlier, just the bare bones Python implementation. So as you can see here, my installation is actually complete, and now I will open Anaconda and I'll show you how you can actually use this Anaconda. So if I search for Anaconda in my system, I would look for something called Anaconda Navigator to actually get started with this. And when I open that, it should open something like this. So this is what opens when you click on the Anaconda Navigator. And as you can see, there are a bunch of applications. You don't need to worry about what these mean right now. Just understand that this is essentially a bundle of different applications and technologies that come along with just the normal installation of Python that you get when you install Anaconda Navigator. Now that we have actually tackled where we've seen how to install, and I'm hoping and I would recommend definitely that everyone is watching this video installs Anaconda, not just the normal Python installation or implementation. Now that we have gotten all the introductions and the basics and the installations regarding Python aside, let's get down to actually creating our first script. So now the question is, how do we actually start doing this task of creating our first Python script? How do we realize now that we've installed Python, how do we start doing something? So the answer to that question is that typically when you're working on Python, one of the most basic things that you can do is create a Python script and execute a script. A script is essentially a sequence of commands and instructions that you give for Python to run and execute to give you a certain result. So I will show you how you can create a Python script. Now there are multiple ways of creating a Python script. You can create it directly from command line, which is obviously something I would not recommend because it is not convenient and easy, and it's not very useful for a beginner. Another way is using a text editor such as the one I have opened right now, which is the Notepad++ text editor. Now it's very important to not get confused between Notepad++ and the standard Notepad that comes with your Windows or WordPad for that matter. In fact, text editors such as Notepad and WordPad that you are more familiar with create text and files in a form that is called rich text. Now, rich text is text that contains formatting and fonts, which is actually a hindrance when it comes to creating actual code. So what we need is a text editor that creates or writes text in what we call as plain text. Plain text is obviously text which does not contain these fonts and these formattings, and it only respects white spaces and indentations, those two being actually useful towards creating code, unlike fonts and formatting, which are only a visual thing. So Notepad++ is obviously a text editor that creates plain text documents. That was actually created with programming in mind. Obviously, you can use a bunch of other text editors such as Vim and Atom, and you can Google for these. There are plenty of them. So without any further ado, let's create our first Python script. So one of the most common, one of the most famous examples of a first program in any program for that matter, not just Python, is creating a print statement that gives us a statement saying hello world. So in Python, this is how you would go about it, or this is the syntax you would use to create this statement. Alright, now where it is very important when you are saving your Python program that you use the .py prefix. So if I were to save this, I can choose whatever folder. I am going to choose, this folder seems fine. So now I give the file name over here as, say, I want to keep it as test. I need to prefix this with .py, and this tells any sort of interpreter, or anytime we need to read the script to know that it's a Python script, we need to add a .py. Otherwise, it will not be treated as a Python script. It will be treated as some normal document sort of a thing. So now that I have stored it as .py, I have created my first Python script. Now, obviously, the next question is I need to see what happens when I execute this line, when I run this script, essentially. So to see that, there are multiple ways. The first way that I will show you is a command line method, which is obviously, again, before we get into it, it's not something that I will be using to teach you. It's not something I would recommend you to immediately start using. But for the sake of showing, I will show you how to execute a script in command line. Well, to do this, you go, since I have installed Anaconda in my system and I will be using Anaconda to work in Python, what I will look for is something called the Anaconda prompt. As you can see, this is the option that I get, Anaconda prompt. This will essentially open you a command line under the environment of Anaconda or Python. So in this, now I am already in the folder, I believe, that had my script. So how do I call this script, or how do I run this script? Well, the command is Python space the name of my file, which was test. Of course, the prefix is very important, so I enter test.py. If this was in a different folder, you would have to change your folders in command line, which is again something that I might show you later. But since my file is already in the folder that I am in my command line, I would just have to enter this command right now. So if I execute this, as you can see, it's given me an output of hello world, which is what I wanted. I wanted it to print this these two words. And of course, the command line is now waiting for the next command for me. So this is one of the most simple ways of, or the most rudimentary ways of executing a Python script. Now, another question would be, well, this isn't the most visually appealing or not the easy to read or easy to use way of executing scripts. And I would agree. And that's why I'm going to introduce another technology or a software called the IDE. So the IDE in Python or in any programming language stands for Integrated Development Environment. It's essentially a software that not only allows us to run scripts, but it allows us to create the scripts, it allows us to debug, it allows us to see outputs, it allows us to see intermediary outputs, it allows us to do a wide variety of tools and tasks, and it comes with a bunch of robust features to enhance our Python programming experience. So let's see. So I will show you an IDE called Spider, which comes bundled along with the Anaconda distribution that I had mentioned earlier. So if I open the Anaconda Navigator, as you can see, the Anaconda Navigator shows me a bunch of technologies and options, and I'm looking for something called the Spider IDE, which is over here. As you can see here, it's a scientific Python development environment. This is exactly what I'm looking for. So I am looking to launch this. So now that I've launched it, you can see out here, this is what an IDE looks like. Now this looks very sophisticated, and almost any IDE is a wonderful software where you can create your code, you can debug your code, you can check the results, you can make adjustments, changes, and you can do a wide variety of tasks and functions with relation to your programming. So this is the Spider IDE in particular, and this is how it looks. Don't worry about the exact details. Just know that on this left-hand pane is our current script that is open out here, and out here we will get the results in this is what we call a console essentially. So now that we have already created our script in Notepad++, and I want to open that script and I want to see the result of that script would look in an IDE. So let's just open it so we can browse for our file. And as I had named it test, this is the file over here. I open this, and as you can see out here in the left hand pane, my script has opened, and the command that I had given or had written is out over here. Now if I want to run this application, I press this green button, and as you can see, the result of my execution essentially is over here. It's in slightly small font, but as you can see over here, it says hello world. And the next line is essentially it's waiting for me to do another execution of the script, and then it will give me new results. So let's actually give the system new results. So now that I have printed something called hello world, let's change what's written over here. Let's say I will perform basic maths. All right, and let's actually perform the basic maths. Again, don't worry about the details, the syntax, what I'm exactly doing. These are things that we will actually cover in upcoming videos and modules. So let's create a variable called a. Let's store a number 3. Let's create a variable b, store a number 5. All right. Let's create another variable c, which will store the result of what's in a and b, in the addition of a and b. All right. And let's print the result, or print what's in this variable c, or what's the result of a plus b. I will print a statement saying the result of the addition of 3 and 5 is, all right, and I will put my result over here. As you can see, I should get the result in this pane. So let's execute this, and you can see my first line is executed saying I will perform basic maths, and the next line says the result of the addition of 3 and 5 is 8. So in this script, what I've done is I performed 2 print statements, and I've performed a basic expression, some variable assignments. All of these things we will be doing later. This is what I'm essentially trying to show you is that IDEs are a very convenient way of not only creating the scripts, but actually seeing the results and then making adjustments as well. We can create a completely new script. We don't need to create a script from some special file or text editor. I can just create a new file here, and this is my new script essentially. So I can start working with this new script right over here from the get-go. So IDEs are very powerful. Spider IDE comes bundled with Anaconda. There are other IDEs such as the idle IDE. It stands for indicated development and learning environment. So the idle IDE comes as part of the basic Python implementation that I had shown you in the previous video, where if you just installed a basic Python implementation, it would come along with a basic IDE known as IDLE, or integrated development and learning environment. But of course, since we are using Python, and that is what I would recommend, it comes with a more robust IDE called Spider, which is actually very, very helpful for scientific and numeric applications, and was designed specifically with that in mind. Now, this is not the only way we can actually work with Python. There's another very interesting and a very educative method of creating Python, let's say Python programs. And it's something that I will be using extensively throughout this course to explain different concepts. So this technology is called, or this software is called notebooks. Now, before I get into the details, I will just open a basic notebook. So the notebook that comes as part of Anaconda is called the Jupyter notebook. And when I launch the Jupyter notebook, this is what I get. Now, a very important feature, or a feature of notebooks, is that notebooks are a web browser or a web-based application. So it's not something that you can use if you are offline or disconnected. Basically, if you're disconnected from the internet, it is something for which you would need an active internet connection. However, it is way more robust, and it has very, very good properties that allow it to be used in education or for presentations and such. So as you can see, this is my Jupyter notebook. These are a bunch of folders. You don't need to worry about what these are right now. I will show you how to create a fresh notebook. So if you go here, you go to new and you select under notebook the Python 3 option. It will open your first notebook. As you can see, this line is essentially waiting for me to enter some sort of a command or a statement that I would give in a normal Python thing. Now, if you would have noticed until now, everything that we were doing involved us creating a script, which was the whole series of commands and functions. So if I go back to my Spider IDE, as you can see, like this is a whole script, and this script contains multiple different tasks and functions that are individually being performed. So this is a separate print function. This is a separate addition, another separate print function. And for longer programs or larger programs, you'll have multiple different tasks being done. And if you were using a script, you can only see the result of something like this by executing the whole thing at once. You cannot see exactly what is the result of just this print statement or just this. It's not typically what an IDE is used for. And this is where notebooks come in super handy. If I had to break down my previous script essentially, where I first did a print statement, where I said some random thing, say hello. Yeah. So if I execute this particular line, you can see it gives me the result. Now I want to do what is 5 plus 3. It should give me the result over here, 8. Now the next, another part of your program might be storing 5 and 3 into variables. So I can do this and I can do this. So now this line will store the variables. Now I want to do the addition of what is 5 plus 3, but I want to use the variables. And I want to see what's the result. As you can see, a plus b means 5 plus 3, which is 8. And I've essentially broken down various different parts of my previous script into its individual tasks. And I'm able to see what each part of that script does. And this is very good when it comes to making presentations or trying to teach a class. So I will personally be using notebooks a lot to explain different concepts when it comes to Python. And I would recommend that you get used to notebooks in general, because it's an amazing way to learn Python programming, or programming in general, in fact. And again, as I had mentioned earlier, notebooks are something that it's an online application. It's a web-based application. So I will have to need a active internet connection to be able to work on a notebook, which could be a disadvantage if you do not have a consistent internet connection. And in that case, you would probably use your IDEs or text editors, which can be used offline as well. In this video, we will be introduced to the concept of variables and expressions. Let's start with expressions. Well, an expression in Python is anything that results in a value. Its difference, or the difference between an expression and a standard statement in Python, is that a statement in Python is something that results in an action or an execution of a command. There is no calculation per se, or any sort of manipulation, or, as I said earlier, calculation resulting in between two different, say, numbers or other objects that results in a value. And this happens in the case of an expression. So for example, if I were to add two numbers, say 5 plus 10, this is an expression where two objects, 5 and 10, are being added and a result is being given to me, which is 15. Now let's see an example of a statement. Well, a statement could be something like a print statement. So when I ask Python to print something for me, it's not calculating anything, it's not evaluating anything, it's simply performing an action that I have, or a command that I have given the system, which is to print whatever I have entered over here, as you can see. So this is a statement. Similarly, there are another type of statement known as assignment statements, which we will learn actually right in the next section. Well, let's move on to variables right now. Now, earlier, you might have learned about objects in Python. So objects are essentially data that we can work with or manipulate in Python. Now, variables are a place to store these different objects. Usually, it's much easier to store objects in Python instead of using the objects explicitly themselves, because objects may be very complicated, whereas variables are very simple to use and very simply are named in a very simple manner so that we can use them quite often in our programs. Now, it's important to note that in Python, we do not have to explicitly declare or define a variable to create them. In fact, variables are created in the same statement where we assign some object to that variable. In Python, the assignment of variables happens using the assignment operator, which is the equals to sign. So if I wanted to assign a number, say 100, to a variable, say b, well, it would be as simple as doing this. Now, anytime I want to know what is stored in b, I just have to enter b and I will get the value that is stored in it. And we can store different types of objects inside any variable. Let's say I want to store this particular word in the form of a string. Now this is stored in x, and if I want to know what is in x, I can just see what is here, and it's a string hello, which I had stored earlier. Now it's very important that we follow certain naming rules when it comes to naming our variables in Python, or else we may be thrown errors or we might get some problems in our program. So the first rule is that you cannot start your variable name with a number. So if I were to give a variable name like 4num is equal to something, say the same string hello, this would be an illegal variable name and I will get an error when I try this. So if I were to choose in num4 is equal to hello, this would be perfectly fine. I won't get an error. The second rule is we are not allowed to use any non-alphanumeric characters except the underscore character while naming our variable. So for example, if I were to name my variable num underscore 4 and I said random, some random string, this is perfectly fine. However, if I changed num underscore 4 to num hyphen 4, this will throw me an error, as you can see over here. Next, the third rule is that variable names are case sensitive. So if I have a variable called num, or say num, if this was one of my variables and I stored, say, the value 50, this is not the same as me writing num all in capitals and say storing some other value 60. These are two different variables. So it's very important that when you name your variables, you are aware of what case you are writing them in, because Python variables are case sensitive. Now the final and probably one of the most important rules in Python is that you're not allowed to use what we call reserve words in Python. Now Python has a bunch of reserved words. These words essentially are performed or they are used to perform certain special functions and are used as identifiers for certain special functions in Python that have a special purpose. Like that particular word has a special purpose within the Python programming language, and we cannot use them to name our variables. So a list of them, as you can see over here, some of them are like false, def, if, del, raise, and there are around 33 of them. And sometimes some of these words are taken out. Sometimes there are more words added as Python gets updated. Now, let's move on to a concept where we try to really understand what do we mean by storing data inside a variable. Now, when I say that we are storing something inside a variable, you get an image or you get an idea in your head that this variable is like a container where we store or we put a particular object inside it. So does this mean that variables have a place in the memory? Are they also an object that is placed in the memory where we can put other objects inside of? Well, I'll show you an example where this idea is kind of disproven, or where I'll show you that the idea of variable is kind of different than what we understand by storing something inside a variable. Now, let's say I'm storing the same object. I will take this object as some random number, let's say 100, and I'm going to store it into two different variables. So I take x is equal to 100 over here, and in the next line I will store 100 in y as well. Now, if variables were objects that we placed in our system, then x and y should have two different IDs. But let's see what happens when I check the ID of x and the ID of y. They should be different in case variables were their own objects. However, as you can see, the ID of x and the ID of y are exactly the same. So, well, obviously we know that two different objects in Python cannot have the same ID. So what does this mean when it comes to the nature of a variable? Well, the fact is that variables are not actually objects in Python. In fact, variables are more like pointers or references to the actual object. So when I said x is equal to 100 and y is equal to 100, what I'm actually telling the system is that there is this variable name called x that I want to refer or point towards the actual object that is in my memory called 100. And I do the same thing with another variable y. So I am not exactly creating a different space in my system for these variables. These variables are more like placeholders or references that point to a particular place in the memory where this object is located. And that is what happens when I do ID of x and ID of y. It's not giving me the ID of something called x or the ID of something called y. It's giving me the ID of 100 each time because 100 is stored in x and y. So as you can see, this is something like a visual representation of what I'm trying to say. And similarly, if I were to, so in this example on the left, as you can see, I've used the value of 50 to explain my point. So as you can see, initially x and y are pointing towards this value 50 because I have stored 50 and 50 in both x and y. Now what if I changed the object that is stored in x? Well, that means x is now pointing towards this new object, and I have stored this new object called hello, this string called hello, as you can see here. So now x is pointing to a new object in the system, and it's called hello. And I haven't changed anything with respect to y, so y will point towards the same thing. And I can also make the pointer of y different, or what I'm trying to say is I can store something else in y. Say I stored this list in y, 50, 60, and 100. And when I do that, now y is pointing towards a different object in Python, and x is also pointing towards something else. So what happens to this object 50? Well, now that there's no variable referring to this object 50, it becomes what we call an orphaned object. And we can actually see that when we do the ID of x, now let's go back to my example on the right where I stored x is equal to 100. So as you can see, it gives me some ID represented by this number. Now let's say I stored something different in x, say 200. Now if I do the ID of x, it should give me a different ID because, as you can see, the values are different. And this is because this object 200 is what is stored in x, and when I do the ID of x, I'm actually getting the ID of this new object now, 200. So as you can see, variables are, they should be, and they are treated more like references or pointers instead of containers for a particular object. In this video, you will be introduced to the concept of objects in Python. Now, what are objects in Python? Well, all the data that we manipulate or use in our operations in our code are represented as objects or relations between objects. So if you want an example, two numbers that you add in your code, well, both of them are objects, and they're usually numeric type objects. Similarly, if you want to store someone's name or an address of your hometown in your code, you usually store it in a form of text, and that text is also an object, usually a string. Similarly, you might want to create a container of different smaller objects inside them, and that big container is also a type of an object, and one of those containers are called lists. And similarly, we have many different types of objects which we will be covering during the duration of this course. The following pictorial representation gives us a broad classification of different Python data types and objects. As we can see, there are 5 broad classifications. Numeric, which contains integers, complex numbers, and floats. We have the dictionary data type. We have the Boolean, which essentially consists of objects that have only 2 valid values, true or false. Then we have sets, and we have sequence data types, such as strings, lists, and tuples. Every object in Python has 3 important properties that kind of define that particular object. They are its identity, its type, and its value. The identity of an object is, it can be considered as a place in the memory or its address in the memory where an object is stored. An object's identity does not change once it has been created. So for example, if I took an example of, say, a string called hello, I can use the id function, this is how you use the id function, to find out the id of this object. And it should be, the answer should be in the form of a particular long integer. So as you can see, the id of hello is this integer 2326476623024. Similarly, all objects in Python have an identity. We have another operation with regarding the identity of an object is the is operator. And the is operator compares the identity of 2 objects. So if 2 objects have the same identity, it should give the answer true, otherwise false. Now the next property of objects is the type. The type of an object is essentially what defines what kind of values and operations that object can have. So for example, a numeric data type in Python, such as an integer, would allow us to do arithmetic operations. And similarly, string object type in Python will allow us to do concatenation operations. Much like its identity, the type of an object cannot be changed as well. Now let's see what's the type of that particular object that I had shown you above. As you can see, it should be string. str stands for string. Similarly, if I did a type for a number, say 50, it should give me int, as you can see. Now the third property of an object in Python is its value. Now the value is the actual data that is contained in the object. It's the thing that we use, that we display, that we can manipulate, and that we can perform operations on. So for example, if I were to talk about this string is hello. So the value of the string is the word or the sequence of letters that spell out hello. And similarly, this particular object is a numeric object with the value 50. Let's see, in this pictorial representation, I have shown you that you can assume this dashed blue area as the memory of the system. Now within this memory, we have objects created called 50 and hello, and this list containing smaller objects called cat, pen, and 40. Now, what I'm trying to show you here is each of these objects have a type, an ID, and a value. And let's see what they are. So if I wanted to see, as we had already seen the type of 50, now let's find the ID of 50. As you can see, we get this unique ID for the object 50, which is obviously not the same as the ID of the object hello above. And the value of this object is the variable 50 itself. So that was a brief introduction into objects in Python. In this video, we will cover the topics of numeric object types and type conversions in Python. So let's get started. Numeric object types in Python are a broad classification of objects. Plenty of common real-life applications that we associate with numerals, such as arithmetic operations and calculus, are done in Python using numeric object data types. There are 3 main types of numerals or numeric data types in Python. They are integers, float, and complex. Integers, as the name suggests, represent all integer values in Python. These can be such as 100, -3, 305, and so on. Floats are used to represent numerals that contain decimal points, such as 100.3, 3.9, 4.8, -6.8, and so on. Then there is the complex object type, which is used to represent complex numbers in Python. And this is an example of a complex number, 3 plus 7j. This is a complex number 3 plus 7j, where the real component is 3 and the imaginary component is 7. All complex numbers have a real and an imaginary component, and this is how we denote them. Now it's important to note that this j is a very common symbol in maths and engineering used to denote the imaginary portion of a complex number. And it's the same in Python as well. So moving on, let's talk about type conversion in Python. Type conversion refers to the conversion of an object from one data type to another, for example from string to an integer. And there are different types of conversions, and let's go through some of them. First of all, let's consider the conversion of something to an integer, and more specifically, let's consider the example where we convert a string to an integer. So let's consider my example string to be something called 145, and I'm storing this within a string for a reason, because I want to convert a string to an integer. So as you can see, I have stored this 145 within a variable x, and if I were to confirm that it is actually an integer, I can use the type function and see that it is actually an integer, str. Now let's convert this into an integer using the int function. So how would we use it is simply passing the int, by passing the variable that we want to convert into the int function. And as you can see, this is what I've done over here, but before this I will also store it into another variable. Alright, now let's see what's in y. Well, y gives us 145, but are we sure that it's an int? We can just check it by using the type function. And as you can see, the type gives us the answer int. That means that we've converted the string to an int. Interestingly, we can convert something and also specify what base we have to treat the number as. By default, when we pass something in the int function, the program or Python will treat whatever we have passed within the string as something in base of decimal. But what if we were to pass something that is, well, not in a decimal? Well, we could do it like this. Now let's store y, and in y let's do this, and I will show you what this means. X, and I will give a comma and 8. What this tells Python is, well, I want to convert the string in x into an integer, but I want to treat whatever is in x as a number of base 8. So 145 is actually 145 in the base 8. Now when we see what's in y, we get 101, which is different to 145, because, well, 101 is actually the decimal equivalent of 145 in the base 8. Similarly, if we were to give it in the base 2, we would just replace 8 with 2 over here. Now next, let's talk about converting something to a float. Now as we know, float is just simply something that has a decimal point. So let's convert an integer into a float. How would we do that? Simply by using the float function. So if I gave 120 and I pass this integer through the float function, I should get 120.0. These two are not the same, though they may mean the same things to us, but for Python, 120 is an integer and 120.0 is a different object, which is a float. And this is how we convert something to a float. Now what if we wanted to convert an integer to a string? Well, we can use the str function. We can also use the hex and the oct function if we want to convert a particular number to a hexadecimal or an octal string respectively. Let's look at all three examples. Say I have a number 688 and I want to convert this into a string. I just use the str function around this. So as we know, just to confirm, let's see what the type of 688 is. This should be an int, as we can see. But let's say we convert it into a string 688 and let's store it into some variable. Let's call it a. Alright, now let's see what's in a. It gives us 688 in the form of a string, but we can confirm by checking the type of a. It is an str, so it is a string. Similarly, we can use hex if we wanted to convert an integer into its hexadecimal equivalent as an output of a string. As you can see, this sort of complicated thing is actually telling us that we have converted 688 in terms of hexadecimals. Now, how do we read this output? This 0 should not be treated as anything. It's more like an identifier, which says that the letter after this first 0 is the base of this whole number. So it's saying that X stands for hexadecimal. So it's saying that 2B0 is to be treated as a hexadecimal number. And if you did basic maths, you would find that the decimal equivalent of 2B0 is 688. Similarly, if I did oct, if I use the oct function for 688, it will give me the result something like this. So again, how to read this? The first 0 is to be treated as an identifier and not part of the number. What it's saying is the letter after the first or after this 0 is the base of the number following these two characters. So as you can see, what's this saying is that this whole number is an oct represented by this letter O, and the number itself that we are dealing with is 1260. And 1260 in octal system is the equivalent of 688 in the decimal system. So this is how we've converted an integer into a hexadecimal or an octal string. Now, what if we wanted to convert two numeric objects into a complex data object? Well, for that we can use the complex function, as you can see here. If I passed complex 5 and say something like 3.1, let's see what this gives us. As you can see, it gives us a complex object where our real part is 5 and our imaginary part is 3.1. So what this does is essentially you pass two numbers. The first one is the real component and the second is the imaginary component. It combines to give you a complex number, as you can see here. Now let's look at some other type conversions. The next type we will be talking about is converting something to a tuple or a set or a list. So what if I wanted to convert a string into a tuple? I will use the tuple function, and as you can see over here, so let's say I have a string called random. Let's call it random. Alright, now if I want to convert this to a tuple, I will use the tuple function. As you can see over here, the output will give me tuples where each individual component of this tuple are the individual components or the individual characters of my string random. Similarly, if I wanted to convert the string to a list, I would use the list function. And this will give me a list of the individual characters of the word or the string random. And I could do the same thing with the set function to create a set of individual characters of the string random, as you can see here. So yeah, these were some of the basic Python type conversions that I have shown you. As we learn about more complex data types and different object types in Python, we will learn different type conversions and functions associated with them. In this video, you will be introduced to the concept of strings. Strings are an object type in Python used to store textual data. This textual data could be something like, for example, someone's name. It could be an address of a place, or it could be something like a word or a sentence. Now, strings in Python are an object type that is actually a subtype of a broader classification of objects called sequences. Sequences are objects in Python which contain components placed one after the other, where each component is given what we call an index, a numeric index. This numeric index identifies the component in the sequence and its position within the sequence. Now, since Python is a zero-index based language, the first object of any sequence is always index 0. The second is index 1, the third is index 2, and so on. Now let's move on to defining strings. How do we define them? Well, strings are defined using what we call delimiters, and delimiters occur in pairs, an opening and a closing delimiter. In Python, these delimiters are pairs of single or double quotes. So for example, if I were to use single quotes to define a string, I would do it like this. This is a string. As you can see, this is a string is printed over here. This is delimited using single quotes. Similarly, if I were to define a string using double quotes, it's as simple as doing this. This is also a, as you can see. Now a valid question arises. What if I wanted to include a single quote within my string? Well, if I tried to, let's see what happens if I try to print a statement with a single quote naturally inside it. So say I'm saying it's my birthday. Alright, let's see what happens if I try to print this statement. It says invalid syntax. And this is because, as I had mentioned, in Python, single quotes and double quotes are delimiters. So they have a special function in Python, and we cannot simply just use them within a string because Python will treat them specially for a special purpose. So what Python will do is it will pair this and this delimiters or single quotes and say, okay, this looks like a string to me. And it's not going to understand the rest of this. And then it will find a random single quote and it won't find its pair, and it will basically throw us an error because of this. So one way or one workaround to introduce single quotes into a string is simply to delimit our string itself using the other type of delimiter or double quotes. So if I want to include a single quote, I will close my string using double quotes. So if I did this instead of what I had done earlier, this is a perfectly valid and legal way of defining my string. And I would do the opposite if I had to introduce, say, double quotes within my string. I would use single quotes to close it. So if I were to write a speech statement, she said, I am hungry. Alright, I want these two double quotes to essentially show that this is a speech, and I'm going to close the string using single quotes. And this is a valid way of doing it. As you can see, my string has these two double quotes. Now, I had mentioned that strings are sequences. Well, let's describe how are they sequences. So first of all sequences in Python are essentially a sequence of smaller objects that form the sequence, right? So let's try to understand like how are strings to be treated as sequences. Some sequences that we will learn later are like lists or tuples. And in all sequences, we can retrieve any particular object or component in that sequence using its index. And how do we use indexes in Python? Well, we enclose a numeric index within square brackets. Now let's see what I'm trying to talk about by this example. Now say I'm storing a particular string called, say, random within, now my variable name here is test, and I'm storing the string random within it. Alright, and this is a way of retrieving a particular index from test. I write the variable name and then next to it I put the square brackets. Now I'm supposed to put a numeral within the square brackets to tell Python like what particular index I'm looking for. So let's try 0. Now as I said, Python is zero index based language. So the 0 index essentially means the first part of or the first component of a sequence. So let's see what happens when I ask Python to retrieve the first part of what is stored in test. It gives me the string R. In fact, it's just one character R and it's a string. So as you can see, it has given me the first character of the string random, which is R. So what this shows is that this string random is essentially a collection or a sequence of one character strings. So random is essentially a collection of the string R, the string A, the string N, and so on together combined to form the whole string that we call random. Similarly, if I wanted the character at the third position of this thing, I would use, well, since it's the third position and since we're working in Python, I would use the index 2. And it should give me the letter N. As you can see, it's given me the letter N. So this is how we can show that strings are also sequences in Python. Well, now let's move on to certain string operations and functions that we can perform. Well, as you have seen already, that we can retrieve any particular character within a string using numeric indexes. Well, what if we wanted to know what index is a particular character at? And we can do it like this. We use the index function. So let's say my test, and I want to know where or what position the character D is in my string random. So this is how I would use the index function. Index, and within the index, say I'm looking for the character D, and Now it should give me the answer 0, 1, 2. It should give me the answer 3. So if I execute this, it gives me the index 3. So this is the index function that we can use for our strings. Now, what if we want to say slice a string into a smaller part? We want to slice it and we want to retrieve only that particular slice. Well, here is an example. Say I'm going to use the same string called random, and it's stored in test, right? So the way of doing this is like this. Now let's just see what this does first. As you can see, it's given me A and D, and if I went to my string random, A and D is this particular slice. Now let's try to understand what I have done by entering 1:4. Well, what this has done is it's retrieved a slice from the first position, the first index, which is the character A, up until the fourth position, which is the character O. But it has not included O. So it's very important when I index like this, every time I put something to the right of this colon, I am not including this itself. Alright? So it's essentially when I say 1:4, what I'm telling Python is give me the first, the second and the third character, but not the fourth one. So it's given me A, N and D. And this is how we do a slicing operation in Python. Similarly, if I were to say slice from the first, if I wanted only the first and the second character, this is what I would do. If I wanted the first and the second character, I would do 1, 2, 3. So this way it tells Python that I want the first, I want the second, but not the third so as you can see, I get A and N. Now, so this is a basic slicing. What if I wanted the portion of a string from a particular point all the way to the right or all the way to the left? Well, let's consider the example of where I want the portion of the string random from the, say, fourth character until the left. Well, the way I would do this is test. Now, since I want it all the way to the left, I don't enter any index to the left of my colon sign. And since I want everything to the left of the fourth character, I enter 4 here. So as you can see, it gives me A, R, A, and D, which is everything from the fourth character of my string random to the left. Similarly, if I wanted something to the right of it, I would just do it like this. I would enter some index here and I would leave the portion to the right of the colon blank. So this will give me everything, including the third character, since this is how we treat the indexing in Python, everything including the third character all the way to the right. So this is DOM, as you can see. Now another perfectly valid slicing is, say I want to slice or take out different characters from the string, but I want to skip certain characters. Like I want this one, then I want to skip one, and I want to take the next one, and then I want to skip one. Well, in that case, we have to introduce a step. So one way of doing this is, now how do we read this? So as you can see, I've written 0:6:2. So what this is telling Python is, I want every character from my string test, starting from the 0th character up until the 6th, but not including the 6th, after skipping or taking 2 at a time. Taking 2 at a time can also be assumed as skipping 1 at each step, or skipping 1 character at each step. So what this will do is, it will go to random, it will take the 0th one, it will take R, and then it will skip the next one. So it will not consider A, and then it will pick N, and then it will not consider D, and then it will consider O, up until the 6th character, whichever that may be. And if you see the output, it gives us R, N, O, which is exactly what we wanted. We wanted R, we wanted N, we wanted O, where we skipped A and D, or we skipped every second character essentially. So this is a way of slicing strings while also skipping certain characters, or skipping characters in steps. Now Python is also there's another interesting technique that we can use in Python to where we can start retrieving characters from the rightmost side of a sequence or a string. We can use negative indexes. So if I were to, for example, show you, let's see what this gives me. Test what is a -1th index. It gives me the character M. Now remember, a string is random, so -1 gave us the last character of the string random, which was M. So this is a way of using negative indexes. And similarly, if I used test -2, it would give me the second last character, which should be the character O, as you can see here. Now there are some other important functions that you may use in Python. For that, let's create another string. Let's call it upper, lower. Alright. I'm storing it again in the same variable test. Let's see what happens when I use the upper function and what happens when I use the lower function. Now I'm going to use the lower function for this. So these two functions will respectively give us the result or give us our string in uppercase and lowercase respectively. So as you can see, the upper function created the first string in full uppercase and the second one created this string in full lowercase. Now another important and probably one of the most important methods that we use for strings, especially when it comes to data science, is the split function. So let's see what I mean by the split function. Let me create another string. Let's call it hello world. Alright. And I'm going to use a split function and I'm going to see what happens when I use this function essentially. So what I'm doing in these three lines is I'm creating the string hello world. I am storing it in test and then I am using the split function on the test, and whatever result I get, I'm storing another variable called sliced, and then I'm just going to show you what is in sliced. As you can see, what's happened to the string hello world is that I have broken it into its components, or its component words, if that makes any sense, into hello and world, and I've stored both of these into what we call a list. Now you might ask, well, how does Python know that it has to separate at a blank space? Well, the split function by default will break up a string at its blank spaces. But if we wanted, we could break it up using or at every comma. So for example, if I wrote hello world using comma, and if I put a comma inside over here, and now if I try to execute this, like for example, I'm going to look for commas in the string and then I'm going to try to split it. As you can see, there's no splitting happening. I have one list with my original string itself because it's not found a comma. What if I introduced a comma over here? Now let's see what happens. As you can see, the splitting has happened. It's found this comma and it's caused a split between hello and world. Similarly, if in my string, if I put a comma again and I put something else, it should give me the split over there again. So we can define our split using whatever we put in between these circle brackets after the split function. It's just important to note that by default, if in case we do not enter anything over here, it will use blank spaces to do the splitting. Another very important operation and very common operation in strings is what we call concatenation. So if I have two strings first and say another string second, and I want to join these together, well, the operator I would use to do this is called the plus symbol. This is the concatenating operator when it comes to strings. So what is the result of this? Let's see. Let's print this out. Let's print this whole thing and let's see what is the result. As you can see, what this has done is it has combined the string first and the string second into one string called first second. So this is the concatenation operator. Now finally, the last topic in this lesson is the topic of escape sequences. Now escape sequences are special commands that tell Python to either suppress special meaning of some character or symbol in a string, or give some special meaning to an otherwise ordinary character in a string. So let's look at the first example. Now remember earlier in this video where I was telling you like what is the way of writing, or how do we introduce single quotes or double quotes into a string, and I had told you the trick. If I want to use a single quote in my string, I just close it using double quotes, or if I want to use a double quote, I close it using single. Well, another way of doing this is using what we call an escape sequence. And an escape sequence in Python is the backslash character. Alright, so let's see what happens when I use the backslash character where I want to introduce my single quote. So if I use my previous example where I wanted to introduce a single quote and say I'm going to close it using single quotes as well. So I'm going to go back to my error example, so as to speak. Now this would throw me an error, right? As you can see, it has thrown me an error. So what if I used the escape sequence that I mentioned? The escape sequence is just backslash character. Now this is the point of the string where I want my single quote. So I introduce a backslash. Now I have my single quote and I continue writing the rest of my statement. Let's close the string. Now will this work? As you can see, this has worked. So what this has done is this backslash character has told Python to not treat this special character or the single quote, to not treat it specially and let it be as a part of the string. So as you can see, that's what's happened here. Now the next case, or the other use case of escape sequences, is when we want to give a particular character that is otherwise just ordinary some special meaning. So let's take the example of the character T and the character N. We use the character T to introduce tab space, and we use the character N to introduce what we call line break. Well, let's see by an example. So normally the character T has no special function. So the character T within a string will just be outputted as the character T itself. However, as you can see here, I'm going to introduce a backslash before this character T. Let's see what it does. It introduces this thing that we call a tab space, which is a larger than normal space. Similarly, if I were to use the backslash n combination, this would introduce what we call a line break. And if you were to see the output of this, you can see at the point of the string where I have this combination of backslash n, a line break has occurred. So there are plenty of other escape sequences that you may choose to learn, and these are just two of the probably the most common ones that I used. So yeah, this was an introduction into strings in Python. In this video, I will give you an introduction into lists and tuples. Starting off with lists. Lists are a collection of ordered or arbitrary objects that are similar to what we call an array in other programming languages, but lists are way more flexible when it comes to Python. Python lists are a type of sequence, and you might have seen what a sequence is when we were learning about strings. And much like in sequences or any other sequence, list objects are assigned a numerical index, and whenever we want to manipulate an object in a list, we use its respective index. How do we define lists? Lists are defined using square brackets. So this is a simple way or a simple list that I have just created and assigned to a variable a, which contains 3 objects, 1, 2, and 3. Let's talk about some of the features of Python lists. Python lists are ordered, and what this means is that even if 2 lists contain the exact same elements, if the elements are placed in a different order, the 2 lists are actually unique and different. And I can check that over here. I have created a list 1, 2, and 3, and say if I create another list 2 and 1 and 3, the same elements but in different order, I will use the is function to check whether these 2 lists are the same. And if they are the same, when I use the is function, it should give me the value or the answer true. And if they're not the same, it should give me the value false. And as you can see, I get the value false because even though I have 2 lists with the same elements, they are in different orders. And so they are different. And that's what we mean by lists are ordered. The next property for lists are that they can be manipulated using their indexes, or the elements and the objects inside a list can be manipulated using the indexes. And we will see that in the section where I show you list operations. The next property is lists are mutable. What this means is that once we create a list object, we can actually make changes and modify them without having to create a new list object. The next property is that lists are dynamic. And what this means is that as we are making or as we are programming, we can actually make changes to an already created list as we are programming without having to go through a compilation stage. So if we had to say increase or we had to add certain elements to an already created list, that original list grows in size to accommodate for these new elements. The next property is that lists can contain any arbitrary objects. So if I created a list right now where, say, if I want to store some numbers, say some floating point numbers now, and I can put strings as well into my list. All of these are valid when it comes to objects that can be put inside a list. We have no such restrictions, so we can put any arbitrary objects inside our list. The final property that I want to talk about is that lists are they can be nested to any arbitrary depth. What this means is that I can put a list within a list, and I can keep nesting it essentially by putting as many lists I want within my list, and I'm only essentially restricted by my system's memory. So if I created a list like this, within this, say I put another list, and within this list I put another list, I can keep going on doing this, and I'm only restricted by the memory of my system that I'm using. So moving on, let's move on and talk about some important list operations that we will be doing when it comes to lists. So let's create a basic list called A, where I'm storing 6 numbers. So now say if I wanted to retrieve a particular element, say if I wanted to find out what's on the index 3, this is how I would do it. If I wanted a slice of my original list, and much like strings, I do it the same way. So what this does is, it tells Python that I want all the elements of list A from index 1 to index 4, but not including index 4. So it will give me 1, 2, and 3 index objects. So it should give me 2, 3, and 4 in this case. As you can see here, 2, 3, and 4. I can do the same thing by considering elements, say 2 at a time. If I wanted to consider elements or consider every second element, what I would do is this syntax. I would use this syntax. And when I give this command to Python, what it understands is I want every element from A, from index 1 to index 4, but not including index 4. But I am going to consider every second element essentially. So what it will do is it will go here, and then it will skip one, and then go here, and then skip one. And that's essentially what we call slicing by using strides. So I'm taking strides. I'm not considering elements consecutively, but I'm skipping certain elements in between. If I wanted to consider every third element, I would change this to 3. And fourth element, I would change this to 4. All right. So let's see what happens when I take every second element. It should give me, it will consider, say, from 1 to index 3, right? So it should consider essentially this section. But since it's going to skip 1, it's going to consider this, skip this, and then consider this. It should give me 2 and 4. As you can see, it has given me 2 and 4. And like in other sequences, we can use negative indexes as well. Negative indexing essentially starts looking from the right hand side of the list. So when I say A minus 1, it's essentially looking at the last element of the list. So it gives me the 6th or the last element, which is the object 6. If I did A minus 2, it gives me the second last element. Similarly, another neat trick that we can use for sequences is the following syntax: double colon, and we give a -1. What this tells the system is I want the list A, but with all the elements reversed. So as you can see, I get my list A, but the elements have been reversed right now. Let's move on to concatenation and replication. Well, concatenation, much like in strings, is done by using the plus sign. So as we know, on either side of the plus sign should be 2 similar objects. So if I'm doing A plus something, A being a list, on the other side it should be a list as well. So let's add a list like this. Now let's see what's in A. As you can see, my original list has 7, 8, 9 added to it. And I can also add things to the beginning of a list similarly. So if I wanted to add, say, 0, at the beginning of a list, I just do it like this, and I get the element 0 added to it. It's very important to note that I actually added 0 within a list, because if I did 0 like this, it will throw me an error, because like this 0 is just an int object and it's not a list. But when I put the square brackets, I make it a list, and then this concatenation becomes valid because A is also a list. Similarly, if I did A star 2, this is essentially replication, or a replication function, where I'm repeating the values in A twice. If I did A star 3, it's the same function, but now I'll have the elements repeated thrice, as you can see here. Let's move on to modifying list values. This also shows the mutable property of lists that I had mentioned earlier. So let's consider this example. So I created a list with elements where there's 3 strings: eggs, apples, and carrots, and I have 5 int objects: 1, 2, 3, 4, and 5. Now if I wanted to change, say, the first element, all I have to do is take the 0th index, and say if I want to replace eggs with say mango, this is how I would do it. Now I've replaced eggs with mango. If I check what's in B, you can see the eggs have been replaced with the element mango. Similarly, I can use the slice syntax to replace a particular slice from my list with a slice essentially. So let's look at this. I want to replace the first three elements. I want to replace mango, I want to replace apple and carrot. So what I will do is, I will consider this, since this carrot is the second index, so I will consider 0 to 3 because the third is not counted. Now I'm going to replace this with three different, let's see, kiwi and say sponge. Now let's check what's in B. You can see my three elements have been replaced. In fact, I don't have to replace like for like. If I want to replace, say, three elements with only one or two elements, that is also possible. So now if I want to replace the first three elements, kiwi, orange and sponge, with just one element, this is how I'll do it. Let's say wine. Now let's check what's here. As you can see, three elements have been replaced with one, wine. I can do it vice versa as well. I can replace smaller number of elements with a larger number of elements. But here there is a slight caveat that I want to show you. So an obvious way of doing this would be, say if I wanted to replace the first element wine with three different elements, an obvious way would be just consider that element's index and then put whatever objects you want. Say I want to add, instead of wine, I want to add beer, I want to add ball and say club. Yeah, well, let's see what happens. Now if I say B, check what's inside my, you can see my elements have been added, but they seem to have been added as is. I had entered a list over here and that whole list has been replaced, or this wine has been replaced by this whole list in the first position. But that's not exactly what I wanted. I wanted the elements within this list to be individually placed into my list. And the way to do that is not this syntax, but actually what I'm going to show you now. If I want to replace one, if I want to replace the index or the object at index 0, I would give this statement, a slice statement, where I will give 0:1. So when I do this, and if I, so let's create my old scenario again, where I had wine and I had 1, 2, 3, 4 and 5. Now if I do this B0, but I give a slice, then this slice is essentially a single object slice. It's essentially the 0th index again. But because of this formatting or this type of syntax that I'm using, what Python will do is, now when I say beer and ball and club, now what Python will do is, it will not consider this whole list and add it to in place of wine or whatever I want to replace. It will actually consider the elements inside of this individually and then replace. So if you see here, now if you see my list, I actually have the, I've removed wine and in place of it I've put beer, ball and club, but these three are actually individual objects within my list and not objects within a list that is then placed within my original list. So this is an important caveat that you should take note of. So moving on, let's talk about certain methods associated to lists. Let's take a simple list now, 1, 2 and 3. The first operation that I want to show you, or the first method, is the append method. So when I do a append, and say if I want to append the list by one object called 4, I just do it like this. Now let's see what's in A. So as you can see, the append has put the object 4 into my original list. Now say if I wanted to append three different objects, I want to append 5, 6 and 7 now. Let's see what append function does. Oh no, as you can see, it's done a similar operation to what we have seen earlier when we gave a single index or the single element replacement that we saw earlier. It essentially put this whole list into this particular spot into the list. And this is not what I wanted. I wanted 5, 6 and 7 to be individually placed. And we do have a way of doing that. And the way to do that is the extend function. That is what I'll show you next. Now if I want to extend, say, the original list by three different elements, 8, 9, 10. When I use the extend function, it will not put this whole thing. It will consider each object inside this thing individually and then add it to A. So if you see my result, this is exactly what I wanted. Now the next method that I want to discuss is the remove method. So the remove method is how you use it is within the parentheses, you put the object that is present in the list that you want removed. So you don't give an index over here, you give the object itself. So if I want the object 8, alright, this number, if I want 8 itself removed, what I will do is put the value 8 here, and it will remove it from my list. So if I check my list A, as you can see, the value 8 has it's gone. Another similar function to remove is the pop function. Now the pop function by default will remove the rightmost value from the list, but unlike remove, the pop function actually outputs a value, and that value is what we have popped out of the list. So by default, it will pop out the rightmost value of a list, or rightmost element of a list, and in this case that element is 10, so it should give me 10. But of course, if we want to pop out any particular object, in this case we do not give that particular object, we give its index. So now say if I want to remove this this list object from my bigger list, as I can see, it's in index 0, 1, 2, 3, 4th. It's the 4th index. So if I want to remove the list which is at the 4th index, I give the index value inside the parenthesis, and it pops that out for me, as you can see over here. So this was it for lists. Let's move on to tuples next. So tuples are another ordered collection of objects much like lists, but they differ from lists in two key properties. First of all, tuples are defined using parentheses instead of square brackets. So this is how I would define a tuple with elements 1, 2, and 3. And the next very important property that is different, or that differentiates tuples from lists, is that tuples are immutable. And what this means is that once we create an object of type tuple, we cannot make any modifications to it. We would have to only create a new object if we wanted something different. And this is obviously a key difference between a tuple and a list. But apart from this, every operation that we have done on lists are actually possible to do in the case of tuples as well. So any operation that we did to lists that did not modify the list, or that does not do any modification, we can actually apply to tuples as well. So if I wanted the first element of this tuple, all I have to do is call it by the index 0. It should give me the value 1, as you can see. If I wanted a slice, I can do that as well. It should give me 2 and 3. And if I wanted to reverse my tuple, well, I can use my same neat technique that I've used for lists and that I can use for strings as well. So it gives me my old tuple, but with the elements reversed. So now the natural question is, why do we use tuples over lists? Well, one important difference is that when we make a program execution where we are manipulating a tuple, if we did the same thing for the exact same objects in that if it were present in a list, it would be much faster in a tuple. Essentially, program execution is just faster on tuples when compared to an identical list. So you use tuples over lists when we want to be efficient while we are creating an ordered list of objects. So whenever we create an ordered list of objects that we don't need to, or we don't want to make any further modifications to, we don't need to create a list, we can create a tuple. And another very important area where we use tuples over lists, or why we need a tuple instead of a list, is when we are using dictionaries. Dictionaries, as we will see later, is a data type in Python that needs an immutable component while we are creating the dictionary. So if we want to use something that is like a list, but since lists are mutable, we can use a tuple instead and use that when we are creating our dictionary. And we will see like what I mean by the immutable component for a dictionary when we actually learn about dictionaries. But yeah, these are some of the places where we would use a tuple over a list. A brief section on tuple unpacking and packing is what I will be doing right now. And what that means is that when I give this sort of a statement, you can assume this to be me packing this tuple into a object or a variable t. Now what's very interesting is, and this is something that's very key to tuples, is that I can unpack a tuple onto another tuple. So let me show you what I mean by that. So now that I have packed 1, 2, 3, and 4 tuple into t, let's unpack it into another tuple. Let's put these elements into this tuple, and I put this into t. Alright, now let's see what I mean by unpacking something onto something. Let's see what happens when I put a. If I just want to see what's in a, it actually gives me the value 1. If I see what's in b, gives me the value 2. If I see what's in 3, gives me value 3, and D gives me value 4. So essentially, if you think of it, what I have done is I have matched this tuple, then put it into T, and then put that tuple T into this tuple A, B, and C, D. So what has happened essentially is the element A has been, or a better way to say this would be the element 1 has been packed onto or unpacked onto A, 2 has been unpacked onto B, 3 has been unpacked onto C, 4 has been unpacked onto D. To show you what I've done in a single line is essentially this. This is essentially what I've done. I have assigned 1 to A, 2 to B, 3 to C, 4 to D. I have matched these two tuples together like this, and this is a very neat feature of tuples. The only important thing that you have to keep in mind is the elements on this tuple and the elements on this tuple should be equal. So if there are 4 elements here, there should be 4 elements here. Alright? In fact, another very important thing about, or a neat feature, is that we don't really need to mention the parentheses when we're doing this unpacking or packing. So if I did X, comma Y, comma Z, if I did it like this, if I put say 5 and 6 and 7, this is also a valid way of packing and unpacking. So now if I see what's the value in X, it is actually 5. If I see what's the value in Y, it is 6. If I see what is the value of X and Z, it should give me a tuple containing 5 and 7, as you can see over here. So this is a neat feature of tuples called packing and unpacking. So yeah, in this video we will cover concepts surrounding dictionaries. Dictionaries are another type of composite data type in Python that are also a collection of objects, much like tuples and lists. And like lists, they are also mutable, dynamic, and can be nested. However, a key difference and property of dictionaries is that they are unordered. Items in dictionaries are paired using keys, unlike in lists and tuples where the objects are assigned numerical indexes. To define a dictionary, we use curly braces. Each key value pair in this dictionary in a dictionary is separated using commas, and the key and values themselves in a pair are separated using a colon. Let's look at an example. This is a dictionary where I have 3 key value pairs. As you can see, they have been separated by colons, and each pair themselves are separated by commas, and these are enclosed in curly braces to define the whole dictionary. In this example, these are the keys: banana, apple, and grape, and their respective values are yellow, red, and green. So this is very important, that in this particular data type we have what we call a key, and that key is assigned a value, and we can have multiple such pairings, and we have 3 such pairs in this particular example. Another example, or another type of way to define a dictionary is using the dict function. This is how we use it. As you can see, I have inputted 2 value or 2 object tuples. This is a tuple, this is a tuple, and this is a tuple. And when I use it in a dict function, when I place it within a list, what Python will do is it will consider the first element of each tuple as a key and the second element of each tuple as its respective value. Now if I check what's in D, as you can see, the key banana has a value yellow, the key apple has a value red, the key grape has a value green. So this is another way of defining dictionaries. An important note over here is that the objects that we use for keys have to be of an immutable data type. So we cannot use, for example, lists as an example of keys, but we can use, say, integers or strings for our dictionary keys. Also, keys have to be unique when it comes to a dictionary. You cannot have 2 different keys with, or should I say, the same key having 2 different values. You can have only one key, and that one key will have a unique value assigned to it. Duplicate keys are not allowed. However, when we speak about values, we have no such restrictions. You can have a mutable or an immutable data type as a value in a dictionary, and you can have duplicates as well. So, if I created a dictionary with a key, say, banana, and if I associated with it a value green, I cannot create another key banana and associate a value yellow. Let's see what happens when I actually do this. If you actually see, what has happened here is Python has considered the second case. So it first looks at the first pair, it goes, okay, so my dictionary has a key banana with a value green. But right after it, it sees another key banana with a value yellow. So it overwrites my first key banana with the second key. And it overwrites the first value green with the second value. And we essentially get one key banana with the second value yellow. So obviously, this is Python does this to avoid duplicacies. However, if I created a dictionary with a key banana again, if I gave it a value yellow or say green, if I created another key and if I gave this also a value green, this is perfectly fine, and this will nothing special will happen in this case because values do not have to follow such rules. Let's see certain dictionary operations and functions now. So let's bring back our original dictionary which we had created earlier with the 3 pairs. Alright. So what if I wanted to, we can use keys to essentially do these operations and functions. Let's see what happens when so much like how we use indexes in example of sequences, we use keys when it comes to dictionary. So let's see what happens when we use a key over here. So as we know, banana is a key in this dictionary. Let's see what happens when we give this command. It actually gives the value associated with that key, which is yellow. What if we wanted to change a particular value associated to a particular key? I would do this. I would give the key and assign it the value that I want to change it with. Alright. Now if I check my dictionary, you can see the key banana no more has yellow value but the value gold. What if I wanted to add a new pair? A new key with a new value completely. I would do it pretty much the same way as I did in the previous step. I would essentially write my new key, whatever I wanted. Say if I wanted a new key called watermelon, I would assign it a value red. And now if I check my dictionary, at the end of the dictionary, you will see that my new key value pair has been added, watermelon red, as you can see over here. Now what if I wanted to remove a key value pair from my dictionary? I can use the delete function, which is called by using the del function. Now how do I do it? Say if I want to remove the key value apple and red. So all I have to do is do del, d, and within square brackets, I have to only mention the key. I don't even need to mention the value, just the key. So you can probably draw parallels in how we use indexes when it comes to lists and tuples and even strings, and how we use keys when it comes to dictionaries. They are quite similar. So if I did this, and if I, I think red is actually not a key. As you can see, red is a value. My key is apple actually. It's not red, it's apple, as you can see. Now if I see my dictionary, the key apple and its value red has been removed. So these are some of the operations that we can do for dictionaries using keys. What if we wanted to use certain inbuilt functions that are associated with dictionaries? Well, some of the examples are as follows. There is a get function. When we use the get function, all we have to do is enter a key inside the parenthesis, and it will get the value associated with that key. So if I gave the key grape, let's see what value is associated with it. As you can see, it's green. There is also a function called items that returns the key and value pairs in our dictionary as a list of 2 object tuples, where the first object is the key and the second object is a tuple. So let's see what it does. As you can see, it gave me a list, and in this list the objects inside the list are 2 object tuples, where the first object is always the key and the second is the value, and it's the same for each of the tuples. So this is what items function does. Let's see what the next function is keys. Let's see what the keys function does. As you can see, it returns a list of all the unique keys within our within our dictionary. Similarly, there is a function for values as well. And as you can see, it returns all of the different values that are present in our dictionary in the form of a list. Also, it's important to note that if we have a particular value that has occurred multiple times in a dictionary, it will appear as many times it has occurred in the dictionary or appeared in the dictionary in our list over here when we use the value function. So if, say, a particular value, say I had another key where its value was green again, so I would have the value green appear in this list once more, essentially. Our next function is pop item. What this does is, much like the pop function in lists, it gives us the last entered key value pair that is present in our dictionary. So the last entered pair was watermelon, key watermelon with the value red, and that's what has popped out when we give this function. Another important function associated with dictionaries is the update function. And the update function is a very neat function that is used to merge two dictionaries together. So say if I had a dictionary, let's say I'm creating a dictionary using the dict function where I have, say, some key called kiwi. So as I had mentioned, I will use two object tuples in this case. And let's say I give this also a value green. All right. And another pair would be, say, mango, and let's give it a value yellow. All right. So this is another dictionary that we have created. As you can see over here, we have created a dictionary with a key called kiwi with value green and another key mango with the value yellow. And I already have a dictionary D with these values. All right. Now, if I want to merge these two dictionaries, I can use the update function. What I do is, say if I want to merge D with X or X with D, only the ordering will change, and that doesn't really matter when it comes to dictionaries. So if I want to merge D with X, I use D update, and then inside it I put my target dictionary. Now when I check what's in D, I have the dictionary X and its key value pairs merged inside my original dictionary D. As you can see, I have my original ones here and I have the merged ones over here. So this was the update function. In this brief video, I will explain what we call the type hierarchy or the standard type hierarchy in Python. It's also known as the data model in Python, and it probably has other names. So essentially what we do or what we speak about in this is how the different types that we use in Python are categorized and classified and what are their subtypes. So it's important to note before we continue further that in future versions of Python, there might be new types that are introduced or the existing ones may be modified. But it's safe to say that what I will speak about in this video will still form the core of what we call Python standard type hierarchy. So let's begin. So the first type is the none type. It's accessed through the built-in name none. Its truth value is false. It's essentially used to denote functions, or it's returned as the value for functions that don't really return anything. So if you have an expression or a function that returns no particular value, you actually get a data type called none. That is how Python interprets it. Then there is the ellipses. Ellipses is something that you might encounter later. It is accessed through the built-in name ellipses. It is used to indicate the presence of this particular syntax, this particular symbol or expression or syntax in a slice. Its truth value is true. Again, don't worry too much about ellipses right now. Next is numbers. And numbers is something that we are very familiar with. We've worked with numbers a lot. They are an immutable type. They are created through numeric literals, and they are the outputs of arithmetic expressions and built-in arithmetic functions. Its subtypes are integers, floating point numbers, and complex numbers. Within integers, you have plain integers that represent numbers in the range this number and this number. So this number is basically the largest positive value that you can represent using 32-bit notation in 2's complement, and this is the equivalent for the negative side. Long integers, on the other hand, are used to represent numbers in an unlimited range that is only subject to the available memory of your system. So these are two types of integers, and as we know, floating point numbers represent machine level double precision floating point numbers, or numbers with a decimal point and a component after that. Complex numbers are numbers that contain a floating point number that represents a real part and a floating point number that represents an imaginary part. So these are the types of numbers. Then we have sequences. Sequences are finite ordered sets indexed by natural numbers. So each element in a sequence has an index, and that index is a natural number. The different types of sequences are based on the mutability, whether the objects can be changed or not is essentially what we mean by mutability, right? Once we create an object, whether we can modify it or not. That is how we differentiate different types of sequences. So there are mutable and there are immutable types. The different types of immutable ones are strings. We know what strings are. They are sequences that contain characters. Unicode is the other immutable sequence, and then there are tuples. Tuples are a collection of arbitrary Python objects, and Unicodes are sequences that contain Unicode characters. Then we have mutable sequences, and there is only one. Currently, there is only one built-in mutable sequence in Python, and that is lists. Lists are also, again, collection of arbitrary Python objects. Finally, we have, well, not finally, but next we have mappings, and mappings are, again, sets of objects, but these objects are now indexed using arbitrary index sets. You know, the difference between a mapping and a sequence, you could consider sequences are ordered, but mappings are not ordered, and the indexes given to the objects in sequences are always numbers. They're natural numbers, whereas in mappings, they are not natural numbers, but they are certain arbitrary objects that we can set for ourselves. Again, in Python, there is only one built-in standard mapping type, that is the dictionary. Dictionaries are they represent finite sets of objects indexed by nearly arbitrary values. The only condition is that these indexes must be of an immutable data type. So these, so what I have mentioned until now are probably the most common data types that we encounter, or that we have encountered now. The next types are like callable types, such as user-defined functions, user-defined methods, built-in functions, built-in methods, classes, and class instances. So again, callable types as a whole are referenced using the call function, and this is something that we will learn when we start learning about functions, when we learn about object-oriented programming, and methods and functions and such. The other type are modules. So modules are module objects, or modules essentially are referenced or called using the import function. Again, modules can be considered as these large libraries or larger pieces of code or applications that we that contain various different methods and functions and objects and classes within them. Again, modules are something that we will think about a little later. Files are data types that are called using the open function. So anytime we, and as we will during the course of this tutorial, during the course of this course essentially, we will be working with a lot of files. Some of these files are text files, some of them are comma separated files. So all of these files that we open using the function open or some other certain specific functions where we create file objects out of these files. These are what we call file data types. Finally, there are internal types that are used by Python interpreter. Again, this is something that does not concern us right now, but just know that the interpreter for Python uses these data types for its functioning. So this was a very brief introduction or explanation into Python type hierarchy. In this video, I will show you some of the categories of operations that are possible in Python. So let's start off. So the first category of operations are arithmetic operations. And as you can see in this table, there are different types such as addition, subtraction, multiplication. So let's go over them one by one. So a simple addition operation would be like 5 plus 6, giving me the value 11. I can do 5 minus 3, that's subtraction. Similarly, I can do a multiplication using 5, say 5 into 2. There's division where I use the backslash. So say I did division of 8 divided by 2. Now you might encounter another type of division which is called the floor division, where we use a double backslash. And what this does is it returns us the largest whole number that is lesser than the result of our division. So the difference between the float division and the normal floored and the floor division or the single and the double backslash is this. Say I did 9 divided by 2 using a single backslash. It should give me, as you can see, 4.5, right? So this is the actual value. Now let's see what happens when I do 9 double backslash 2. It will give me 4, which is the largest number lesser than or equal to 4.5. That is also a whole number. So this is what we call floor division essentially. Finally, we also have, if we want to raise something to the power or something. So if I want to do say 6 raised to the power 3, so I would use double asterisk, and this is how I would do it. It will give me 216, as you can see. If I wanted remainder between the division between two different numbers, I will use the percentage sign. So if I wanted the remainder of the division between 7 and 3, this is how I would do it. I get the answer 1, as you can see. So the next category of operations are logical operations. The first one is the logical AND operation, where we use the operator AND. Alright, so let's see what we mean by this. I am creating, so as we know, the AND operation returns the value true if both the operands are true. So let's actually do this for an example. Let's give this variable the value true and this the value false. Actually, it should be done like this, true and false. So now think of it like 1 and 0. So 1 and 0 is obviously 0, right? So if I did A and B, I should get the answer false or 0 because I'm doing true and false. So it's like doing 1 and 0. So if you see this, I should get the answer false. If I change this to true as well, now if I do this, I will get the answer true, as you can see. The next logical operation is the OR operation, where, logical OR is if either of the operands are true, then we should get the answer to our OR operation as true as well. So in this case, obviously, if I did OR over here, it will naturally give us true. If I change this to false, it should again give us true, and it will only give us false if both are false, as you can see here. Now it's false. The next operation is the logical NOT. It's done by using the NOT operator. So in this case, the value that we get is true if the operand is false. So let's take A. As we know, A is false over here. So if I did not A, I should get the answer true. But if I change this to true, now if I do not A, I should get false, as you can see. So this was the logical operations. Let's move on to the next set of operations, that is comparison operations. So there are a bunch of them. Let's go over them one by one. If I want to check if two operands are equal, so if I did x is say equal to 2 and now y is equal to 3. If I want to check if they are equal, I will use the double equals to sign. And if they are equal, I will get the value true. If they aren't, I'll get value false, as you can see, since x is 2 and y is 3. As you can see, x and y are not the same, so there's false. They are not equal. If I change this also to 2, now I will get the answer 2. The next comparison is the not equal to, or where we use the exclamation sign. So over here, the result of this is true if x and y are not actually the same. So I should get false over here, as you can see. But if I change this to say 5, now I will get true because x is not equal to y in this case. The next one is greater than. So if I did x greater than y, as we can see 2 is not greater than 5, I will get false over here. Similarly, there's a lesser than. If I did x lesser than y, I should get true over here, as you can see. There's also a greater than or equal to and lesser than or equal to. We simply add the equal to sign here. So let's see. Now if I say x is lesser than or equal to 3, I should get true because x is 2. And if I put 2 here, I should also get true. But what if I put 1 here? Since x is equal to 2 and 2 is not lesser than or equal to 1, this is a false statement. And I can do the same thing with like this, using the greater than equal to. Now it's true because 2 is actually greater than equal to 1. And so this was comparison operations. The next set of operations that we can do in Python are assignment operations. We've already seen a whole bunch. We've already been assigning values to variables. We've been doing assignments throughout already, but let's go over them and see some of the assignment operations. So as we already know, the equal to operation is assigning everything that is on the value on the right hand side of the equal to sign to what is on the left. So if I did a is equal to 5 plus 6, it will assign the value 5 plus 6 or 11 to a. Let's check what's in a. As you can see, it is 11. There is a plus equal to sign, and what this does is, so for example, if I did say a, now since a is 11, let's create another variable called b and call this 5. Alright, so now if I did a plus equal to b, what this will do is it will add b to a and then store it in a. So let's see what this does. Once I do this, now let's check what's in a. It should be 5 plus 11, as you can see, 16. So this a plus, so this plus equal to sign is essentially the same as doing a is equal to a plus b. It's essentially the same thing. They're both the same. There's a similar thing for this, the negative or subtraction as well. Minus equal to. So now that a is 16 and b is still 5, of course, if I did minus equal to b, now I'm subtracting the value 5 from 16. So I should get a is equal to 11 again, as you can see here. And this is the equivalent of doing a minus b. A is equal to a minus b, I mean, as you can see. So the next similar like assignment operation, let's create a is equal to say 6 in this case, and say b is equal to, I will say 2. Alright. Now if I do a star equal to b, what this does is it multiplies b to a and then assigns it back to a. So if I see what's in a now, it should be 12, as you can see here. Similarly, there is similar thing for subtraction as well. So if I did a is equal to 6 and b is equal to 2, if I did for division. So if I did a division symbol and the equal to sign, and then if I give b, what it will do is it will divide a by b, or 6 by 2, and it will assign that back to a. So my value in a should be 3. As you can see here, 3.0. Obviously, this is a single backslash, so this is a float division. The resultant of a single backslash is always a float. I can do the same thing with a double backslash. So let's see if I did a is equal to 7 now, and then b is equal to 3. Now, if I did a double backslash equal to b, now it will do the same division, but it will do a float function. So it should give me 2 in this case. If I did the same thing with a single backslash, just to show you the difference between single backslash and double backslash division, in this case it will give me the value around 2.3 or something, a float basically, 2.33, as you can see here. Then there is the modulus. You can use the modulus sign as well with this assignment. Say a is equal to say 5 now, b is equal to 2. Now if I do a percentage symbol equal to 2, I mean b, it should give me, it will assign the, it will take the modulus in both sides and then assign it to the left hand operand. Now let's see what's in a. As you can see, it did a divided by 2. The modulus symbol is basically the remainder of the division between two objects. So in this case, it will divide a by b and then give me the remainder and then put that remainder back in a. And as you can see that the remainder of 5 divided by 2 is 1, and we get that over here. Similarly, we can also do exponential. So if I have a is equal to say 5, b is equal to 2, and I want to raise a by, if I want to raise the value of a by the value of b and then store that back in a, this is how I would do it. So it should be 5 to the power 2, which is 25, as you can see here. So this is assignment operations. So finally, we move on to two special sets of operators. One is the identity set, identity operators, and the other is the membership operators. Let's look at the identity operators. So when we talk about identity operators, what we mean is the is and the is not operator. So what the is operator does is it checks whether two operands have the same location in the memory essentially. This does not mean that it does not check for whether two objects have the same value, and this is very important. So let's look at this. If a is equal to 1001 and b is equal to 1000 plus 1, alright? If I did a is equal to 2, this is an equality check. Are they the same values? True. Now if I say a is b, let's see what happens. As you can see, it's false. This is because this object and this object are not the same, and this is what the is operation does. We can confirm this by checking the ID of a. The ID of a gives us some value like this, and the ID of b gives us, as you can see, a different value. So the two objects are not located in the same place in the memory, as we have seen using the ID function, and that is what we check through the is operator. And the is not is essentially just the opposite of that. So that is the identity operator. Now the membership operator is used for checking whether something is present in a sequence or not. So let's create a sequence. I will create a list to show in this example. My list is 1, 2, and 3. Basically simple list with 3 integer objects, 1, 2, and 3. I will check whether now say 2 in A. So is 2 in A? If it is, it will give me true, as you can see. Is 5 in A? It should give me false because 5 is not in A. And the not in operator is just the opposite of that. It checks the other condition essentially. So this is the membership operators in Python. In this video, I will be speaking about what precedence or what importance each operator has when you use multiple of them in a particular statement or a command. This is what we call operator precedence. So of course there's confusion when we don't know which operator has precedence over the other. And in Python, there is a strict precedence that is followed in such scenarios. So this table gives us the precedence. So as we can see, the operators at the top are at the lowest precedence. And as we go down, we get operators with higher precedence over the ones above them. So the low of the operators that we have seen, the OR operator, the AND, and the NOT have the lowest precedence. So OR, AND, and NOT, and then we have comparisons and identity operators such as the equal to sign, the exclamation equal to sign. So these operators come at the next level. Then you have addition and subtraction followed by multiplication, division, modulus, and floor division. And finally, the highest precedence of all the operators that we have seen till now is the exponentiation or the double asterisk. So let's see a couple of examples that explain this point a little more. So as we can see in this line, we have 20 plus, then there's a 5 and asterisk 3 minus 25. And we want to know like, okay, what is the precedence in this case? So as we know, we have the plus sign, we have the minus sign, and we have the asterisk sign. So we have addition, subtraction, and multiplication. So which one will take precedence over the other? Well, let's refer to this table. As you can see, the addition and subtraction have lesser precedence over multiplication. So this multiplication will happen first. So we actually do 5 into 3 first. We get 15. After that, we do plus and minus. So we get 5 into 3, 15. Then we add it, or we can subtract it with 25. That does not matter. So we do 5 into 3, 15. And then we do 20 plus 15, which is 35 minus 25. So we should get an answer 10. As you can see, we do get the answer 10. Another example would be where we have this plus symbol, we have a double asterisk which shows exponentiation and a subtraction and a division. So again, as we know, exponentiation has the highest precedence. So in this whole operation or this whole expression, we first do the operation associated with the exponential. So we do 5 to the power 2 or 5 exponentiated by the power 2. So we have 5 to the power 2, which is 25. Now we look at, okay, once we have that, we still have a addition and we still have a subtraction and we still have a division symbol. And as we know, division takes precedence over addition and subtraction over here. So once we do this, we finally move on to this step where we do the division of 6 divided by 2, where we get 3. So we have 25 from this, 5 to the power 2, which is 25, and we have 3 over here. So now we do 20 plus 25, which is 45, minus 3, which is 42. And then as you can see, that is the answer over here. Let's look at the precedences when it comes to certain comparisons or the logical operations or the comparison operations, so as to speak. So I've created a variable called season with the string summer. I've created the variable age with the value with the string 10. So you don't need to put it in a string. So I have the int object 10. And I have the color, a variable called color with the string pink. Now I'm going to see in this line, I'm going to do an if and else statement. So if you don't know what an if and else statement is, just follow along with me. So what this does is, if this condition is met, I will print this statement. Otherwise, else, I will print this statement. Now what is this first condition? It is saying season equal to summer, whether this variable is equal to the string value, or as we know about the OR operation, age is equal to this and color is equal to pink. So as we can see in our comparisons and our logical operations, the precedence for OR and not is OR is the lowest precedence, and is above that, and then not is above that. In this we have the or and we have the and. So of course the first check is the and function. So it's going to check whether this whole condition and this condition are it's going to do that operation. So it's going to do this and this. So is color pink? Color is indeed pink. Okay, so this part is true. Now let's see if this part is true as well. Now once we're going to check whether this is true or not, what we need to see is this condition itself has an or statement. So the first part of it is saying, is season summer? Season is indeed summer, as you can see here. Next part is saying, is age greater than 0? But this does not matter, since the or function just needs one of the operands to be true, and in this case this is true. In this case it is also true. So this whole statement is true as well. So once we have this statement as true and then this statement as true, we finally move on to, we come back to this and statement, and we say, since both the operations, or both the operands I mean, are true, the resultant of this and should also be true. And since this is true, this whole condition, we actually move into this section of our if-else condition, where we say, okay, we can do this statement, this print statement, and we do not have to print this particular thing. So our answer should be, our result should be the printing of this string okay. And as you can see, the okay string is actually what is printed over here. So this is an example on operator precedence. Of course, it always helps to, try to fiddle around on your own, create random expressions out of the top of your head, and see how exactly Python is evaluating that, and try to understand and break it down on your own. And this is probably the best practice you can do to understand operator precedence. In this video, we will be looking at the math module in Python, and we will look at some of the math functions that are associated with this module in Python. So starting off, what is this math module? Well, the Python math module is an important library or a feature that is designed to deal with mathematical operations. This math module is part of the basic Python installation, so you don't have to install this separately. To use this math module, all you have to do is import this module, and this is how you would do it. You just do import math, and this will import your math module for you to use in your programming. And in the course of this video, I will be showing you certain concepts surrounding the math module, such as what are the constants that come with the math module, some of the arithmetic functions, the logarithmetic functions, power functions, and even trigonometric functions that we can do using this math module, and the functions inside the math module. So starting off, let's look at some of the constants that are part of this. So as you can see, the standard constants that are available in this module are pi, there is tau, there is Euler's number, NaN, which is a special, it's a programming specific concept, and infinity. So let's look at these one by one. So starting off, our first constant is pi. Pi is, as you know, in maths, it's the ratio of a circle's circumference to its diameter, and pi is an irrational number. The value of pi is 3.14 something. Since it's an irrational number, we cannot define it in terms of a specific fraction, but it can be approximated to the fraction 22/7. So how do we access this pi constant? Is as simple as this. Once you have imported maths, the maths module, all you have to do is do maths.py, and it will give you the value, as you can see. So as you can see, the value returned to us is a float. This is important to note. And the number of decimal digits, the number of digits after the decimal point that we can see here are 15. And this is like a by default thing for Python, that if you call the pi constant, it will give you the value of pi correct up to 15 decimal points. So an example of where we can use this thing is, say we have the radius of a circle 3, it can be in any units, 3 meters or whatever you want, and you want to find out its say circumference. So as we know, the circumference of a circle is 2 pi r. So if I had to find the circumference of a circle in my code for some application with the radius 3, all I would have to do is use the formula 2 pi r, and to call the value 2 pi r, instead of specifically writing 3.14 something, I can just use this function math.py over here, and then I can enter the r. As you can see, it will return me the radius, as you can see. So moving on, the next constant that we will talk about is tau. Tau is similar to pi. In fact, tau is the ratio of a circle's circumference to its radius. Pi is the ratio of a circle's circumference to its diameter, and tau is the ratio of a circle's circumference to its radius. It's important to note this difference. So because of this definition, tau is always 2 times the value of pi. This is by definition. And much like pi, if you call the tau constant from the math module, it will also return you a float number. And to find that, this is the function that we use, or this is the syntax. So as you can see, this is actually 2 times the value of pi, 6.283, and even this is returned correct up to 15 places to the right of the decimal point, and this is by default. Next constant is the Euler's number. The Euler's number is it's one of the most widespread constants used in the world of in the scientific community, in the mathematical community. You will be using the Euler's number probably a lot as if you move into data science or AI or something like that. So what is the Euler's number? It is the base of the natural logarithm. If you know what the natural logarithm is, it is used to calculate rates of growth or rates of decay. And as with numbers or constants like pi and tau, even the Euler's number is an irrational number with infinite decimal places. The value of the Euler's number, in short, it's denoted by the small letter e. So this value of e is usually approximated to around 2.718. So how do we call this constant? Is simply as math.e. This is how we do it. So you get this value. Again, this is also a float, and it's correct up to 15 decimal places. So the next concept that we will be talking about is infinity. Now infinity it's more of a mathematical concept, and this is very important to note because infinity is not really a number. There is no number called infinity. It is used to define something that is infinitely large or infinitely small. So positive infinity is something that is higher than any known number to us, and negative infinity is lower than any known number to us. So this is the concept of infinity. And how do we call this function? Well, so let's see what happens when we call the math constant infinity. So this is how we do it. And as you can see, it will return us this, it might look like a string to you, but this is actually a special type in Python, which is not a string. This is also a float. It's a type of a float. In fact, this infinity value, it's like a special data type. It's a special data type that you can consider as an equivalent to a float, but it's not a typical float that we know, like 3.14 or 2.71. The value of math.inf will give us INF, and this INF is actually not a string, so we can confirm that over here. As you can see, when I check the type, you see it's actually a float. In fact, this was recently added in Python 3.5, a special type known as math.inf. It returns this INF data type, which is equivalent to a float. So this is how we use infinity. If you wanted to get the value of, say, minus infinity, all you would have to do is math.inf with a minus sign preceding this constant, and you will get minus INF. Now let's check if the concepts or the properties of infinity are maintained. Like a positive infinity is greater than any number that we know, and negative infinity is greater than any number that we know. So let's just confirm this. So I will take math.inf and I will do a check. Is this greater than, say, some really large number? Something that comes off the top of my head immediately. Okay. So let's see if this is true, then this is conceptually correct. And as you can see, it is true. In fact, I can change this number to anything as large as I want. This will be true because infinity is larger than any number that we know. And similarly, if I did minus math.inf, and I checked some very small number, a very, very small negative number. So just consider some minus 10 to the power something, right? This should also be true. Sorry. It should be a smaller sign symbol. This should also be true because I'm checking minus infinity. It's smaller than any known number to us, and it is true, as you can see. So it's very also if you did something like, so let's say if we do let's add something to this. It's a number, so we should be able to do arithmetic on this. Let's actually see what happens when I add, say, 10 to positive infinity. it actually gives us the same value back, infinity, because intuitively we know that infinity plus anything is still going to be infinity, right? And this is exactly what Python does for us. Even if we add a number to this math.inf, or the infinity constant in Python, it will still give us the same value, the same data type of inf or infinity. Similarly, if we subtracted something from the negative of math.inf, let's say minus 100. So if we subtract something from minus infinity, we're technically still minus infinity itself. So this will again give us minus inf, as you can see, and this is absolutely what we need, and this is a very, very interesting feature in Python. Finally, the last constant that we will discuss is the NaN, or the not a number constant. So this is not really a mathematical constant. There is no constant in maths called not a number. This is a computer science related concept that it's used to denote invalid inputs, or it's used to indicate certain places where, say, a variable that should have a number, it's been corrupted for whatever reason, and it now has a text or a symbol, and our code throws an error. Then in these cases where Python expects a number from us or from your code and it does not get it, it will throw you a NaN value, and this is usually used in cases where you have errors in your code. So again, just to check like what this constant, how to call it, this is how you actually do it: math.nan, and it will give you a data type called NaN. Also, much like the infinity constant, let's see what's the type of this constant. Again, it might look like a string to you, but of course this is not a string. This is a numerical concept, and as you can see, it's still a float. So this is like it's another special data type that was created for specifically this case, where it's the equivalent of a float, but it's not really the typical float that we associate with. So this was constants in the math module. So our next topic will be arithmetic functions that we can do in the using the math module. So some of the common arithmetic functions that are available to us are factorials, the ceiling operation, floor operation, there's permutations, there's combinations. You can find the greatest common divisor, or the GCD, and the LCM, or the least common multiple, and you can truncate numbers. So let's look at them one by one. So starting off with the factorial operation. The factorial operation is done using the factorial function, as you can see here. Actually, it's defined like this: math.factorial. Alright, so now what we pass in between the parentheses will be what we calculate the factorial for. As you know, factorial is always for a positive integer, and the factorial for, say, a number 10 would mean 10 times 9 times 8 times 7, so on until the number 1. Obviously, factorial is only defined for positive integers. It is not defined for negative values, or and it's also not defined for decimal values. So let's look at an example. So as we know, so let's say we pass math.factorial for 6, and let's see what's the value. So this is exactly what we expect. So we expect the value of 6 times 5 times 4 times 3 times 2, that is actually 720. Let's see what happens when we pass 0. This should give us 1, since we know 0 factorial is 1. Now let's see an error case where we pass, say, minus 5. As you can see, this will throw us an error because factorials are not defined for negative numbers. Now moving on, so the next function that we'll talk about is the ceiling function. So the ceiling function is defined using math.ceil, as you see here. So again, we pass the number that we want the ceiling for in between the parentheses. So what is the ceiling function? It gives you the it gives you the smallest number that is greater than or equal to what we pass over here. So for an example, if I gave you 6.6 and I asked you, okay, what is the ceiling function for 6.6? It should give you 7, because 7 is the largest integral value that is greater than 6.6 or equal to it. Obviously, if you give the ceiling function for an integer, it will give you the integer itself. So let's look at an example, 7.8. So this should give me the value 8, as you can see here. Let's look at another negative number. So minus 12.3. An integer that is greater than minus 12.3 is minus 12, the smallest integer that is greater than minus 12.3, and this should give you 12, minus 12, as you can see here. A similar function is the floor function, which is defined like this. Again, the floor function, what it does, it gives you the greatest number that is smaller than whatever value we pass between the parentheses. So if I gave it 2.3, it should give me the value 2. Again, if we pass integers, it will just give us the integer itself. Again, just to reiterate, this ceiling and floor functions, they give you integer values. So the floor function will give you the largest integer that is smaller than what we pass over here. So let's look at 6.7. So the largest integer that is smaller than 6.7 is 6. And as you can see, this is our answer over here. The next function that we will look at is the truncate function. The truncate function is defined using this. Truncate is very similar to what we have seen. This is how we define the truncate function. It is very similar to the ceiling and floor. In the truncate function, what we do is we pass a decimal value, a float number, to the between the parentheses, and what we get back is the number without the decimal component, so only the integral component. So if I gave it 7.8, for example, it will give me only the 7 part. It will return me only the 7 part, and it will chop away the 0.8 part. If I gave it minus 12.3, it will chop away the 0.3 part and give me only minus 12 back. So let's look at an example. 8.9. It should give me only 8, as you can see here. Say I did minus 8 or minus 6.9. It should give me minus 6. So you can think of truncate function as it does the floor function for positive values and it does the ceiling function for negative values, because it rounds down and rounds up respectively for positive and negative values. So now let's look at the next set of arithmetic functions. Let's move on to permutations. Permutations are defined using this, as you know. So in between the parentheses, I have to pass two values, n and k. So I have to pass an n and a k. The k has to be lesser than or equal to n, because the permutation, as you know, is the number of ways in which we can permute from n objects, k different objects. So what this mathematically, what this is permutation of n and k is n factorial divided by n minus k factorial. So if I pass, say, 10 and 6, it will give me the permutation of 10 and 6. So let's look at what's the value. As you can see, it's this very large value, 151,200. Similarly, there is a combination function, and this is combinations and permutations are used a lot in probability. So if you're going to move into that sphere, which you will encounter a lot in machine learning AI, you will be using these functions quite a bit. So the combination function, again, you pass an n and a k. Again, the n should be greater than or equal to this k. What this evaluates is n factorial divided by n minus k factorial times k factorial. So again, this is a mathematical concept. So let's look at the the combination of 10 and 6. So as you can see, it gives me 210, which is the combination of 10 and 6. In the arithmetic function section, are GCD and LCM. As we know, GCD is the greatest common divisor, LCM is least common multiple. So as of the newest version of Python, in Python 3.9, the math module gets these two new functions that were very lately added, actually. Since I cannot show you that because I don't have the absolute latest version of Python on my system, but using the math.gcd function, this is the function, and in between this, what we would do if we had the latest version is we would pass two numbers, or as many numbers in fact, and what this function would do is find the common divisor amongst them. So if I gave these, say for example, if I gave these numbers, it would give me the value 10. Similarly, the LCM function, again added in Python 3.9, finds the common multiple amongst whatever we pass over here. So if I passed, say, 20 and 30, this will give me the value of 60, which is the LCM of 20 and 30. So again, these are it's something neat that if say you have Python 3.9 or if you have Python 3.9 or after that, you will have access to these functions as well if you when you import the math module. So that was for the arithmetic functions. Let's move on to the next section, which are power and logarithmic functions. So let's start off with the power function. There are multiple ways you can actually do a power function in Python. So you can do something like this, which is the equivalent of 2 to the power 3, or you can use the inbuilt module math, and you can use the POW or the power function, which is, this is how you do it. And if I had to do same, 2 to the power 3, I would just pass 2 and 3 as arguments like this, and it should give me the value, as you can see, 8 over here. What if, so there's actually one more function, which is simply the POW function, and this is not part of the math module. It's a function not part of the math module, but it's still part of the base Python. You can use this as well, and you can do the same thing. POW, 2 and 3, it should give you the value 8 again. Now you might ask, what's the difference between these two functions? Well, it's not much. For at least in a beginner standpoint, it's not that much. Just note that the math.power function is slightly computationally faster than the simple power function. So yeah, moving on, the next topic would be the next function that we'll discuss is the exponential function, which is defined like this. Again, exponential function is again e to the power something. So if I did exponential of 3, this would give me e to the power 3. So as you can see, oh, of course, I did not define the module beforehand. So math.exp, now when I do this, it'll give me some value, which is basically Euler's number or e to the power 3. So this was the exponential function. And let's look at an example. So we will look at the example of rate of decay, and we will use this function in that example. So the exponential rate of decay is used to calculate the amount of radioactive elements that is present in a substance after a certain amount of time. So the expression is something like the initial amount of radioactive elements that were present right at the beginning times the exponent of -693 times t for time divided by the time period, the half-life time. So let's just write it down to make it simple. So again, as you can see, so this will give me the remaining amount of radioactive elements, right? So let's write down remaining. Let's assign this to a variable remaining. So the initial, again, initial is the initial amount of radioactive elements. So let's give it some value, say 100. The time, let's assume it's 10 years. And let's say the half-life is around, I don't know, let's give some value, say 3 or something. Again, this is the details are not important. So this will I'm using the math.exponential function over here, as you can see. And for these values, now when I check what's the value of remaining after I calculated it, it's something. So it's basically what this tells me is that I started off with 100 units of some radioactive element, and in 10 years, this is what is left. So yeah, so this is how we would use, say, the exponential function in a particular example of ours. So next type of, again, functions are logarithmic functions. So let's look at some of the logarithmic functions that are part of the math module. So basic log function would be written like this, math.log. In between this, I would pass the number that I want the log for. By default, if I just pass one number, it will calculate the log of 8 to the base of e. As we know, e is the Euler's number. So let's see what it does in this case. It gives me some value. What if I wanted to specify a particular base? Well, I would pass a second argument in this case. I want to find the log of 8 to the base 2, and this should be the value 3, as you can see over here. There are two specific functions that are also provided in this math module, that is log2. What this will do is, again, I have to just pass one argument, and this will automatically find the value of the log of 8 to the base 2, as you can see here. Similarly, there is a math.log10 function. If I did this, I will find the value of something here to the base 10, as you can see. So this was logarithmic functions. Then finally you have the square root function. So how would we use the square root function is math.sqrt. Again, we pass what we want over here. If we want the square root of, say, 49, this should give me the value 7, as you can see. Finally, we move on to the final set of functions that we can do using this math module. They are trigonometric functions and they are hyperbolic functions. So let's start off with some of the trigonometric functions. As we know, we can do sine, we can do cosine and tan, some of the basic functions. The way we would do it is math.sine. In between this, this is to calculate the sine of a particular angle. And this angle must be passed in radians. This is very important to note. We do not pass it in degrees, but in radians. So if I say passed sine of 3.14, as we know, 3.14 is an approximation of the value pi. Sine pi is supposed to be, in fact, it's supposed to be 0. So let's see. We get something close to 0. Again, since this is an approximation, it won't give us the exact value. Similarly, we can use math.cos to find the value of a particular angle. If you want to find the value of the cos of a particular angle, we can use the tan function in case we wanted to find the tan. Similarly, we have the next set for arc sine and the arc cosines of the certain angles. So to find the arc sine, for example, we would use a sine. For arc cosine, we would use this, and for arc tan, we would use this. The next set would be hyperbolic functions. Again, hyperbolic functions are basically the sine and the cosine and the tan calculated not circles but on hyperbolas. Again, the details you don't have to know the details. You should know that if we wanted to say, for example, find out the hyperbolic sine of an angle, we would use math.sine h, and we would pass what we want in between this. Similarly, if we wanted to find the cosine, it would be cos h, tan, it would be tan h, and if we wanted to find the inverse of the hyperbolic inverse, what we would do is use a. So we would use a tan h. If we wanted to find the hyperbolic inverse of sine, we would use a sine h, and similarly for cos, it would be a cos h. So this concludes our video on the math module in Python and some of the math functions surrounding this. In this video, we will learn about conditional statements, and we will learn about how do we create these control structures where we have these conditional statements. We will learn about the keywords that we use in Python to create a conditional statement block, the if keyword, the elif keyword, and the else keyword. We will also learn about indentation and its importance in Python. So let's get started. So the basic syntax, if you will, for a if statement in Python consists of the keyword if followed by an expression. As you can see from this pictorial, there's an if statement, there is a expression, there is this block of code which, if you can actually see, is slightly indented to the rest of the code, and then we have the rest of our code after that. So what we're looking at is this. So this is our if statement block. Now let's break this down. So what is this expression that we're speaking of? An expression in this context is a Boolean expression which evaluates to a true or false statement. So when we are speaking about the if statement, we have an expression, and if this expression evaluates to true, then we execute everything below the if statement. Otherwise, we skip that portion. As you can see, if this statement is true, we execute this statement or these statement blocks. Otherwise, if it's false, we move on to the next statement block or the beginning of a new statement. So let's look at an example to further understand this. Let's take this if statement over here. As you can see, in this if statement, I have this expression 50 greater than 30. So what Python is going to do now is it's going to check whether 50 is greater than 30, and it's going to check it in a Boolean context. If this is true, then we can move on to the next portion, which is this. But if it is false, then we will skip this. So let's see what happens over here. So since we know that 50 is indeed greater than 30, this is a true expression, we move on to this block of code, which is saying that print 50 is indeed a larger number than 30. So let's see if this actually gets printed. So as you can see, we get this the result, which is this is a true statement, and we get our print statement getting executed. What if we gave a false expression over here? So let's look at what happens if I gave a false expression. Now I'm checking if 50 is lesser than 30, which is a false statement. So if it's a false statement, we do not move on to this portion of our if statement block, and we directly skip. So if I have to execute this, you will see nothing gets executed. And in fact, my print statement is just not executed because we never entered this, because our expression over here was indeed false. So yeah, this is how a basic if statement block looks like in Python, and this is how we move on to how we check for the truthfulness or the falseness of a particular expression in the if statement. So moving on, let's move on to the topic of indentation in Python. So as you can see, this if statement is an example of a control structure. So without defining what a control structure is in detail, control structures consists of these conditionals or loops or iterations, if you will. So all of these control structures involve heavy indentation. So what does an indentation mean? Well, what if I gave you an example? Say I gave you some variable called age and I wrote 20 over here. Now if I gave you an if statement saying if age is greater than 10, now it's very important to note that when I'm defining an if statement, I need this colon, otherwise this if statement is not defined. So this colon is important anyways. So now I'm checking this expression if age is greater than 10. Now what is this? What happens if age is greater than 10? Now what if I want Python to do something only if age is greater than 10? Well, how do I tell Python that there is a piece of code or a section of code that I want executed only if this condition is met? Well, this is where indentation comes into play. So if I want, say if I want this line, this person is an adult. Again, this is some random line where I'm assuming age is pertaining to this adult, alright, or this person. So if I have this variable age where I write this number 20, which denotes the age of some person, and I'm doing a check if age is greater than 10. Actually, let's be specific here. Well, the adult age for most people is 18 in most countries. So let's see if age is greater than 18. Now, if I'm doing this check, I want to print this statement only if this person's age is above 18. So how do I tell Python that I only want this statement to be executed only during this if this condition is met? Well, this is where indentation comes into play. As you can see, exactly as you can see, this portion of the code is slightly indented compared to the if statement. So when this condition is met, then only do we move on to this. If this condition is not met, we move on to whatever the next section of code will be, like whatever code that we have after this if statement. So let's see. So since this condition is actually met, as you can see, this print statement is actually executed. So this is the importance of indentation. Now we will see as we learn more about if statements and else statements and elif statements, how indentation plays a key role in defining what we want as an output when a certain condition is met. Alright, so for now it's very important to understand that this is how indentation is used in Python. In other languages we might use, we probably don't use indentation. In fact, popular language, the C language, does not use indentation at all. But some languages, and Python is probably the trademark language for indentation in programming. So you might say that, so different people have different opinions on indentation. The general consensus is that indentation helps make the code look very presentable and very readable, and this actually is one of the facets of Python programming, is the indentation and the easy readability of it. Anyways, moving on. So what if we have multiple conditions in our code or in our if statement block that we want to see? So let's create this list, or let's actually just copy this example that I have written over here. As you can see, what I am doing in this piece of code is I have a list X where I have this integer 50, I have two strings, cat and apple. Now I want to check a bunch of things. So I want to check if 60 is an X, and I also want to check if the string cat is an X, and I want a final sort of, like, if none of these conditions are met, I want something to happen. So how do we do that? Well, we start off our if statement block with the standard if keyword. Alright. Now if we have one more condition that we want met, then we can use the elif, which is kind of a short form for else if. So we use the elif keyword. So what Python reads is it checks this condition, then it will check this condition, and then finally we have this else keyword. And else is a keyword used in our block to tell Python that if none of our earlier expressions have been true, then do what is in the that is within the else keyword, that is indented within the else keyword. So again, we don't pass an expression for else, because else is we only reach this else statement in case all of the earlier conditions have not been met or have come to be false and not true. So let's look at this particular code example. So we have a list of 50, cat and apple, and my first expression that I'm checking is 60 in X. So this is how we check actually. So if 60 and X should be read as is 60 in the list X. So Is this 60 in the list X? Well, actually no, we don't have the object 60. So this part is not executed. We move on to the next condition. Is the string cat in X? Well, actually it is. The string cat is indeed in X. So we move on to this statement block, which is within the condition that is met, which is print cat is in list X. And you will see that none of the other statement blocks will be executed because we have met our condition over here. So if I execute this, as you can see that the print statement cat is in list X is what is actually executed. And we do not execute this obviously because it is false, and we do not even check or we do not even move on to this statement because, well, we have a condition met over here. So it's one thing that is important to note is that we can use as many elif statements to check for as many conditions that we want to check for, but it's very important that we only use, and if we are using, that we only use one else statement and only at the end of our block. Okay, so moving on. Now I'm going to show you a very neat example about how Python actually does its these condition checkings. So it's very important to note that once a condition is met, none of the other conditions are even checked for. So we do not even consider the next statements and we directly leave this if statement block. So let's look at this example over here. Now in this example that I have over here is where I've stored the string cat in X. Now I have three conditions that I'm checking. I'm checking is 50 greater than 60. I am checking if the value of X is indeed cat, and I'm checking some random expression 1 divided by 0. This is not even a check. This is literally just checking if 1 divided by 0 is true or false. And as we know, we cannot divide anything by 0. So let's see what happens when I execute this statement. Now typically if I wrote 1 divided by 0, Python will throw me an error because 1 cannot be divided by 0. That is an erroneous statement. So let's see what happens when I do this actually. As you can see, I have a statement being printed, but I have no error even though I gave an erroneous statement in 1 divided by 0. Well, now you might ask, why is that so? Well, it's simply because I have actually never reached this condition. I have not even, Python has not bothered looking at this because if you actually see, there is a condition previous to this over here, which is met and which is true. So we move on to this block, we execute this block and we forget about the rest of the code. So we don't actually get to this erroneous statement, which is an interesting thing and which is an example that I have shown to show you that once a condition is met in an if statement block, we do not look at any of the further conditions that are being checked. Okay, so finally, I have one small topic that I would like to share with you is the conditional expressions or the Python's ternary operator. Now, this is slightly different to the if statement that we have talked about up until now, in the sense that it is not a control structure. So what this actually is more of an operator that defines some expression. So let's see what I am trying to say over here. So as you can see over here, highlighted is the syntax for what I'm trying to talk about, this ternary operator. So let's look at this example and let's see what I'm trying to do over here. So I have this variable age, alright, and this age is 26. Now X, now just read this statement. X is equal to adult if age is greater than 18, else child. Now I could have done an elaborate control structure with an if statement, then an indentation within that if statement. And then I could have written else and then another indentation and I would have written another statement over there. But instead of that, I have used this operator to assign a particular value to the variable X. And this, what value I'm assigning to X depends on if this condition is true or false. So as you can see, the condition says is age 18, greater than 18. So if this is true, then I assign this particular string. If it is false, then I go on to the else statement and I assign this. So since age 26 is greater than 18, I should assign the string adult to X. And as you can see, if I execute this and check what is an X, you can see adult is indeed an X. So this is a very neat, a very readable, and a very it's probably a more it's a better looking way to perform simple else simple if and else statements where you don't want to create a whole if else statement control structure block. So yeah, this was the ternary operator. Finally, we make a short note on the pass statement in Python. So the pass statement or the pass keyword is a place where is a placeholder of sorts. So what if I had an if statement and I'm writing a piece of code, but I don't know what to do with this if statement. So if a statement is correct, if a statement is true, but I don't know what to do if this statement was true, how do I tell Python, well, let's just keep it a hold for now, and I might put something into this block later in the future? Well, I would use the pass statement. So if I had this, say this some condition again, if I'm checking age is greater than 18, but I don't know what to do with this, I would just simply use this pass statement, and this basically does nothing. It's a way to, it's like a way to create a placeholder where maybe in the future I might write some sort of a, say a print statement or some sort of a different function or something else within this indentation. So, but in the meantime, like currently I don't have anything to place over here, so I just leave it with a pass statement. So this is a way where you can use a pass statement in if and else statements or if and else control structures. So yeah, this was a basic or an introduction into conditional statements and the control structure of if and else statements in Python. In this video, we will be doing a small exercise on if statements. Just to drive home the point or the purpose of an if statement, we will be doing a small exercise. So let's first revise some of the concepts of an if statement. So a basic if statement can be something like this. We have a small condition where we're checking if a variable x is greater than 5 or not. And if it is greater than x, we print a statement over here. So if this condition is met, we print this statement. Else, we move to this statement block. Now our variable x has the value 5. Now since x is not greater than 5, what this will do is it will check this statement, and since this will be false, we skip this statement block and move on to this statement. So as you can see here. Similarly, we can do something where we are checking multiple statements. We use the elif statement in such a case. So now in this block, we are checking in one of the conditions we're checking is if x is equal to 5 or if x is greater than 5. And then finally, if both of these conditions are not met, we say else and we print whatever, or we do whatever is in this particular statement block, which is a simple print statement. So as you can see, x is indeed equal to 5. So this is the block that will get executed, as you can see here. Now another example are nested if statements. So nested if else statements are if else statements within if else statements. So let's look at an example. As you can see here, we have a string stored in a variable called orange quality, and the string is fresh. Now we have an integer, or a float in this case, 4.0, stored in orange price. Now our first statement is checking whether orange quality, the variable orange quality, is it equal to the string fresh. Now within that, if this statement or if this condition is met, we do another check where we're checking what is the price. Is it lesser than 5? If it is, we do this block. Else, we execute this block. Finally, if our initial statement or initial condition is not met, we move on to this else block. Now when I execute this, what should happen is I will enter this block because this is true, and finally I will enter this block because this condition is also true. So I should have this printed. I will buy 5 dozens, as you can see here. Now let's move on to our main exercise for this video. So this was all just a revision. Now we're going to use some or all of these concepts in a sample project or a sample exercise for your further practice. So in this exercise, what we're going to do is we're going to request the user to enter a number between 1 and 20. And our code is going to check whether this number entered is an even number or an odd number. So as you can see, there are 2 sets of checks that we're going to do in this code. The first check is going to be whether the number that is entered is between 1 and 20 or not. And if it is not, we have to say it's an invalid number. But if it is entered between 1 and 20, we have to move on to the further checks, which is whether it is an even or an odd number. So let's see how we do that. So in this piece of code, what we start with is a print statement saying, please enter a number between 1 and 20. And then we add an input command. This input command will open a box where we can enter whatever number that we want to enter. Now we use this int keyword to make sure that whatever we have entered into the input box is stored as a int data type in the enter num variable. Once we do that, our first if statement is going to check whether the entered number is greater than or equal to 1 or lesser than equal to 20. And lesser than equal to 20. So both of these conditions have to be met. If this condition is true, then we have a valid input and this statement is printed that we have entered a valid number. And then we move on to the rest of the statement block within this if statement, which is another set of if and else if statements. If our number is not between 1 and 20, we move to this block, and this block prints that we have entered an invalid number. Now, once we have, say, entered a valid number, we move on to this block, this if else statement block. Now what this block is checking is whether the entered number is an even number or not. Now as we know, an even number is divisible by 2 and leaves the remainder 0 when divided by 2. So this is what this check is doing. If this check is true, that means our number is even and we get printed that our number is even. The other check or the other if statement is checking whether it's an odd number, and that means when we divide by 2, we should get the remainder 1, as you can see here, and we get printed your number is odd. So let's execute this and see what happens when we enter a number. Now it's asking me to enter a number. Let's say I enter 17. Now that I have entered 17, as you can see, it's a valid number that I have entered, and the code is telling me that my number is indeed odd. Let's look at some other, what if I entered something else here? Let's say if I enter 16 now, since it's an even number. As you can see, 16 is also a valid number as it's between 1 and 20, and my number is even, and the code checks for that. Let's see what happens when I enter an invalid number. Let's say 25. Now when I enter 25, as you can see, it says I have entered an invalid number. And in this case, what has happened is, this condition itself is not met, and I have moved on to this statement block. So to give you a breakdown as to how our code has executed this, let me show you an example for the number, say 9. When I enter 9, the first check that happens, of course, is this check, whether it's a valid number or not. And since it is between 1 and 20, we move on to this block. And in this block is checking whether our number is divisible by 2 or not. And since it is not, it will leave a remainder 1, and we execute this block, which says our number is odd, as you can see here. So this was a brief recap into the if statement and if-else statements, nested if-else statements. We also saw an exercise where we used nested if-else statements. In this video, I will introduce you to the concept of iterations in Python, and we will be speaking in specific about the indefinite iteration in Python, otherwise known as the while loop. So let's look at what an iteration means. An iteration is executing the same block of code over and over, potentially many times. A programming structure that implements an iteration is called a loop. Now in programming, we have two types of iterations, definite and indefinite iterations. And in this example, we will be speaking about indefinite iterations. Indefinite iterations in Python is the while loop, where we use the while keyword to define an indefinite iteration. So let's look at the basic syntax. As you can see, this is the basic syntax where we have the while keyword followed by an expression and again the colon, and below that is something indented. Again, we encounter indentations just like in if-else statements, a set of statements where what happens here is, following the while keyword, we have this expression where this expression is evaluated in a Boolean context. Again, we check if this expression evaluates true or false, and if it is true, we execute all the statements or the statement block that is indented below this while statement. This is another example of control structure, much like if and else statement blocks, where we use a lot of indentation. So let's look at a basic example now of while loop. So let's copy this example and let's see what this does. So I have a variable n where I am assigning it a value 0. This is called an initializing process, and it's very important to note that most while loops consist of an expression which contains a variable, a control variable, which is usually initialized prior to starting the loop, and then this control variable is typically modified somewhere within the main loop body. So in this case, my control variable is n, and I am initializing it by assigning it the value 0. So let's move into the loop now. So the loop has this while keyword, as you can see, followed by an expression n lesser than or equal to 5. Now what this is an expression which is going to check if it's true or false. Is n lesser than or equal to 5? And as long as this expression is true, we will continue doing whatever is indented below this while statement. And what is below this while statement is a print statement, first of all, which says value of n is, and it basically prints the value of n in that particular iteration. And as you can see, this compound assignment where we add the value of n by 1 and we assign it back to n. So what this is, let's see what this does actually. Let's execute this and see what this does. Important to note, the value of n again is initialized at 0. So this while loop will keep going on until the value of n remains lesser than or equal to 5. So as you can see, I have the execution of this particular block of code, or this while loop, where I get the multiple different iterations of this print statement that you can see here. The first iteration, it says value of n is 0. Then it says value of n is 1. What I'm doing is I'm writing the value of n multiple times, and each time the value of n is written over here based on what iteration it is. So what is happening actually is that initially the value of n is 0, and I print this statement value of n is 0. Now I add the value of what is in n by 1. So now what is the value of n? So again we do this check. So after this first iteration, we come back, like once this whole block of code is executed, we again come back to this expression and we again check if this statement is true. So now that the value of n is actually 1, this statement is still true. So again we execute this, and that you can see over here, value of n is 1. Now again we add the value of n by 1, and again we go back here once this block is executed, and we check if this statement is true again. And as you can see, the value of n when it's 2 is still making sure that this expression is true. And this keeps happening until the value of n is greater than 5. So once the value of n becomes 6, this condition is no longer met, and finally we do not execute this statement because this expression evaluates to false, and we do not do this anymore, and we finally leave our while loop. So let's check what the value of n is just to confirm this. As you can see, the value of n is indeed 6, and that is why we have left this while loop over here. So this is an example of a basic while loop where we check for this an expression. If it evaluates to true, we evaluate everything within it. Once this is done, we go back and we evaluate this expression again. If it is again true, we again go back and do whatever is indented within it. And we keep doing this until the expression gives us false. And interestingly, we don't necessarily have to define these control variables always. We can actually use iterables, and we will learn about iterables actually in a future video. But we can use iterables, and an example of an iterable is the list. So let's look at this list and let's look at this whole block. Alright, so I created this list A, which contains 5 objects, 1, 2, 3, 4, and 5, all integer objects. And I have another variable x where I store the integer 1. Now this while statement, now it might look confusing. Now it says while A. Now what is A? Well, A is not your typical expression where you're making sure if some condition is being met or not. But this, the way you read this is while A exists. So in the context of a list, as long as A, which is a list, contains objects within it, A is true. If it does not have any objects within it, A is false. So while A, basically what it means is while A has objects within it. And if it does have objects within it, or as long as it does, we continue executing whatever is indented within this while statement. And this while statement is a print statement. Again, we do like we have this value x where we're doing we're printing this is iteration number, and we pass x. So the first iteration will obviously pass x is equal to 1, and then we add x by 1, and then the second iteration should pass this is iteration number 2, and then so on. And finally we have another statement within this block called the pop statement, where we're popping the elements of A. Now as if you would have seen the video on lists, the pop statement removes the rightmost value from a list. So if I do a.pop, initially it will remove 5 from this list, and I will have the rest of them. And again, if I do pop, it will remove 4 from this list, and then you will have the rest of these. So let's actually see. We'll actually check what's left in this list each time we do this pop statement. So I'll also print the list A during each iteration, and let's see what happens over here. As you can see, what is happening out here is while A has elements, we are going to continue doing this while statement, whatever is within it. So in the first iteration, obviously we have all of it, and it is iteration number 1, and as you can see, the list contains everything. Then I pop it. Then iteration number 2, it again has elements, but it has lost its rightmost element. And this keeps on happening until the list finally has no elements left. And once the list has no elements left, this expression while A evaluates to false, and we do not execute this anymore, and we leave the while loop. And again, let's check what is in A. A should have no elements. As you can see, it's an empty list. When I checked what's in A, it's an empty list. And that is why while A returned me a false and we did not print any further. So this is an example of using a while statement using lists. And of course, the next topic would be discussing nested while loops. And this is a broad topic. What I mean by this is that when I'm saying nested while loops, I'm actually talking about nested control structures. So we can have while loops within while loops. Not only that, we can have if and else statements within while loops. We can have while loops within if and else statements. And we can have if and else statements within if and else statements. So if you think of all of these loops, and we will even speak about for loops in another video. For loops again are a type of control structure. So all of these are control structures. While loops are control structures. For loops are control structures. If and else statements are control structures. All of these are control structures, and nesting can happen within them. And it does not matter which is the parent of the nest and then the child of the nest. You can have a while loop within an if and else statement. You can have for loops within a while loop. All of this is valid in Python, and it's one of the great features of Python that is very flexible in this way. So let's look at an example where I have a while loop within another while loop. So I'm copying this piece of code where I have this list 1, 2, 3, 4, 5 and another list first and second. Now my first while loop, I print what is popped from A. So I take A, then I pop the 0th index. So basically from the left hand side, and I print what is that. Alright. And then I have another while loop where I have this list B and I'm doing the same thing. But this while loop is within the first while loop, and let's see what happens out here. So as you can see, my first iteration of this parent while loop causes me to pop what is the first element, which is 1. Then I do these while loops and this is completely executed, and only then do I go back to this first one. And then I come back and do all of this again. Then I go back to this one and then I come back and do all of this again. And that's why you can see this repetition. So I have this first iteration and then I do the second while loop. Then I have the second iteration and then I do the second while loop, and I keep doing this. And this is an example of a nested while loop. Okay, so our next topic in this video would be break and continue statements. Now break and continue statements are ways to abruptly end iterations in a particular loop. You can use break and continue statements not only in while loops, but you can use it also in for loops. So let's look at how we use it in while loops. And let's look at what we mean by break and continue statements first of all. Well, the break statement terminates the loop entirely. So once the break statement is found, the complete while loop that we are using is completely terminated. And the continue statement, on the other hand, terminates only the current loop iteration, and it goes back to the beginning or the expression, and it checks whether the expression or the controlling expression is again reevaluated, and it is checked whether the loop will execute again or terminate. This pictorial that you can see here actually emphasizes, or it shows the difference between break and continue. So I have this while loop and I have an expression. Alright, I have a bunch of statements and I have a break command over here and I have a continue command over here. So if I encounter the break command, it will not execute any of this. In fact, it will not execute this while statement at all, and it will move on to the next piece of code that we have. But a continue statement, if a continuous statement is encountered in a while loop, will not completely break away, but it will not execute the rest of the statements in that iteration, only these two, but it will go back here, it will check this expression again, and again we will do this all over again. So this is this small difference between the break and continue statements, but both are used to abruptly end an iteration in a loop. So let's look at an example of how we use the break statement. So I will use this example where I have initialized some controlling variable n to 0. My first loop will check whether n is less than or equal to 5. If this is true, then I will print this statement. Then what I'm doing over here is I am incrementing it by 1. Now in my earlier example using the similar example, I had no, this part was not there. So what you got was I was printing the value of n. So it was printing as value of n is 0 and then 1 and then 2 and then 3, 4 and 5. But over here I've included I've nested an if statement, and within that I put a break statement. And this if statement is checking if n is equal to 2. So once n is 2, I move on to this and I do the break statement. So let's see what happens now. As you can see, So when I have executed this, I don't get the whole value of n is 0 and then 1 and then 2, 3, 4, 5. I stop at 1, and that is because once n is equal to 2, I actually do not execute this while loop again. I do not go back and execute print value of n is 2 now. In fact, I break from this whole while loop, and my while loop terminates right then and there. And that's why you only get these two iterations, value of n is 0 and then value of n is 1. Okay, so now I'm going to show you a neat example of what happens, or what is the difference between a break and a continue statement. Okay, so let's go back to our initial example where we're printing this value of n is 0, 1, 2, 3, 4 and so on. But I've added one more statement where I print hello at each iteration. So let's see what happens when I do this. As you can see, it will print hello after each of whatever I was doing already. Now let's introduce our break statement first of all. So when I do break, well, let's go back to this if statement. If we check this condition, then we break. Let's see what happens now. As you can see, something interesting has happened where we have this first iteration completely being executed, but the second iteration kind of stops where there's no hello, and that is because we have broken from this while loop before the second iteration's hello was printed. Let's see the difference between a break and continue now. So now I have this continue statement instead of a break. Let's see what happens here. As you can see, it seems familiar to our first example where we did not have any break or continue. But there is a small difference that I want you to catch, and that is very important about this continue statement. So as you can see, the first iteration has value of n is 0 and then hello. Then value of n is 1, but there is no hello. And this is because once this condition is actually met, we do not move on to this statement, but we go back to this expression and we evaluate this expression. And then once we evaluate this expression again and it's found to be correct, we do everything the same again where we print hello. But except for that one step where this if statement was met and we did continue, and this following statement was not executed. And that happens only for one iteration, and that is when n is equal to 2. And as you can see, that is what happens over here. In one of the iterations, we miss a hello, and that is the difference of the continue statement between, that is the difference of the continue statement with the break statement. So this concludes it for our video on indefinite iterations. In this video, we will be looking at 3 examples where we are using while loops along with other stuff like say if and else statements. So our first example will be where we calculate the factorial of a number. In this example, as you can see here, we are first going to ask the user to enter a particular number for us. Now this number is supposed to be an integer. Once we have this integer, we store it to a variable called number. Now we have this, you can say this variable called FAC which stores 1, and we will see how we are using it later. Now we know that the factorial of 0 is 1. That's how it's just defined. So we have an if statement checking whether our entered number is 0, and if it is 0, we say that the result is 1 or the factorial is 1. However, if we enter a number that is greater than 0, we must calculate the factorial for this number. And that is what we are going to do in this else statement block over here. Now in this else statement block, we have a while loop. In this while loop, the condition is checking while number is greater than or equal to 1. So as long as this condition is true, everything within that while loop will be executed. So as long as number is greater than or equal to 1, we are going to execute these 2 lines. Now what do these 2 lines do? Let us see. So the first line takes the variable FAC where we had the number 1 stored, and we are going to store FAC times number into it, number being the number that we have inputted. So in case, for example, we entered 8, then what this line will do is 1 into 8, and it will store that back into FAC. Now once that is done, we move on to the next line where we are decrementing the number variable by 1. So if we have stored 8 or we have entered 8 into our input, it will become 7. Now as we know, 7 is still greater than or equal to 1, so this condition is still being met. And then we do this process again where we are going to multiply FAC. This time FAC stores the value 8 and we multiply it times the new number which is 7 now. So we do 8 into 7, and then again we decrement this. Also once we do 8 into 7, we store it back into FAC. And we keep doing this where we keep multiplying 8 times 7 and then we decrement the number variable by 1, and then we check this condition again. So what ends up happening is we are going to keep doing 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. And once we are at 1, again when we do this decrement operation, the number variable will store the value 0, and then this condition will no longer be met. So number will be 0 and this condition will be false, and we can move out of this while loop. And then finally we store the result into a variable called result, which stores the result of 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. This is of course if we did enter 8 when we were asked to give an input. So let's see this in real time once we execute this. So I'm executing this. The first thing it asks me is to enter a number. So let's say I enter my number 8, as I was speaking about 8. Alright, now that I have entered 8, as you can see, the result that it gives me is factorial of 8 is 40320, which is correct, and you can check this for yourself, where it will show you 8 times 7, or 8 factorial is basically this number. Okay, so now in our next example, we will be looking at how we can generate Fibonacci numbers. For this example, we will be using bunch of if and else if statements along with a while loop. So let's look at this piece of code where we are actually doing this. So as you can see, the first part of the code is basically an input statement asking us how many Fibonacci numbers we would like to generate. And then the user would be asked to give an input, which is stored as an int into a variable count. Now in this if-else statement, the first if statement checks whether what we have entered is 0, in which case we just store an empty array in the variable called fib. Next, if our entered integer is 1, we just store the value 1 in this array called fib. If our entered number is 2, we store 1 and 1 in the array fib. All of these are different sets of Fibonacci sequences. This obviously an empty array shows that, well, there is no numbers to be generated in this sequence. If we have 1, we just print the first number of the Fibonacci sequence, which is 1 itself. If it is 2, we print the first two numbers, which is 1 and 1. Now, the actual calculations happen when we say we want a Fibonacci sequence for more than 2 numbers. Now, in that case, we move on to this block. In this statement block, we initialize the fib variable with the first two Fibonacci numbers 1 and 1, and we store in this array. Now we are going to do a while loop within this, and in this while loop we are going to keep executing this statement block as long as this condition is met or this condition is true. And what this condition is it's checking this variable I, which we have initialized as 1 over here, and we are going to check whether that is lesser than count minus 1, count being the number that we have been asked to input. If the statement is true, and as long as the statement is true, we will be executing this statement block, which is basically us appending this expression into the array fib. Now what this expression is basically, it's going to keep adding each subsequent numbers, and we're going to store each subsequent numbers back into the array fib. So in this case, if you see, what the first step will do is it will take the value at the first position of the array fib, and it will add it to the value at the 0th position of the array fib. And both of these values, since they are 1 and 1, when we add them, we get 2, and we append that to fib. So now our fib will look like 1, 1, 2. Then we increment this by 1, and what we do is we do the same process again. So in the next step, what we would do is we would do 2 plus 1. So we would get 3. Now this would keep going on until this condition is met, or basically until the numbers that we actually want to generate in our sequence. So let's execute this, and let's see an example of what happens. So it asks me how many Fibonacci numbers I would like to generate, and I will say I want the first, let's say 6 Fibonacci numbers. So I execute this. As you can see, this gives me the first 6 numbers in the sequence, which is 1 and 1, and then 2, which is basically 1 plus 1, and then 3, which is 1 plus 2, and then 5, which is 2 plus 3, 8, which is 3 plus 5. So if we wanted more numbers, we would just enter over here. Like say if we wanted the first 10 numbers, it would give us the first 10 numbers in the sequence, as you can see here. Now in our next example, what we are going to do is we are going to write a program which takes 2 digits that represent the dimensions of an array. For example, if we want a 3 by 3 array, we will enter 3, 3, and we are going to generate a 2-dimensional array in which each of the elements of the array are basically the row times the column position of that particular element. And what I mean by this is, say we have a position I comma j on the array. The value of the element at that position would be I times j. So for example, if I'm looking at something at the third row and the fifth column, or say the third row and the third column, for example, the value of the element would be 3 times 3. And if I'm looking at something at the second row and the fourth column, I am going to do 2 times 4. So let's see how we can do this using code. So if you look to the right over here, I have a piece of code where I'm going to where it asks me to input two numbers, two integers, to represent the dimensions of my my sample array. Now once we have done this, we are going to store these dimensions in the inputs in a variable called input string. So obviously when we enter say 5 comma 5, that will be stored as an int in this particular string or this variable. What we want is, we want 5, say we entered 5 comma 5, we want 5 as a separate integer and the other 5 as another separate integer. And that is what we do in this particular statement, where we're going to split up our input string based on the comma separator, and we're going to store the first part of that string into the 0th position of dimensions, which is an array, and the next dimension in the first position in this particular array. Now we're going to store the number of rows as row number, and that is the 0th position of this array, and we're going to store the number of columns as the first position of dimensions, or whatever we've mentioned in the input. So now we have this our results array called multilist, which is basically what our final array is going to look like, and we're going to store it into multilist. And in this example, we will be using for loops to do this, or to create this particular array. So as you can see here, our first we have initialized our multilist, saying that we're going to have only zeros in our sample array. So initially, once we have initialized this array, all multilist will contain is a, say for example, we have inputted a 5 by 5 array. It will have basically a 5 by 5 array with all elements as 0. And that's what this line does. Once we have done this, we are going to move on to the for loop portion, where we are actually going to create our array that we want. So as you can see, our first for loop is going to say for row in range row number. So obviously range will generate an iterator which can be iterated over, and since it says range row number, and say the number of rows that we entered were 5, what it's going to do is it's going to create an iterator containing the value 0, 1, 2, 3 and 4. So for row and range, it will basically row will take the value 0, 1, 2, 3 and 4. And a similar thing is going to happen in this nested for loop, which is within this, where we're going to again create an iterator using this range function and for the column number. Once we have this, we're going to do the simple process of multiplying the value of the element based on its position. So if it's at the position 3 comma 4, we're going to store the value 3 times 4 into that particular position of the array. And we're going to do this for every position, which is what happens in these two for loops. We're going to first go by each row, and then within that we're going to check each column, and we're going to perform these calculations. And finally we print our result. So let's look at an example. Now I'm going to say I want a 3 by, let's say a 2 by 4 matrix. So let's see what the results will be when I give this as so what I'm saying is I want 2 rows and 4 columns. Now as you can see here, it might not be very clear to you right now, but what you can see here is this is the first row and this is the second row, and each row contains 4 columns. So this is my final array that I get. So what you can see here is this is the 0th position, and or you can say this is the first row, first column, first row, second column. And since Python is 0 based, so this is actually the 0th row and this is the first row. So as you can see, this value basically is 0 times 1. This value is 0 times 2, 0 times 3, 0 times 4. And over here it is 1 times 0, 1 times 1, 1 times 2, 1 times 3. So similarly, if I did, for example, a 5 by 5 matrix, what you will get is 5 rows now, 5 rows and 5 columns. And for example, like this particular value is 1, 2, 3, or 0, 1, 2, 3. So 0, 1, 2, 3 and the first column. So this is 3 times 1. If I took this value, this is like the fourth row, for example. Fourth row times the 0, 1, 2, 3 third column. So this would be 4 times 3, which is 12. So, and each value of this has been generated in the similar process. So this is an example of how we can use for loops for a particular exercise that I have shown you right now. So this was it for these particular examples into while and for loops. I hope you found the 2 examples on while loops and this 1 example on for loops helpful to you, and I hope it gave you further insight into how we can use these types of loops in say different projects. In this video, we will be covering the topic of definite iterations using for loops in Python. So starting off, we know that there are 2 types of iterations in programming, definite and indefinite. We have already covered indefinite iterations in the form of while loops. Definite iterations, on the other hand, are done using the keyword for, and the basic syntax or the standard syntax for a basic for loop in Python is as you can see over here. We have this for keyword, we have some variable, we have the in keyword, and we have this iterable, and we of course define this control structure with the colon, and then indented we have this statement block. So once this for loop has started, we execute all of these statements within the statement block as part of the for loop iteration. So yeah, let's to understand like how for loops work exactly, let's look at the concept or meaning behind what we call iterables and iterators. So think of it in a stepwise manner. Alright, so in Python we have different objects that can be used as iterables, and an iterable is basically some object that it's a collection of other objects. So think of your lists, think of dictionaries and sets. So all of these are essentially collections of objects. So once we have these collection of objects, we can create an iterator out of it. How do we do that? Is we use the iter function. So for example, if I passed this list A through the iter function and I store it in some variable iter underscore A, and I see what is iter underscore A, it is actually a list iterator at some random memory location which we don't really care about. Similarly, if I gave a tuple and I did the same thing, I will create a tuple iterator, and in the left, if you can see over here, I've done the exact same functions with sets and dictionaries as well. So I'm creating iterators out of these iterables, so as to speak. Now what is an iterator? Well, an iterator is an object that yields values successively. So if my list contained 5 values or 5 objects, an iterator of this list will yield these values one after the other, and that is kind of how, or that is the basis for which we create loops. Let's see what we exactly mean using this using another function that we call the next function. So the next function keeps moving from object to object within an iterator. So since I've created this list iterator, let's just do it once again. So as you can see, I've created this list iterator iter underscore A. Now with this iter underscore A, what I'm going to do is I'm going to use this next function. What next function does is, starting from the leftmost object within this iterator, I will keep yielding, or I keep producing the values. So let's just see what happens when I do next for this particular variable. It gives me this object first. Now let's see what happens when I do it again. Now it gives me the object second. What if I did it again? It gives me third. Now if I kept doing this, it will keep giving me the different objects that were initially stored in A. That is first, and then second, third, fourth, and fifth, one after the other. So let's actually perform that. Now I get fourth, now I get fifth. Now a natural question is, now that I've exhausted all of these values, what will happen if I perform the next function again? Well, let's see what happens. I get an error, and this error is the stop iteration function error, which basically is telling me, look, you have exhausted all of the objects that were initially present in this list A, and you cannot keep doing the next function anymore. You cannot keep going further. So yeah, so this is what the next function does when it comes to the concept of iterators. Alright, so now we've learned 2 things. What is an iterator, and how do we create an iterator out of different collections of objects like a list or a tuple, and we've also learned how to use the next function. Now let's let's come back to our for loop that we started off this video with. So our for loop again, let's consider our for loop over here. as you can see, some for loop with the objects again 1, 2, 3, 4 and 5. Alright, this is a list. Now I'm going to do for x in A, print x, and let's try to see what happens when we do this. Okay, as you can see, when I have executed this, it gives me 1, 2, 3, 4 and 5. So I have, first of all, let's look at this for loop. In this for loop, I define a new variable x, and then I say for x in A, print x. And what's happening? Well, in each iteration, I'm printing whatever the value of x is at present. So in the first iteration, it is the first object 1. In the second iteration, it is the second object 2, then 3, 4, 5. And then finally, on its own, like this for loop knows that, okay, now once I have exhausted all of the objects within my iterator, I can stop doing this for loop and I can move on with the rest of the code. Alright, so think of it like a 3-step process, a for loop in Python. The first step is it calls an iter function to obtain an iterator for whatever we pass over here, this iterable. Second step, it calls the next function repeatedly in each iteration. Alright, to keep getting the next item from the iterator. So it gets 1, then it calls next, then it gets 2, then it calls next, and it gets 3, and then 4, and then 5, and so on. And then finally, the third step is the termination step, is when after we do the final next, where we get this error, as you can see, this stop iteration error or exception. Finally, this tells the for loop function or the for loop that, okay, we have reached the end of our definite iteration or the end of our definite for loop, and this is where we must terminate our loop and then continue with the rest of the code. Alright, so this is how a for loop works in Python. Now it's very important to note that whatever we have discussed when it came to while loops, such as nesting of while loops and nesting of other control structures, is also applicable in the case of for loops. So if I had a for loop within another for loop, that is perfectly fine. If I had a while within a for loop, that is perfectly fine. So all of these are valid statement blocks that we can do. And again, for loop is another control structure, and so we must follow the concept of indentation when it comes to writing our statement blocks within a for loop. Okay, so now I'm going to speak about, in specific, I'm going to speak about this something called the range function. That is quite, you could say, it's used, definitely it's used in other areas of programming, but it's widely used in Python. I mean the for loop in Python. What I mean by this is that this range function is very important for the for loop, and we will see why. Okay, so let's look at one of the examples of using the range function. So what does the range function do is, if I give range 5, let's see what it does. It gives me range 0 to 5. What this basically tells me is that this will create an iterator that contains integers from 0 to 5. So it will contain the object 0, 1, 2, 3, 4 and 5. And we can use this as an iterator. So let's look at this. I have range 5. Let's store this in x. Okay. Now let's do a type just to see what happens when we do type x. It should give me the type of range, as you can see. And this is a type of an iterator in Python. Now let's see what happens when I do for I in x print I. Okay. Let's see what happens. As you can see, it prints the number 0, 1, 2, 3, 4. An important caveat when it comes to the range function is when we say range 5, it creates an iterator from 0 to 5, but it contains the objects 0, 1, 2, 3 and 4 only. It does not contain the object 5 itself. Okay, this is something that is very important too. So once again, I use this range function to create an iterator iterator of 5 objects from 0 to 4, 0, 1, 2, 3 and 4. I use that in my for loop, and that is what you are seeing here. Now let's use this range function in the context of something else. For example, let's see. So I had my earlier list A, right? Look at my list A here. So you can see list A contains these 1, 2, 3, 4, 5 objects. Okay. Let's see what length of A is. Length of A is 5. Okay. Let's use the range function on top of the length of this list A. And this is like, I can't show you an example right now without any context, but this form of using a for loop is widely used in Python programming. You will use it so much in data science. You will use so much in machine learning and AI. I cannot tell you. This is a very important, like, sort of for loop expression. So you have for, let's say, I in range len A. Let's see what's going on here. First I do length of A, that gives me 5. Then I do range of 5, that creates an iterator between 0 and 4, right? When you do range 5, it gives you an iterator of 0, 1, 2, 3, and 4, as we saw earlier. And this is what we're doing over here. We have created an iterator out of the length of a list. Now when I do print I, it should give me again 1, 2, 3, 4. 0, 1, 2, 3, 4, of course. So as you can see here, it will give me 0, 1, 2, 3, 4. And this is a very neat way of using the range function on top of the length of a particular collection of objects. In this case, we're using the list A. This is something that you will use a lot. So I would recommend that you get used to this form of creating a for loop as well, using the range function. Also, of course, you can use break and continue statements as you have in the case of while loops. It works exactly the same in the case of for loops, wherein the break statement will abruptly stop the for loop completely and we will move on to the next piece of code, whereas the continue statement will break that particular iteration and then we will resume with the next iteration. So yeah, that was break and continue statements in for loops. Finally, I would like to show you something about how to use dictionaries as an iterator or as an iterable when it comes to for loops. So let's create our dictionary. Let's go. We have a dictionary already here. In fact, let's create this dictionary. Again, we'll store it in A. Okay. So I created this dictionary A. All right. So I have dictionary A. What I'm going to do is I'm going to pass it through the iter function, as you can see. And now I'm going to just, for the sake of showing you, I'll show you that it is actually an iterator of type of a specific dict key iterator type. All right. So now let's do something on this. So as you can see in this dictionary, I have the key first that has the value 1. I have the key second that has the value 2. I have the key third that has a value 3, and then fourth for 4, fifth for 5. Now, a good question would be, when I do iteration or when I do a for loop on top of this A, well, what is it going to pick up? Is it going to pick up first? Is it going to pick up the keys like these? Or is it going to pick up the values? Or is it going to go one by one? Key and then value and then key and the subsequent value. Let's see what actually happens. So let's do for I in iter underscore A print I. Let's see what is the iterations happening upon using this. So as you can see, we're using the keys. So by default, when we do this, when we create an iterator out of a dictionary, we use only the keys as our iterator elements or iterator values. But of course, like if you wanted to use values, all you would have to do is pass a dot values over here. And if you remember from a dictionary video, this a dot values gives us a list of, or it gives us essentially a list of the values in our dictionary. So when we pass this to the iterator, iter function, and we create an iterator out of it, let's see what happens over here. Now let's see what is iter underscore A. You can actually see it's now the dict value iterator at a particular memory location. So it's not the dict key as we saw earlier, it's a dict value iterator. So now that we have this dictionary value iterator, now let's print what are our iterator elements. And as you can see, now we are printing values and not the keys. So this is this is basically two different ways of iterating through a dictionary, one through keys and one through values. So this concludes it for our video on definite iterations in Python. I hope in this video you understood and you learned about the concept of iterables and iterators and the different functions associated with it and how exactly the for loop function works in Python. In this video, we're going to learn about the topic called file handling. Now, file handling is basically needed because most of the times when we're handling large and different types of data in Python or in general, we cannot store everything into a variable and we will have to use files. Now, there are two types of files that we are going to deal with. They are binary and text files. So binary files are some of the files that most of the files that we commonly encounter, like document files, image files, video files, etc. Now all binary files are encoded in a particular format and they cannot be read by a normal text editor. And we would be needing certain specific softwares for specific files. Text files, on the other hand, do not have any specific encoding and they can be opened in the normal text editor itself. And they are like XML, CSS, HTML files, and so on. Now, there are four main operations that we can do in Python on files. They are open, read, write, and close. There are certain other operations as well, though, like rename, delete. So some of the most basic operation that we can do is obviously creating and opening a file, and the syntax is as you can see here, where we use the open command and we give a file name and we give a mode and we store that in a particular variable. Now a mode is basically telling Python how to handle this opening. So we can have a read-only mode which is done by this letter R, a write-only mode which is done by letter W, and there are a bunch of other modes such as read or write mode which is done by R+, and we are going to see them as we encounter them. Now it's important to note that what I just mentioned is for text files. If we are going to do for binary files, we're going to do this file handling, then we would be using the letter B in front of whatever we were using in the case of text files. So if we were doing a read-only mode for opening a binary file, we would be using RB. And if we were doing read and write mode, read or write only mode, for a binary file, we would be using RB+. So basically just adding the B in the case of binary files. Let's look at a basic example. When we want to open a particular file, we are going to open, like in this example, I'm going to open some file called filehandling.txt in a read and write mode, read or write mode, and I'm going to store it in FO. So this is as simple as it gets. Similarly, if I wanted to do it for a binary file, since I'm using a binary file, I will use the letter B as well in the mode. And that's how you do it here. Now let's look at different ways in which we can read from a file. And there are three commands that we can use. We can use the read command followed by an optional number of characters. We can use the read line command followed by an optional number of characters, and the read lines command. So this optional number of characters is denoted by n over here, and basically it's telling us how many characters we want to print. So let's look at a simple example of where I'm going to print something called, so I'm going to take this and I'm going to do a print on top of this. So I've opened it and I've stored it in my file, and then I'm going to do a method or a function called read, and I'm going to say, like in this example, just read the whole thing. So as you can see, my file that I have opened has all of these lines. This is like the whole file basically. But now what if I wanted to open only the first 5 characters of this file, which is basically this? Well, in that case, let's open this once again. Now let's do the same read command, except we will give the character number, which is 5. As you can see, it's only printed 5. Now let's do a print read command and try to read the whole thing again. And you will notice something very interesting. Now when I do the read command, you can see it's kind of picked up from where we left off from our previous command. And that is the nature of how Python handles files. So if I wanted to again take the cursor back in such an example, I will have to open this again, and then I use this read command once again to get back to where I started from, as you can see here. Now another command that we can use is the read line command. So let's once again open this over here, and now we're going to use the read line command over here. So what read line command is going to do is each time we use this command, it's going to go one by one and read each particular line from this file. So in first case, it will take artificial intelligence, then data science, big data, and so on. So as you can see, if I execute this, it first takes artificial intelligence. Now if I did this command again, it will say data science. Next time if I do it, it should say big data, as you can see here. Okay. So this is the read line command. Now within the read line command also we can enter characters, and that will tell us basically that we want these number of characters from the next line. So if I want the first 6 characters of the next line, I will say 6, I will enter 6 here, and it will give me the first 6 characters of this particular line, which is the next line that is to come, as you can see here. Now another way in which we can print whatever is there in our file line by line is by using a for loop. So again, I'm going to open this file. I'm going to store it here. Now I'm going to use a for loop saying that, well, for line in my file. And what this does is basically at each iteration, it's going to take each line and store it in this variable that we enter over here, which is called line itself. And we're going to print that. At the end of the loop, what we'll have is all of the lines have been printed one by one. And another thing that we can do right now is, say we want to read a particular line. Say I wanted you to read the 5th line of my file. I can use this technique where I just say, okay, I'm going to store 5 in this variable called line number, and I have this another variable called current line, which I'm going to initialize with 1. And what I'm going to do is I'm going to do the same loop where I'm going to say for line in my line, but I'm going to add a condition saying that only if current line, when it's equal to line number, am I going to print the line, and then I'm going to break out of this whole thing. And at the end of each loop, I'm going to say current line is going to be incremented by 1 until basically these two variables are equal. So when I do this, I get my result, which is machine learning, which is the fifth line of whatever file I had. Now we're going to move on to the topic of image file handling. So we saw how we handled and we saw certain operations around text files. And text files are obviously something that we're going to use a lot. But we are also going to be using files such as images a lot. And let's look at certain examples and certain use cases around image file handling. So my first step is going to be importing a bunch of modules and packages. Now the details of these modules and these packages are not important as of right now because they will be covered in a future video. But just keep a note of some of these packages such as let's say numpy and the image package. So once I've done this, let's move on to my example. So what I'm going to do is I'm going to store certain file locations in two variables. So it's basically two strings. I've attached the this prefix r to say that this is a read-only sort of a prefix. So the next topic that we're going to be handling is image file handling. Now we have already seen many examples pertaining to text files. So text files are obviously something that we're going to be using a lot. But image file handling is something very important as well. And we're going to see certain operations that we can do around image file handling. So starting off, I'm going to import a bunch of packages and modules. What these packages exactly are and what these modules exactly are right now not that important to you right now, but it's something that will be covered in a future or in future videos. It's important to just keep note of what these are, such as numpy and image. So once I've done that, what I'm going to store is I'm going to store two particular file locations in two variables, location 1 and location 2. And I've prefixed them with R just to say that these are raw strings. So once I've done that, I'm going to use the image from the image package. I'm going to say open, and I'm going to say open from this particular location and this particular location. And I'm going to store these images in IM1 and IM2 over here. Very similar to a normal text file opening. Now, once we've done this, we can access certain properties of this image using, say, format, which tells us the format of the file. It identifies the source of an image. And if the image is not read from a file, it is set to none. We can also see the size of the file using the size attribute, and we can see the mode, which basically defines the number and names of the bands in the image and also contains the pixel type and depth. Certain common modes are like L for luminescence, RGB for true color images, and CMYK for pre-press images. So let's look at them. So when I access this, you can see my first file is of JPEG of this size and an RGB format image. And my second image is another JPEG, slightly bigger image, and again RGB. Now we can also, of course, display these images, and to do that, we can use the PLT. Again, PLT is supposed to stand for matplotlib.pyplot. It's a particular package that again you don't need to know the details of right now, but this is how we would do this. So I'm going to use a bunch of commands and methods such as figure and subplot and then IMShow. So once I have done this, as you can see, both of my images, with this being IM1, this being IM2, have been produced on the screen, as you can see. I can also use display, this display function followed by the name of the file, and this will simply display my image, as you can see here. Now I can obviously save a particular image using the save function, which is as simple as just doing this. So I'm going to save the image as im_save.jpg over here. Now if I wanted to crop an image, I can do that as well. So I stored the dimensions that I want cropped in the form of a tuple, as you can see here, and I'm going to pass that tuple to the crop function, and I'm going to apply that on top of im1, and I'm going to store that to region. Once I've done that, as you can see, so basically what I've done is I've cropped this image based on whatever I've passed here, and I've stored it into region. And now if I wanted to see what was actually in that crop, I can just do the IMShow function, and I'm going to pass the particular cropped image, which is denoted by region, as you can see here. And you can see my cropped image is basically a left portion of this whole image has been cropped out, and I have produced it over here. Now I can also use the copy function. It's a simple basically copy. You use the copy function, and it copies an image onto another variable that you have assigned. And when I use the imshow function, I'm going to show you the copied image, which is basically the same. Now we can do the transpose operation as well. So let's see some of the let's see what we have done here. So in this transpose operation, so in this basically I've done a bunch of operations such as rotating by 90 degrees, rotating by 180, rotating by 270. And finally, once I've done with all of these multiple operations, I'm going to show you the final output, which is basically a certain transposed image like this, which is basically the result of whatever I have done before this. So this is it for this video on file handling. I have shown you two slightly more comprehensive examples on text files and even certain examples on image files. However, we can use file handling in different libraries pertaining to file handling for audio files and even for like stuff like PDF files. And this is just only the beginning, and I'm sure you will encounter a lot of different use cases, different examples as you continue learning Python programming. This video is going to be the first of a part of a series on object-oriented programming. So to start off with, let's try to understand and get an introduction into what is object-oriented programming. Well, as the name suggests, object-oriented programming is all about creating objects. An object is a group of interrelated variables and functions. Variables can be referred to as the properties of the object, whereas the functions can be referred to as the behavior of an object. So if we were to treat, say, for example, a car as an object, its properties would be its color, its model, its price, and its brand. Whereas its behavior, or functions for that matter, would be like accelerating, gear change, braking. Similarly, if I gave you an example of a dog as an object, we could consider the properties of the dog as its weight, or its name, its breed, its color, whereas its functions could be, say, barking, playing, eating, walking, etc. Objects provide a better and a clear structure for a program. Now let's move on to what is a class and an instance. Now a class is like a blueprint or a template of certain functions and entities, whereas an instance is a particular realization of a class. Classes are used to create user-defined data structures and define certain functions called methods within the class, whereas instances are realizations of these classes. And when we are speaking of classes and instances, classes don't contain any real data. They are just merely templates. Instances, on the other hand, contain real data. To think of an example of the difference between a class and an instance, think of a class like a empty form or a questionnaire. Now, an empty form or a questionnaire does not have any information, but it does have a template to it. It tells you to fill in certain information, and based on who is filling in the information, that information or the data on a particular form will be different. So an instance is like a filled out form with its own unique set of information. That is one way of treating or understanding what is a class and an instance. Now for our first example on classes, I will be taking you through a class where I've defined based on the circle object. So this class is going to define basically information about your general circle, such as its radius and its area. So let's go through it. Now obviously, to define a class we need a keyword. Well, in the case of classes, we use the class keyword followed by a name for that class. So in this case, my name is circle. Now after the colon, every information that is part of the class has to be obviously indented, as is typical for Python. Now you can see over here a bunch of def keywords followed by something that you might not be familiar with, and I will try to get you through this. So if you see here, you have a def keyword followed by init, and this init is prefixed by a double underscore and it's suffixed by a double underscore. And you can see the same thing for str and repr. Well, this double underscore is called a dunder, and any method, these are of course methods. This is a method, this is a method, this is a method, this is a method. Now any method that is prefixed and suffixed by double underscores are called dunder methods. These dunder methods are or can be thought of like predefined or built-in methods for any class that you define. So these we have like 3 dunder methods over here, and we have one user defined method that we will get to. So this first method that you see here is the init method or the initialization method, and this is invoked or called whenever we create an instance of this class circle. And what we do here is basically we pass when we create this instance circle, what happens is that we get an option to pass a value for what is this keyword or variable radius. So if I pass, so you will see me later on creating an instance where I will be passing a value, and that value is basically stored as the radius. And by default, the radius that will be passed whenever we create an instance for this class is 1. The str method is basically used to return a descriptive string for the instance of class. REPR is not something that you have to bother with right now. And now get area is something that you should follow, because if you see here, I have not used any double underscores. So this is a user defined method. User defined methods are so methods that we define, and these are like tasks that we define on our own. So in my user defined method called getArea, I will be returning the area of this circle based on the radius that I pass to it. Now if you notice here, before in every method, I have this self keyword before any other attribute. So like this has self, even the getArea has self. Now what this means, self is like an optional keyword that is used to improve readability of a program, first of all. And it's also the function of the self keyword is basically telling Python that, any of the methods that we are invoking in this class or the instance of this class has to refer to attributes and variables within that instance of that class. So if I'm going to use getArea function, I'm going to get values and attribute values and variable values based on only the current instance of that particular class. Self is obviously optional. We don't really need it, but basically the first attribute of any method is basically what is the instance that the method is invoked upon. So if I say self, I'm telling this particular function that, okay, all the value that you're going to get for performing whatever task you want is going to be found in that particular instance where you have been invoked itself. Now don't worry if all this is very confusing. This might be in the beginning, but just try to understand that this is something that we do for good practice, and you will understand when to use self or when not to use self as you learn about object-oriented programming. So if you see here, my getArea function is supposed to return the value radius times radius. Self.radius is basically telling whatever value I've passed for radius for that particular instance. You can read this as radius times pi as well. So obviously this is pi r squared, which is the area of a particular circle. Now let me show you an example where I'm going to perform some of these functions. So if you see this first line, I have created an instance of the class circle where I've passed 2.1 for the radius of the circle. So now the value of the variable radius in this particular instance is going to be stored as 2.1, and this particular instance is going to be stored in the variable c1. Now the print c1 function invokes the str self-defined or predefined function. Now if you remember, it's basically used to return a particular string that describes like what the class will do, and this is something that we define on our own. In our example, str will return the string saying this is a circle with radius of, and then it will return the radius that we passed. So in this case, it should say this is the circle of radius 2.1, as you can see over here. So if I execute this, you can notice this line. This is a circle with radius 2.1, and this is invoked by the print function. The print basically invokes the dunder str function, which does all of this. Now in the next line, we say print c1.getArea. So this is going to print the value of what gets returned when we invoke the method getArea for this particular instance c1. So obviously in this particular instance, our radius is 2.1. So the getArea function should do pi times 2.1 squared. And the value is, as you can see here, is some 13.85. So that is the area that we got. Now if we want to print a particular radius, we just say print c1.radius. So this will print the value of what is stored in radius for the particular instance c1. Now you might notice me using a dot whenever it comes to defining a certain function or a keyword. Well, anytime that we want to invoke or use a method of a particular class, we have to use the dot keyword. So we use the instance name c1 dot followed by whatever method that we want to use. So if we want to use the getArea function, we say c1.getArea. If we want to find out what is there in the radius radius variable of a particular instance, we say c1.radius. Now before we move on, let's talk about some of the naming conventions. Class names are initial capitalized. So if our class name is, for example, if it's camel case, well, each word that is part of this class has its first letter capitalized. Variables and method names are in lower class. So if my class was called circle, we say class circle with C being in capital. Now moving on, let's talk about how we initialize or define instance variables. Now instance variables are declared within the init method. If you remember from the earlier example of circle, init is a dunder method. It's followed and it's preceded by double underscore, as you can see here. Now if you see in this particular case, I have again used the self keyword, and as I mentioned earlier, the self keyword is the first parameter of all member methods. And this basically binds that particular method to the particular instance itself during invocation. So every time a new circle object is created, the .init function sets the initial state of the object by assigning the values of the object's properties. So the init function basically initializes each and every new instance of of our class. So we can give init any number of parameters, but the first parameter must always be a variable called self. Now when a new class instance is created, the instance is automatically passed to the self parameter in init so that new attributes can be defined on the object. Inside the init method, the self.radius basically means that we want the value of radius based on the current instance itself. So as you can see, radius defines an instance variable radius, and we're going to use the particular instance and its value for radius in our variable radius. Now the init function is not a constructor, but it is an initializer to create instance variables. The init function also will never return a value, and it is optional and can be omitted if there are no instance variables. Now let's move on to class variables. So now, as we mentioned earlier, all the attributes that are created inside the init function are instance-specific attributes. And the instance attributes are obviously specific to a particular instance of the class. For example, all dog objects. Now, if we have a class called dog, then all dog objects have a name and age, but the values for the name and age will vary depending on which dog we are talking about, or basically which instance of the dog are we talking about. Now, class attributes are attributes that have the same value for all class instances. And we define a class attribute by assigning a value to a variable outside of the init function. So if you look at this example over here, we have created another class called circle, and we have this initializer again, where we have a class specific variable called radius, whose value will change depending on whatever we pass for that particular instance. However, if you look before the init function or the initializer function, if you see here, we have another variable called shape object, which stores the string circle. And this variable is going to be the same and constant for every instance of the class circle. And unlike the variable radius, we will not have different values depending on a particular instance. Okay, now let's talk about instantiating an object, and let's see what happens when we create two different instances of the same class. So as you can see here, I've created an instance C1 for class circle, and I'm going to check its ID. Well, if you see, the ID is something like this. Now, if I created another instance over here called C2, and if I check its ID, well, it's something different now. So if you see, each instance basically has a different memory location in our memory, and this is how each instance is different each time we create it, and they are created in different memory locations. Finally, before we conclude this topic on the introduction into OOP, let's talk about class methods, instance methods, and static methods. Now, class methods are actually declared with the @class method operator or decorator, as you can see here. It accepts the class as its first argument. So in this case, I'm going to define a class called myClass. I'm going to use this @class method decorator to say that whatever follows here is going to be a class method. And I've defined a class method called hello that takes in that uses again self and a name attribute. So what this does is it prints whatever I have passed to it in the form of hello from self.name. Now what this is going to do is basically it's going to give out a string saying hello from name of the whatever class we have and whatever we pass in the attribute name. So in this case, I'm going to invoke this method using the class name itself. I'm not going to use an instance name because I have no instance in this particular example. And since this is a class method, it can be invoked using the class name itself. So I'm going to pass Rakesh, and let's see what happens when we do this. As you can see, the first print will basically give us the information of the class itself. It's saying that the class is called my class, and the second print statement is basically a string saying hello from the string name my class with a comma and then whatever we passed initially, which was Rakesh. Next is then instance methods, and these are the most common types of methods. These are invoked by an instance object. So we have to create an instance to actually use an instance method, and it takes the instance or the keyword self as its first argument. So if I say if I define a class my class in this example, and I'm going to define another function called hello. As you can see, I have not used any decorator like at class method. So this is going to be an instance method, and it's going to be invoked by the particular instance. So in this case, it's going to print hello from, and it's going to basically say the name of the class again. So I create my instance called my instance1, and it's an instance of this class. And then I'm going to invoke the instance method by using this dot operator and the instance name. And the result will be basically this string over here, as you can see. Now finally, we have another type of method called the static method, which is declared using the addStatic method decorator. So a static method does not know its class and is just attached to the class for convenience. It does not depend on the state of the object and could be from a separate function of a module. A static method can be invoked via a class object or an instance object. So if you look at this example over here, I have defined a static method. I've defined hello, and it basically says print hello world. So it's going to basically just print this. So if you can see here, I've created my instance and I'm going to say dot hello. It should basically print hello world. That's all. So guys, this was it for the introduction on OOP. In this video, we will continue our discussion on object-oriented programming. In an earlier video, you might have gone through the introduction into OOP. In this video, we will continue that discussion on OOP with inheritance. Inheritance is used to describe the relationship between two classes, wherein one class takes the methods and properties from another class. In this relationship, we have something called the base class or the parent class, from which we will derive all or some of the properties and methods. And the class which actually derives these properties and methods is known as the derived class. So you can think of the derived class as a specialized version of a base class. To explain what inheritance is in a basic way, I will show you an example where I'm creating a cylinder class, which is going to be a subclass of the circle class that you might have encountered in the earlier video on OOP. So what we're going to do is create a cylinder class that is a subclass of circle, where we're going to get the attributes radius and get area from circle class, and we're going to add the attributes height and get volume to the cylinder. So right off the start, you can see we have our class circle that you might have seen in the earlier video. So this class circle has the familiar initialization where we are supposed to enter a value for a radius that gets stored in self.radius. And we also have a description string, which basically is a dunder method that returns a string when we invoke the print command on a particular instance. And we have the getArea method as well. Now if we move on to the cylinder class, you can see that I'm defining this class with the class keyword with the cylinder name, but you can see that I have added a parenthesis, and within it I have mentioned the name of the superclass that I want the cylinder class to be a subclass of. So this is how we actually define a subclass in the most basic way. You enter the name that you want, and you enter the name of the superclass that you want the subclass to be a subclass of in parentheses right after the name. Now next, if you move on to the dunder initialization, the initialization is very familiar, except now we have another attribute for height, which has a default value of 1, just like the radius. So this basically means that we have an option of entering two different attributes for our cylinder instances. Now if you see here, there's a line which says super.init. Now this is like, this is a command which we use to invoke the superclass's initializer. So anytime we create an instance for cylinder, we also want an initialization for the circle method as well as a part of our cylinder instance. Next, you can see that much like how we stored the radius attribute in self.radius, we're also storing the height attribute in self.height. Now even this cylinder class has an str method to return a particular string if we use this print function. And finally, we get on to a new method that we have defined only for the cylinder class called getVolume. Now, if you see the getVolume, it returns us basically the volume of the cylinder that is being described in the particular instance, for which we enter the height and the radius. So if you can see here, what we've basically added extra is a height attribute and another method called getVolume. And the other parts of the circle superclass, such as radius and getArea, are also going to be a part of cylinder, even though you do not explicitly see them anywhere here. And we will see how in the form of an example that's coming up. So let me just execute these classes. Now that that's done, I'm going to create an instance for cylinder. I'm going to store it in cy1, and I'm going to pass 1.1 for the radius and 2.2 for the height. And once that is done, let's just print to invoke the str method. And as you can see, the str method basically tells us the information that it's a cylinder with radius 1.1 and height 2.2. So now let's print what is the value we get when we use the getArea method. Now it's important to note getArea was not explicitly defined in the cylinder subclass, but it's a method that is a part of the circle superclass. And we can see that we can actually access methods that are part of the superclass simply by accessing any other method. So if we use the .getArea, you can see that we get a value for the area of the cylinder. So this area is basically the area of the circle face of the cylinder, the top or the bottom. Now let's invoke the subclass specific method, which is the getVolume method, in a similar manner. As you can see, just by invoking this method, we get the volume as well. Now, if we want to see what is the radius and the height, we can just do a simple print statement followed by cy1.radius, cy1.height, and it gives us both of these values, as you can see here. Now over here, what I'm going to do is create another instance of cylinder, but I'm not going to pass anything for radius or height. So basically, it's going to take the default values for radius and height, which was 1 and 1 respectively. So once I print, this statement is basically going to print the str method, or whatever we stored in the str, which is basically the description of the object followed by what is its radius and height. This method will give us the area, and this method will give us the volume. So once I execute this, as you can see here, this is what we get, and this is what we expect as well. So now in this example, what I'm going to show you is now I'm going to go back and I am going to create another instance for circle. Now this is the superclass, of course, and I'm going to give it, and since the superclass has only one option, one attribute that we can enter, which is for the radius, so I pass 3.3, and I'm going to print what happens when I just print this instance. It's going to basically give us whatever was a part of the str method. After that, I'm going to print isInstance. This is basically a check on whether C1 is an instance of this class circle, and next I'm going to check if C1 is an instance of its subclass cylinder. Now when I execute this, you can see that this is the str method that gets printed. But if you see here, you can see that it says C1 is indeed an instance of circle when it says true over here. But when we look at the next line, is C1 an instance of cylinder? It says false, and this is obviously because a superclass object is never an instance of a subclass object, whereas vice versa, it would be true. Now in the next part of this video, what we're going to do is look at the different types of inheritances in Python. So there are basically 5 types of inheritance in Python. There is the single inheritance, there's multiple inheritance, multi-level inheritance, hierarchical, and hybrid inheritance. So we will go one by one and see each of these examples. Starting off, we have the single inheritance. This is simply where we have one base class and one derived class from that base class. So this is just simple single inheritance. And in this example, you can see I have a class called country, where I have a method that I have defined called show country, which is basically going to say print this is India. It's basically going to go print this every time we invoke this show country method. Then we have a class called state, which derives from the superclass called country, where we have a method called show state, which is going to say print this is state every time. So you can see I created an instance of the class state, and through that instance I can access the superclass and the subclass methods over here. Next we have the multiple inheritance, and this is when a derived class contains more than one base class. So let's look at an example to understand this. So if you can see here, I have a class called student with 2 methods defined called method 1 and method 2. In method 1, we can pass 2 attributes, SN, SNO, or I think it is This is supposed to be like an ID, I guess, like SN number, and we have S name. So this is basically two attributes we can pass that are probably descriptors for a student. And in the next method, you have basically two print statements which says student number, and then they will print the student number, and it will also print the student name. Next, we have a class called marks. This is also, so these two classes are basically what our super classes are going to be, and we're going to derive a third class from these two. So this second class is a class called marks, and we have two methods again. One method is called set marks, which has the option of putting in two attributes, m1 and m2, both representative of the two marks, and we store them in self.mark1, self.mark2. The second method is put marks, which is going to print the marks, namely mark 1, and then it's going to tell us how much marks are there in the first subject, for example, and another print statement doing the same thing for the second subject, or mark 2. Finally, we have a third class called result, which derives from two classes, marks and student. As you can see here in my parenthesis, I've passed in marks and student. Both are super classes, and our class result is going to derive from both of them. This is an example of multiple inheritance. And within this class result, I have two methods specific to this derived class called calc, wherein I'm going to basically calculate the total marks of the total marks, which is basically the addition of mark 1 plus mark 2, and I'm going to have another method called put total, which is going to print me what is the total. So if you can see here, I have created an instance of this derived class called result, and I'm storing it in R. Then I'm going to access method 1, which is obviously a method from the first superclass called student, and I'm going to store, okay, so his name is, I guess, Lucky, and he has 60 marks. Secondly, then I'm going to do R set marks, which is the method from the second superclass, which is going to set the marks respectively. So you have Lucky student, and his ID is 60, and he has got 50 and 60 marks respectively in, say, the first two subjects. And finally, I'm going to access the derived class method called calc. So this is going to do the sum. Finally, I'm going to also do our method 2, which is going to print our student number and his student name. Next, we're going to have put marks, which is going to tell us the what are the individual marks for mark 1 and mark 2. And then finally, we're going to print the total marks with put total. So once I execute this, you can see here it says student number 60, student name Lucky, marks 1 is 50 as I written here, marks 2 is 60 as I passed here, and then total is 110, which is basically 50 plus 60. Our next type of inheritance is called multi-level inheritance. Now multi-level inheritance can be assumed as where you take a superclass, let's call it A, and you derive a class B from that class A. Now what if we derived a class C from B, and we kept doing this? So until, say, a class E. Now each of these steps is in its own an inheritance, but this whole relationship can be described as a multi-level inheritance. So let's take an example again. So this time I've defined a class called student, where I have defined two methods called set stud and put stud, or you can call it set student and put student. In my first method, I have two options of adding two attributes. Again, this is the student number, this is the student name. In my second method, I am going to print what is the student number and what is the student name. Finally, next we have another class called marks, which derives from the first class called student. This has two methods called set marks, where I'm going to again get the option of adding two integers for m1 and m2, which is going to represent mark 1 and mark 2. And finally, I have put marks, the method which is going to print mark 1 and mark 2. Finally, I have another class called result, and this, if you see, this derives from marks. Now, if you see this relationship, you'll notice result derives from marks, whereas marks itself derives from student. And this is an example of multi-level hierarchy. And even as a part of this third class, we have its own methods called calc and put total. Calc will calculate the total as we had seen earlier, and put total will basically print that total. And we're going to do a very similar operation. We're going to create an instance of this third class result and store it in R. Then we're going to do basically, we're going to set the student details, his student number and his name. We're going to give him his marks 50 and 60. We're going to calculate what are the total. We're going to say, okay, now put the details of what is the student's number and name. We're going to also display his marks, mark 1 and mark 2. And finally, we're going to display the total marks. So let's execute this. And if you see, it's basically the similar operation that we did earlier. but the only difference is in the earlier example, our third class result was derived from marks and student together. So this was an example of multiple inheritance, whereas in this example, the result class derives from marks and marks itself derives from student. So this is an example of multi-level inheritance. Finally, we have, penultimately we have as our fourth example of inheritance called hierarchical inheritance. Pardon my mispronunciation, it's hierarchical inheritance. So in this case, a base class basically will contain more than one derived class. So let's look at an example of what we mean here. So I have a class called 1 where I have defined a method called display, where what I'm going to do is I'm going to store self.x is equal to 1000 and self.y is equal to 2000. Then what I'm going to do is I'm going to print a statement saying this is the method in class 1, and I'm going to say after that I'm going to print another statement saying value of x is self.x, which is going to be 1000. Then I'm going to have another print statement saying value of y is self.y, which is going to be 2000. Finally, next I have another class called 2. This is going to derive from class 1, as you can see here. And in this class 2, I have defined another method called add. And in this method add, what I'm going to do is I'm going to first print a statement saying this is the method in class 2. And then I'm going to actually print the result of x plus y, which is 1000 plus 2000. Finally, I have another class called 3. And this is also deriving from 1. So if you notice, we have one parent class called 1. And from this one parent class, we're going to derive two different subclasses called 2 and 3. So this is an example of hierarchical inheritance. Now in this class 3, what I've done is I've defined a multiplication method. What I'm going to do is print, first of all, I'm going to print this when I invoke this method, that this is the method in class 3. Finally, I'm going to say, I'm going to print the result of x times y, which is 1000 times 2000. So if you see, I am going to create an instance of 2 and I'm going to create an instance of 3, and I'm going to store them in T1 and T2. Now since T1 is an instance of 2, so I can access its methods add and I can access its methods display. So I'm going to use T1.display, and even in T2, since it's a class, it's an instance of class 3 and this also derives from class 1, I can also access its method display, but now I cannot access add, but I can access multiply. So if you see here, I access add through T1 instance, since add is a part of class 2, whereas multiply is a method in class 3. So I access it in its respective instance, which is T2. So if you see here, now once I execute this, what you will get is basically the results. So first of all, it will basically display the method from class 1, which is the display method. It will display the values of x and y. And since I've done this twice from two different instances, it will basically show a repetition over here. Finally, I've done the addition, and since this is a method in class 2, it is going to say as much, that this is a method in class 2, and then it's going to say x plus y is 3000. And now multiply is a method in the third class, so it's going to say this is a method in class 3, and it's going to tell me what is the multiplication result. Finally, we have what is called hybrid inheritance, and this is a combination of multiple plus multi-level inheritance that you saw earlier. So let's again understand this through this example. So we have a class called student, where we have a method called setStudent. Again, two attributes we can pass here for student number and student name. Next, we have another method, part of the class student, called putStudent. So this will print us the student number and student name. Next, we have a class called marks, and this marks inherits from student. So we have a method in class marks called setMarks, where we can pass two attributes for mark 1 and mark 2 respectively. And as we had seen earlier, we also have a putMarks, which will display the marks for marks 1 and marks 2. We have a class called practical. This practical is basically another superclass. If you see here, since this does not derive from anything, it is a superclass on its own. And what it does is it has two methods, getPractical, and we can pass an attribute for p1 here, and we store that in self.p1. And then we have an attribute for putPractical, which will print us the practical marks, whatever we passed for this attribute in p1. Finally, if you see, we have a class called result. Now in this result, we are going to derive from marks and practical. But if you notice here, marks itself is a subclass of student. So this is an example of multi-level inheritance. Whereas since result derives from marks and practical both, it is also an example of multiple inheritance. So if you see, notice here, this is an example of multiple and multiple level inheritance, which is basically what we call hybrid inheritance. And as we had seen earlier, this result class will have a calc method to do a total of the marks. In this case, mark 1 plus mark 2 plus the practical mark P1. And we have a put total method, which is basically going to print us the total. So now we're going to create an instance of this result. And through this instance of result, we're going to first invoke the parent class method called setStudent, which is the second level parent, basically the student class setStudent method. So we're going to setStudent here. We're going to say 60 is the student ID and name is Ash. Then we have setMarks, which is again the second level parent, which is a student class, where we set the marks. Finally, we access this getPractical. Now, if you notice, getPractical is part of the practical superclass. So in this, we store the third subject, or the practical marks 100. Then we calculate the total and we put first the student details, then we put the individual marks, then we put the practical marks, and finally we enter what is the total. So let's execute this. And if you notice, you will see here student number is 60, student name, and all the basically whatever details we wanted is shown over here. So this was it, guys, for our video on inheritance. In this video, we will continue our discussion on object-oriented programming with the topic of polymorphism. Now, the term polymorphism in OOP refers to the ability of an object to adapt the code to the type of data it is processing. Polymorphism is one of the key concepts of Python, and it is also a built-in feature of Python. An example to get us started on polymorphism would be how we use the plus operator. We use the plus operator not only for arithmetic additions, but we also use the plus operator for stuff like string concatenations or joining two lists together. This example, where we are able to use the plus operator for different operations, is an example of polymorphism. To show you what I mean, I have basically done a simple addition operation here, where I'm adding two variables, number 1 and number 2. When I do it on integers, it basically adds 1 plus 2. Now when I use it on two strings, str1 and str2, which contains Python and programming, two separate strings, and when I use the plus operator on these, you can see what it does here. It forms one string containing both of these individual strings. So this is basically the plus operator showing polymorphism, and is one of the simplest occurrences and yet most common occurrences of polymorphism in Python. Another example of polymorphism would be through the length function. The length function in Python is something that we use a lot and over multiple data types. Depending on the data type that we use the length function for, we get a different value or a different sort of information from the length function. Now, if you see here from this diagram, when we use the length function on a string, it gives us the length of the string. When we use the length function on a list, it gives us the number of items. Whereas if we use the length function on a dictionary, it gives us the number of keys. So this is, well, another example of how we have polymorphism in a function. Now what we're going to do is look at the different techniques through which we can enable polymorphisms in our code. Our first example that we are going to look at is through method overloading. Now, method overloading in its traditional sense, where we can have a method with the same name, more than one method with the same name in the same class, is not exactly possible in Python. So if we have multiple methods with the same name in a class in Python, which may differ in types and number of arguments, are not allowed and not supported in Python. In fact, if we did something like this, where we created a method with different say types and number and arguments, but having the same name in the same class, then what Python will do is it will only recognize the last defined method, and it will not recognize any of the earlier methods with the same name. But we can simulate polymorphism through method overloading by using default arguments in a method. Now, for example, what I'm going to show you here is an example where I have a method called sum. Now, by default, it has three attributes that you can pass through this method. A does not have a default value, B does not have a default value, but if you notice, C has a default value 0. So this is a simple example where I'm going to show you that the sum method is going to be used in two different cases. In one case, we're going to simply add two numbers, and in another case, we're going to use the sum method to add three different numbers. So we have this class overload demo, within it a method sum, and I have three attributes. A and B are supposed to be given by the user since they do not have any default values, whereas C has a default value 0. So if you see here in my first case, I first of all created an instance called OD for the class overload demo, and I have what I'm going to do is I'm going to store the value of the sum of 7 and 8 in the variable sum. Now if you see here, I have not passed a third argument. So what this method is going to do is it's going to take the value of c as 0 by default. So it's basically going to do 7 plus 8, and it's going to give us the sum for 7 plus 8. And in the next instance, I'm going to give 3 arguments, 7, 8 and 9. So now c will be replaced by 9 instead of 0, and then I'm going to get the sum of 7, 8 and 9. So in this is not a very commonly used thing, but it's basically a method just to show you that we can actually simulate method overloading in Python by using default arguments. So I've basically shown you how the same method sum has been used to do the addition of 2 digits, and then in another instance is doing the addition of 3 digits. It might look very similar, but you'll basically notice that by having this third attribute c, I have a default value of 0. I have induced some form of polymorphism through method overloading. Now the next way that we can induce polymorphism is through inheritance, which is called method overriding as well. Now method overriding gives us the ability to change the way or change the implementation of a method in a child class which is defined already in one of its superclasses. Now if there is a method in a superclass, the method having the same name and same number of arguments in a child class, then the child class method is going to override the method in the parent class. So what we do is when a method is called with the parent class object, the method of the parent class will be executed. Whereas if we call the method using the child class object, the method of the child class will be executed and it will override the method in the parent class. So the appropriate overridden method is called based on the object type, which is an example of polymorphism. So let's look at an example to understand this. So we have a class called person, and we have defined what we're going to define the initializer is 2 attributes which we have to pass called name and age, and we're going to store them in self.name and self.age. Now we have a user defined method called display data, where we're going to print if this display data has been called through the parent called person. If it's going to be called through the parent class object, then we're going to print in parent class display method, and then we're going to print the name and age that we have entered. Now we have another class called employee, which is going to be a derived class on person. So it's going to so it's also going to have an initializer, and this constructor will basically what this initializer will have is it'll have an constructor for the superclass, where we're going to do this the same initialization that we do in the superclass, but we're also going to store another attribute called id in self.employeeID. And if you see here, we also have another method called display data, which is the same named method from person. But now if you see in display data, I have almost the same information. I'm going to print the name, I'm going to print the age. But if you see the first statement, I'm going to say, if I'm going to call this method from the employee object, then I'm going to say in child class display data method instead of in parent class display data method, to say that basically I'm invoking this method from the child class object. And I'm also going to print on top of the whatever I'm printing before, I'm also going to print the employee ID. So if you see here, I have created an object called person, which is an object of the class person with the information of name John and age 40. And then I'm going to display this. Now next I'm going to create an object called emp, which is the child class employee object, which is going to now have the same information of John for the name and age 40, but now it's going to have an employee ID. And then I'm going to store this in emp, and I'm going to display the data for this child class object, and we will see the difference in how the display data is differing from the earlier case. So when I execute this, you see in the first case it says in parent class display data method. So this display data has been called through the parent class object, and I'm only going to show the information of name and age. Whereas when I invoke this method from the employee class object, it's going to say it's going to specifically say that it's a in child class display method, and then I'm going to say the name, age, and also the employee ID over here. So this is the difference between how display data has been used in its parent and its child class, and this is basically the example of method overriding. Now our next example of polymorphism is going to be through operator overloading. And operator overloading is the ability to overload the operator to provide extra functionality in addition to its real or core operation. And operator overloading is also an example of polymorphism, as the same operator can perform different actions. The earlier example of where we use the plus operator for different operations is an example of operator overloading polymorphism. Now, when is operator overloading required? Well, anytime you want an operator to perform a different function for you in your custom objects, you would basically do operator overloading. Now, an example of this would be what I'm going to show you below. So if you see this class called point, it has an initializer where I'm going to store two attributes x and y in self.x and y, and in self.x and self.y. Now I'm going to create one object called p1 where I'm going to create point 1 and 2. So you can think of this object as basically like a coordinate, x coordinate 1, y coordinate 2. This is one point, and another point called x coordinate 3, x coordinate 4. I'm going to call that p2. Now I want to print p1 plus p2. Alright. Now if I try to execute this, you will notice an error. It says unsupported operand types for plus, point and point. This basically means that plus does not know what to do when it's given an object of this type. It has no idea what to do. Whereas what we want it to do is add the x coordinate from this point and the x coordinate from this point. So we want it to do 1 plus 3, and we also wanted it to do this y coordinate plus this y coordinate, or 2 plus 4. And then we want to print basically like something like 4, 6, or the addition of the 2 points, or the vector addition of these 2 points. So this is what we want this plus operator to do, but the Python does not have any inbuilt feature for the plus operator, and we are going to have to basically do some operator overloading to create a polymorphism on this. So let's see how we can do that. So to do that, first of all, we have to understand that all operators in Python have internally defined methods to provide functionality for these operators. The operator, or the special method to provide functionality for the plus operator in Python, is the add method. And whenever the plus operator is used, we are basically internally invoking the add method. So these sort of internal methods that provide functionality for the operators are part of a bigger class of methods known as magic methods. And these magic methods are automatically invoked whenever its corresponding operators are used. So if we want to change the operation for the plus operator in this example, we are going to have to use the add method in this case. And since it's a magic method, magic methods are also are basically what we saw earlier in the form of dunder methods. So magic methods are going to be invoked using double underscore, a prefix and suffix to it. So similarly to how we defined an init method or an str method, we are going to also invoke the add method using the same double underscore before and after its name. So now let's see how we're going to do this. So if you see this class, I have now my class point, and I have the same initializer when I'm going to store x and y. Now I am going to define on this add magic method, I am going to override the normal functionality of plus, and I'm going to give it a very specific function where I'm going to say for two different objects, you're going to add its the first part or its so-called x coordinate with the other x coordinate, and the y coordinate with the other y coordinate, and you need to return this to me in the form of a similar object. So now when I pass 1 and 2 and 3 and 4, it should return me 4 and 6. As you can see here, I have basically done what I wanted to do by operator overloading. I have changed, or I have overloaded this plus operator using this add magic method, and I have created a new functionality for this add function for these 2 points 1 and 2, 3 and 4. Now I'm able to add 1, 2, 3, 4 in the way I wanted to. So now that you saw how we did operator overloading, I'm just going to show you a list of similar magic methods for different operators that we are familiar with. So the plus operator already we've seen has the add method. Then we have the minus operator with the sub method, and similarly we have for all of these operations such as multiplication, division, we have its respective magic methods. These magic methods are again prefixed with 2 underscores and suffixed with 2 underscores, and they are also called dunders in Python. So this is how we would do operator overloading in Python for whatever operator we want. Similarly, we can do this for like comparison operators and for unary operators as well. So look at this example now where I'm going to overload the multiplication or the asterisk operator. So I've again defined a class called point, and I'm going to define an initializer where I'm going to store some attribute x in self.x. Now what I'm going to do is I'm going to overload the multiplication operator, where I'm going to basically allow the this asterisk operator to multiply 2 objects from, like, for example, 12 and 5. Usually I can just do a normal 12 times 5, but in this case my object is slightly different. My 12 is being passed through an object of a class called point, and 5 as well in another instance of the same class. Now when I want to multiply these class instances, like the multiplication operator does not perceive these class instances to be integers. So by default it would not be able to multiply what we want to multiply. But when we define or we overload the multiplication operator within our class, it's now able to understand what to do using the attributes of these classes in its respective class instances. So it's able to say, okay, so I want this attribute from this particular instance P1, 12, and I'm going to multiply it with the attribute 5 from instance P2 whenever I say P1 times P2 or P1 asterisk P2. So when I execute it, it will give me 12 times 5. Similarly, I can also do this for the greater than operator over here. So I have a class called person where I'm going to define an initializer where I'm going to pass name and salary and store them in self.name, self.salary. The GT method is basically the greater than method, magic method, and it's going to we're going to use this to overload the greater than operator. And now again, using this greater than operator, I'm able to basically say object 1 greater than object 2, and I'm basically able to check through this, and if object 1 is greater than object 2, it will basically tell us if it is true or false, or basically whatever like we want to know. So basically the print statement will check for object 1 dot name, and it will say earns more than object 2 dot name if in case object 1 is indeed greater than object 2. So when I execute this, you can see here my first information says John is earning 4,500 of some units, Natasha is earning 6,000 of some units. So it will say John earns more than Natasha. Well, it's false because object 1 is not greater than object 2. So since 4,500 is not actually greater than 6,000. And this is the check that I'm doing by overloading the GT operator over here, where I'm returning the Boolean value of what is greater, self.salary or other.salary. Self being the first object in any comparison. So if I'm basically any comparison, if I'm doing 5 greater than 6. So what the GT will do is this will be the self object and this will be the other object. So this is what I'm doing over here. I'm checking self.salary with other.salary in the form of these objects. And it's basically the same way that we are able to do 5 plus 5 through these class instance objects that you saw earlier, or 12 times 5 that you saw earlier. So this is all examples of operator overloading in Python. Well, this was it for polymorphism. In this video, we will be learning about exceptions. Exceptions are errors that are raised during the execution of a program. When an error occurs, Python generates this exception that can be handled, which avoids our program from crashing. Python has many built-in exceptions. However, we can create many user-defined errors or exceptions as well to catch whatever errors we're looking for in our program. So when an error occurs, Python interpreter raises an exception and stops the current process, and it passes it to a calling process until the exception is handled. And if this is not handled, the program will crash. Some of the built-in exceptions are like IO error, in the case when a file cannot be opened, or import error, Python cannot find the particular module being imported. And there are so many similar, exceptions that are built in Python for the appropriate cases. Now, before we move on and see how we raise these exceptions, let's look at the difference between an exception and a syntax error. So for that, I will be using an example where I will be dividing something by the number 0. Now, of course, this is not possible. So let's see how Python handles this particular problem. Well, it raises what we call a zero division error. And this is an exception that is built in Python whenever we try to divide something by 0. Now let's look at the difference between this exception and a syntax error. So this is the same statement, except I'm going to add this extra bracket, which does not make sense syntactically in this. Now if I try to execute this, as you can see, we get a different type of error known as the syntax error. And it says the unmatched closing bracket. So this is what a syntax error looks like an extra bracket or a comma that basically makes the line unreadable to the interpreter in the first place. So the interpreter doesn't even get to the point where it needs to figure out that there's something being divided by 0. It doesn't even get to that point because it finds this extra bracket and it cannot execute this line at all. So that is like the difference between an exception and a syntax error. Alright, now for our first case of how we raise or how we handle exceptions, let's look at the keyword raise. So for this example, what I will be doing is I'm going to take this variable x, alright, and I'm going to store a value 10. And what I'm going to do is I'm going to check for a condition. If x is greater than 5, then I'm going to raise this exception using the raise keyword like this. And in case this condition is met, if x is actually greater than 5, I want this particular message to play out in my exception. So let's see what happens when I execute this. As you can see, the exception is raised because x is indeed greater than 5, its value is 10, and the error message says as so, that x should not exceed 5, the value of x was 10. So this is an example of how we can raise an exception. And as you can see, when a condition was met, the program comes to a halt and an exception was raised. Now let's look at another type of handling exception, where we use the assert statement. So when we use the raise command, we waited until an error occurred and our program crashed midway, right? What if we want to check if a condition is met? And if this condition is met, then the program can continue. But if the condition turns out to be false, then we want a particular error, namely the assertion error exception, to be thrown to us. So we can use the assert command in such a case. So in our example, we will be checking whether the system that we are working on is actually Linux or Windows 32. So let's see. First of all, let's import a library called sys. This is it's a library where we can access system information. One of the modules in that is one of the functions in that is the platform. It basically tells us what system are we working on. So we're working on a Win32 system. Okay, so let's use the assert keyword. All right, now we're going to check if Linux is what we are working on, and in case it is not, then we want an error message, and this will be the error. The error will obviously be an assertion error because we are using the assert keyword. So this is how we use the assert statement. And if we execute this, as you can see, we get the assertion error because sys.platform contains Win32 and not Linux. And so we got this assertion error. So if we change this to check for Windows system, we won't have any error when we execute this, as you can see. So this is the example where we use the assert statement. Another way of handling exceptions is by using the try and except block. So this is probably one of the most common ways of handling exceptions in Python, where we use a try keyword and an except keyword. Now within the try keyword, as you can see here, we have a chunk of code which we're going to check. And if everything is fine in the try keyword, then this is perfect. So we don't need to move on to what we call the except part of the try and except block. But if say there was an error in the try block, then we move on to the except block, where we're going to run the part of the code in the case we find an error in the try block. So first we check the part of the code that is under the try block, and if there is an error, we move on to the except block and we run that part of the code over there. And in the except block, that is where we handle our whatever error that might get thrown our way in the try block. Okay, let's look at an example at how to use this technique. So I have a basic function out here. All right. It's defining a function called Linux interaction. What this is basically doing is that when I call this function, I want to do an assert check. I'm going to check if Linux is the system I'm working on, and if it is not, then I want this error to be thrown. Okay, and so yeah, let's see what happens in the case. And if this assert statement is actually passed, then we will move on to this statement. So you look at it like this: when I call this function, it will first check for this assert statement. In case something wrong happens and we get an assert error, then we do not move on to this line. So we only get this printed. But if this assert statement passes, then we move on to this line and we get print doing something. Okay, so let's see. Now I'm going to call this function out here. Let's see what happens here. As you can see, I get an assertion error because obviously this is a Windows system and not a Linux system, and I get this message. Okay, now let's see what happens when we use it in a try and except block. Alright, so now I have a try block over here in which I am going to try this function, Linux_interaction. If in case I find an error, I immediately jump from the try block into the except block. Now you see the slight difference in how we handle this. Like what happens? So as you can see, when we use the function explicitly, we directly went to what we call an assertion error. But when we use a try and except block, we will not use the assertion error because we are leaving the try block immediately and we're going to go into the except block, where the only thing we're doing is printing the statement. As you can see, we are not on Linux, found some error. Okay. Now what if we wanted to catch the error within this function itself, which was the assertion error? And we can do that explicitly like this. So now what I'm doing is I'm going to try Alright, and it's going to catch an error in this, right? So now in the except block, I'm going to say the assertion error that we found in this function in the try block, we're going to use that in our except block. So as you can see, we're going to print that assertion error. It'll basically print this statement: function can only run on Linux systems. As you can see here, function can only run on Linux systems. Function can only run on Linux systems. And the next part of the thing was the Linux interaction function was not executed. Okay, so this is something very important happening here. When we use this assert statement, the whole program is actually getting executed, right? But when we're using the try and except block, we are immediately jumping on, like the moment we catch an error, we are immediately jumping onto the except statement. And all the handling of the exception is done in the except block and not in the try block anymore. So we have to think of it like this, that the try block is only to check if a particular piece of code is does it have any errors or not, and in case it does, then all the handling that we do is in the except block of this particular statement. Now let's look at another example. In this example, I'm going to try opening a particular file. Now this file does not exist, so I will get a file not found error, and this is a built-in exception. And I'm going to catch that, and I'm going to print that error over here in the except block. Alright, so as you can see, file not found, and whatever error I have, I printed over here. Alright, so this is another a file not found error that we caught in our try block, and we're handling it in the except block. Now let's combine both of the examples where we use this Linux interaction and we also try to open a particular file, and we try to do both things in the try block. And since both of these contain errors, let's see what happens when we have multiple errors in a try block. So as you can see, in my try block, I'm not only doing this Linux interaction, I'm also trying to open a particular file that does not exist, obviously. So now you might think, will I get 2 exceptions? Well, let's see what happens when we try to execute this. So it's important to note that in our except, we have an except for catching a file not found error, and we also have an except for finding the assertion error that is part of this Linux interaction function. So since both of these are erroneous statements, or they will throw exceptions. So now the question is, will we get both of these except blocks, or will we get both of these exceptions? Will we get only one of them? Will we get the first one? So let's see what happens. So as you can see, my error statement is very much like the assertion error that we had done as part of this Linux_interaction function. Function can only run on Linux systems. The Linux function was not executed. So as you can see, that is the one that has been caught, and for some reason the file not found error has not been caught. And this is because this is a very important feature of the try block. The moment we find the first error in our try block, we immediately leave and we do not execute any of the further statements, and we jump into the exceptions and we handle it using the except blocks. So the moment an error was found in this function, we did not execute this part of the statement, and we directly jumped into the respective exception. That was the assertion error exception. So this is a key takeaway. So some of the other key takeaways when it comes to exceptions is a try clause is executed up until the point where the first exception is encountered. And in the except clause or the exception handler, we determine how the program responds to this exception. We can have multiple exceptions and we can differentiate how the program responds to each of these. And it's also very important to not use except clause on its own. It's very important not to use a bare except clause. Now finally, before we conclude this topic of exceptions, let's look at the else and the finally clause. So the else clause is used when we want to execute a particular piece of code in the case where we have no exceptions or no errors found. So let's look at this. Just like we had the Linux interaction function, I'm going to define a win underscore interaction. And this is going to check whether our system is Windows or not. In case it is not, then we get this error message. Alright. And in case it is a Windows system, we print this in the case of when we call this function. So let's again use our try and except statement. Only in this case, we will be using an extra else clause. So we first try this function. In case there's an error, we catch it as an assertion error and we print that error. But if there is no exception, then we move on to the else statement and we print this. So as you can see, our we have actually moved on to the else statement and we print this line executing the else clause. And that is because we have found no exceptions over here. So again, it's key to remember that the else clause is used whenever we want to execute a particular statement in the case where we do not find any exceptions in the try block. The finally clause is used when we want to execute something regardless of whether we have an error or an exception or not. So no matter if an exception happens, is raised, or if it's not raised, we want this finally block to always get executed. And let's look at let's look at an example of it being used. So I have this block where I'm doing a lot of things. The first thing that I'm doing is I'm going to check for this Linux interaction function, which is going to check, of course, whether it's a Linux system or not. This is I'm doing the try block. Now, if I catch an error, I want to handle it by simply printing the error over here. And in the event that there is no error, then I will move on to the else statement and I will try this particular block of my statement, which is again that where I'm trying to read a particular file that does not exist. And it's very important that you note that within the else block, I have another try and except block, and this is perfectly legal and it's perfectly valid in our program. We can do this. So think of it like this. I'm first trying this. If I have an error, then I do this and I don't execute this. But if I don't have an error, then I execute this whole statement, which contains its own try and except block. All right. But regardless of whether I get an error here or not, I will always execute this portion of my statement or under the finally clause. So let's execute this. As you can see, of course, the error is raised in this try block. So we move on to the exception, and that is what is printed over here. And after the exception is done, we move on to the finally. We of course skip this else block because the exception was actually raised. So after that is done, we move on to the finally block where we print this particular statement. Well, that was it for an introduction into exceptions in Python. I hope you learned something from this. And of course, this is just the beginning. Exceptions are something that you would probably encounter a lot, especially when you're beginning. And it's something that you will learn to extensively work with. And that will also help you improve in your programming. In this video, we will be taking a brief introduction into what is a function. So, a function in Python is a group of related statements that performs a specific task or tasks. Now, functions help break our program into smaller and modular pieces of code. And it's very good and very convenient to use functions to make our code organized and manageable, especially as our overall program grows larger. It also helps us to avoid repetition and makes the code reusable. So let's look at the basic way of defining a function. So this is a basic function that I'm calling fun_name. Alright. Now the rest of the function, or whatever the task is going to be performed by this function, will be written over here with an indent, of course, as a standard when it comes to Python. So I'm going to define this one something in triple double quotes. So don't worry about what this is right now. This is a doc string. Don't worry about what this means, and I'll explain it to you just in a short bit. Alright. Now the rest of the statement, the rest of it will obviously be what this function will do. Let's include a simple print statement. Alright. Let's done here, and let's call this. So of course, now once you define the statement a function, to call the function, you just have to use its name like this. This is how you call a function. So as you can see, when I call this function, it should print the statement hello. Now let's look at some of the like what happened over here. So we've used the keyword def to define a function. We give it a unique name, which makes it with which we uniquely identify this function. And also, once we've done this, we can give this function a particular header. It's called a doc string. So what this doc string is basically something that we include in triple quotes over here just after the def keyword. And this is like a brief. We can use this to give a brief brief information into what our function is doing. So we can say this function performs addition, this performs subtraction or whatever, like some basic information as to what our function does. So we can use a doc string for that. Of course, this is an optional thing. This does not have to be, we don't have to include this as well. Alright. But for the sake of this, let's just keep it here. After that, of course, rest of the function will contain whatever task we want to do with it, and that will be indented. Finally, we can also include a return keyword. And what the return keyword does is, at any point you find the return keyword in a function, you immediately leave the function and you go back to where this function was called. Okay. So Now let's see. Now there's also one more important component of defining a function, and that's parameter. Now if you've noticed over here, within these parentheses, I did not include anything. This is like an empty parenthesis, opening and closing. What if I said A, if I included some A and B over here? So what this means is, whenever I call this function, I need to pass two parameters, A and B. These can be like strings or numbers or whatever. But now it becomes almost mandatory that I pass these two things for my function to work. So let's define a function where I'm going to add A and B. So instead of this print statement, let's do this. I create a variable C, and in that I'm storing A plus B. Alright, and then I return C. So you can use a return, and you can return certain like variables along with the return statement. So I'm saying not only return from this function, but also give an output or return an output called C, which is the addition of A and B. Now how do we use this? Well, now instead of just calling the function like this, I'm going to include parameters. So I'm saying pass 2 and 3 to function name, where 2 will take the place of A and 3 will take the place of B. Alright, what will happen now is addition will take place and we will get returned the result. So let's see what happens now. As you can see, 2 plus 3, and I got the addition of 2 plus 3, and it returned me 5. So yeah, this was like a basic usage of a function and parameters. So of course, we can, if you want to know like what the docstring of a particular function does or says, you can use this statement. So let's say it's very important to like just keep a note in your while you're going through this or while you're learning that whenever we use some sort of a function which has double underscore, right? This is like a built-in command provided by Python within the Python library itself. So these are like built-in commands to check certain details. So I want to check what is the docstring, and this is how I do it. So let's do print. Let's print what is the docstring over here. This is a docstring. So this is basically what I wrote over here. I can change this to this, like this does addition, for example. Alright. Now this will say this does addition when I execute this line. So this is the way to check what is a docstring. Anyways, so now that you have seen a basic function or two basic functions that I defined for you and how we use them, what a parameter is, let's look at another concept that we call scope and lifetime of variables. So scope of a variable is the portion of the program where the variable is recognized. Alright. Now a parameter and a variable that are defined inside a function are not visible from outside the function. This is a very key thing. So if we define something within the function, we can only use it within this function, and we cannot use it once the function has already been executed, so as to speak. These variables and these parameters have what we call as local scope, since they are only recognized within a particular function. Now the lifetime of a variable is the period throughout which the variable exists in the memory itself. And it's very important to note that lifetime of variables that are defined inside a function are as long as the function executes. Once we return from a function, whatever we have defined within it are destroyed. So when we use a function, it will not remember the values of a variable from a previous iteration of a function call. So let's try to understand this example or this concept using certain examples. So out here I have defined a function where I'm going to create a variable my underscore var, my variable, and I am going to store the value 10 in this, and then I'm going to print. So whenever I call this function, I will always create this variable, I will store 10, and I will print the value of this. Alright. Now what I'm going to do is, I'm not only going to create this my var inside this function, I'm also going to create a variable outside. So you see there, now you might be confused as to, okay, how is the behavior going to be? Because outside the function, I have created my var with a value 20, but inside the function, I will always define my var as 10. Okay. Now I'm going to print. So what I'm going to first do is, I'm going to execute this function that I created initially, where I store the value of 10 in my var, and then I'm going to print the value of my var that was present outside the function. Let's see what happens. You can see two different things happening. So when I execute this function, it prints the value inside the function as 10. But when I print the next line, which says, okay, now get the value of my var, it actually prints a value of 20. And this is a very key concept, because what's happening here is when I initially call my function, within this function it creates a variable called myvar and it prints the value as 10. And the moment my function has been executed, it destroys this variable, and the variable which contained the value 10 is of course now destroyed, and all we have is the myvar that contains 20 from the outside. And when we print that, we get its respective value as 20. So you can also think of it like this. The myvar that is present inside this function is different to the myvar that we create outside. So the scope of the myvar within this function is local only to this function. And once the function is executed, that variable is destroyed. Alright. Now let's look at another case, or the other side of this case, where say we're dealing with variables that have a global scope. How do we deal with them? So let's create a variable called myvar. Alright. And I say I store 100 in this. Alright. Now if I define a function, I've stored myvar. Let's say I define a function. Define underscore, say again, same name, where what I'm going to do in this is I am going to print the value of whatever is there in myvar. Okay. So let's do print value of variable is value stored in variable is. Okay. Let's myvar. So let's see what happens when we do this. Let's call this function fun underscore name. See what happens here. So as you can see, the value, I stored a value 100 in myvar and I've called it inside the function. And this is because since I've defined it outside, I can use it inside as well. Now what if I try to change the value of this variable inside the function though? So let's see. If I did this, and now if I try to print, let's see, is this allowed? No, it's not allowed. In fact, I get an error. It says local variable myvar reference before assignment. And without going too much into detail, what it's saying is that the variable inside over here is still local to this function. And I have not defined this myvar as a global variable. So I cannot make changes to it within this function right now. And to change that, I can use the global keyword. What if I did global over here? So if I did global, and now if I said, okay, global myvar, and I declare this variable as a global variable. Now if I do this, now if I do the same incrementation, now let's see what happens when I'm trying to do this. You see, I get the value 101. This is exactly what I wanted, and that is because I've defined my variable to be a global variable within this function. So I can in fact make changes to it within this function. So this is how we use the global keyword and global variable. Also, just to make a quick note, there are three types of functions, the three types of categories in which we can divide functions. First one being built-in functions. These are the ones that are built into the standard library of Python. The other is user-defined functions. That is the ones which we define ourselves. And the third type is called anonymous functions. They're also known as lambda functions, and this is something that we're going to cover in a separate video. Now let's talk about the arguments that we pass in Python. So there are four types of arguments that Python user-defined functions can take. First one being default, the other one is required, then there is keyword, and then there is variable number of arguments. So the default argument is when, say, if I defined a function where fun underscore name, and I'm saying a comma b, right? But what if the user has not, say I want a default value of a and b each time when I use this function. So in the case where if, say, I don't pass a value for a and b, like this will always be used. So I can just say a is equal to 2 by default and b is equal to 3 by default. And then within this function, I will say c is equal to a plus b and then return c. So I do this, and if I say fun underscore name, and in case I don't pass any arguments here, let's see what happens. By default, I get the answer 5 because by default a is 2 and b is 3. But this is not fixed and I can always change this by passing my own values here, 5 and 6, and in this case I should get 11, as you can see here. Now the next type is required arguments, and when we are defining a required argument, we just simply do not use the equal to sign for the parameters over here, and this basically it makes it so that now anytime we call this function, we have to pass something over here. So now if I try to pass like this, I won't get a default value. Then that's because well, there is no default value and it needs an a and b. So I have to pass it a 3 and say 4. Now it should give me 7, as you can see. The next type of argument that we'll be talking about are the variable number of arguments. So let's look at an example here. So what I'm doing in this particular example is I'm defining a function called mySum, where I'm passing some parameter called myIntegers, and I'm doing something out here. And what this does is it will take the values of a particular collection of objects, and that's called myIntegers. And each value I'm going to keep adding it to each other, and I'm going to result a particular sum. I'm just going to result the sum of whatever is there. So in this case, what happens is I'm creating a list 1, 2, and 3, which contains 1, 2, and 3, and then I'm going to print the summation of whatever is there. So it should give me 6. Now the problem in this case is that each time when I'm going to perform this function, I have to create a separate list where I'm going to store these objects. But what if I do not know what exactly I'm going to pass here? What if I don't know if it's going to be a list of objects, or what is it going to be exactly? Well, in that case, I can use a variable number of arguments. So it's like a variable keyword argument. So what we use here is a specific way of passing keywords, and we do it like this. So I say define my underscore name, and I use an asterisk. Now I give it any name. This can be args, this can be integers. It doesn't really matter what this is, but this is the key, the asterisk here, and this tells us that whatever we pass here is now we're supposed to create an iterable out of this, and then we can perform whatever task we want. So let's just since I've already created one here, let's see how I'm going to use it in this case. So as you can see, I'm creating a particular variable argument function over here, and I'm doing the same task. I'm just going to keep performing I'm going to add whatever I pass over here. But now when I'm calling this function, I don't need to create a separate list as I did over here. I'm just passing all the numbers that I want to in the form of it's pretty much like a tuple. So I'm just passing these numbers here, and what this function is going to do is going to create an iterable out of this, and then we're going to iterate over it. As you can see, that's happening over here. And I can keep I can just keep so since I've done it for 1, 2, 3, and 7, the summation should be 13 in this case. I can add another number here just explicitly, just like this, and you can see the value will change. And that's because this is a variable argument method of creating a function. Now the fourth type of function arguments is the variable keyword argument. So let's look at what is the keyword argument now. So I have defined a function here called the concatenate function, and let's see what I'm going to do with this. So in this, I have passed a keyword argument. I've said that, okay, this is going to be a keyword argument function, and what I'm going to do in this is I'm going to create a blank string, and what I'm going to do is I'm going to add or I'm going to concatenate certain strings that I'm going to pass to this function. So in this example, I have passed Python and is and cool and an exclamation mark, all separate strings, and what I'm going to do in this function is I'm going to join them together, and I'm going to create one whole string out of it. Let's see what's the result. Python is cool. So this is, so of course, if I had to add something else, like Python is say cool, and say I just wanted to say hello and say one more string, I can add it just like this. I don't have to define a fixed number of arguments. I can pass any number of arguments I want, and this works exactly the same as variable. In the only difference is instead of positional arguments, we're using keyword arguments over here. Hello, bye. This, it doesn't really make sense, but just to show you, as you can see. So this is how we use keyword arguments. Well, this is it for this introductory video into functions in Python. I hope you learned a bit about defining functions and sort of the keywords and the components that are part of function definitions, such as keywords and arguments and docstring, for example. You also saw the different types of arguments that we can pass.
Welcome to this video on Python projects by Simplilearn. Today, we will learn 3 hands-on projects that will help you improve your Python coding skills. We have with us Anish Karan, who will take us through these projects. So the first project we are going to see is, given a block of text, you will count the frequency of each word occurring in the text or paragraph. In the second project, you will trace the movement of a robot. The robot can move up, down, left or right. You will write a program to find the distance between the starting point after a sequence of movements. In the final project, we will write a program to check the validity of passwords given by the user. Often, while logging into a website or an application, You are asked to input the username and password to register. Our project will check the criteria for setting a password and approve it only when the criteria are met. So a password should have at least one letter between A to Z, at least one number between 0 to 9, one uppercase letter, one special character, and so on. So let's get started with our first project.
Hello everyone and welcome to another video on Python programming. In this video we will be covering a sort of a project side type of scenario, which is basically going to be a problem case for you, and it's going to be slightly difficult, slightly tricky, but what we're going to do is we're going to tackle a particular problem, and we're going to what I'm going to do is also show you a solution to that problem. So let's start with this. So this question that we have is we have this program that we have to write where we compute the frequency of words that exist in some input. Okay, the program should output after sorting the key alphanumerically. Now this input can be it's basically a block of text, right? So in our example we have for example, if this was our input, right, what we want to see is an output which is basically saying that the word Python has appeared, say, well, in this example it's appeared 5 times, and then the word read has appeared 1 time, and so on and so forth. Like for each of these words we want to see how many times have they appeared in this particular block of text. So let's look at a particular example now where we have done this. So let's see here. So first of all, I'm going to create a dictionary. So why am I creating a dictionary is because I'm going to use each unique word as a key and the number of times they have appeared in a block of text as the value to that key. So I'm going to use a sample string, which is basically this long string that you can see here, which is stored in line. So this large chunk of text is what we're going to be analyzing. So how are we going to do this? It's pretty simple. So we have this. Now what we want to do is when we find one way of tackling this problem that we're going to do here is we want to check word by word. First of all, we want to see if it's a unique word, and if this word is before I encountered it for the first time, then we need to store a new key in our dictionary called frequent table or frequency table. And if it has already, if there is a key already with that particular name, then we just want to increment the count or the value by 1. So let's see how we do this over here. So if you can see in the solution is as simple as this, but if you see what's happening, it's basically what it's doing is we're splitting up this string using the split function. What this will do is it will split up the string at every white space. So it will take this as one part, it'll take this part as another part. It will create an iterable with each word as the each iterable object in that container. So it's going to be a list of words like Python is 1, so on and so forth, and we're going to go one by one. So we're going to say for word in line.split. Now if this word if it exists in frequency table as a key, then what we're going to do is we're just going to increase the count of the value of that key by 1. But if it does not exist, then we're going to actually create a key with the word as that unique word, and we're going to create its value, initialize its value to 1. So when we execute this, now if we want to, once we've done this, we can sort it by the count of the words. So what we're going to do is we're going to create another tuple called sorted tuples, where we're going to use the lambda function out here to sort the dictionary in terms of its values. So what we're going to do is we're going to take the key being the lambda item with index 1. Index 1 is basically the value. So a particular key has a value. So the word Python appears so many times. The word say scientist appears so many times. So we're going to check which words have the highest number of occurrences, and we're going to sort it in a descending order. So that is basically what the reverse is equal to true does. So when we're going to sort this, when we're going to use the sorted function, when we say reverse true, it tells the sorting function to sort this dictionary frequency table in terms of value. by the descending order. So whichever word appears highest, that will be the first word in our sorted tuple. So that's what we do in this line, and once we execute this, we're also going to print. So if you see the result of this activity that we've done, you can see that the word machine appears 6 times, learning appears 6 times, then Python appears 5 times, and so on and so forth. So we've created a sorted tuple where the first object of the tuple, we've created a list of sorted tuples where the first object of the each tuple is the unique word, and the second one is the number of times that it has appeared in this particular example or this particular string. So yeah, this was the first basic project that we have tackled.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Hello everyone, and welcome to another video on Python programming. In this video, we will continue with what we started in terms of our project number 1. What we're going to do is we're going to tackle another slightly complicated question or a situation. We're going to try to arrive at a solution. So in this, what we have is some sort of a robot, a moving robot, which moves on a Cartesian plane, a 2-coordinate plane, is going to move in terms of up, down, left, and right. Okay, and each time it moves up or down or left or right, it takes a certain number of steps in that direction. Integral steps, of course. So what we need to do is from its starting position, whatever its starting position is, which we're going to take as 0, 0 in this example, we're going to make it move to a particular location with the commands up, down, left, and right, followed by certain steps. And we're going to what we're going to do is we're going to calculate the distance between these 2 points. And we're going to calculate different types of distances. So you might be introduced to new concepts, new distance concepts in this video as well. So what we're going to be using for distance calculation is the Minkowski distance. And that is, we're going to take, so the Minkowski distance between 2 variables is basically the absolute difference between these 2 variables, so these 2 points, and we take it to the power of something. So if we want to say calculate the Minkowski distance with in terms the quadratic Minkowski distance with basically p2, so we are going to do xi minus yi, absolute difference to the power 2, and then we're going to take the second root of it after summing each and every point. So when we take p is equal to 2, we say the Minkowski distance behaves like the Euclidean distance, and this is probably one of the most common distances in case you've done basic Cartesian geometry. When you're asked to find the distance between 2 points on a plane, we can also take the absolute distance where we take p is equal to 1. So in this case, we're just basically summing the absolute distances between each point. No roots, no powers, nothing. Basically p is equal to 1, and we call that the Manhattan distance. So we're going to take p is equal to 1, 2, and 3 in each case, and we're going to find the distance between 2 points based on these measures. So this is just a visual representation. This is basically the Euclidean distance, basically the estimate of the value between these 2 points. If since this is a 2-coordinate system, whereas the Manhattan distance would be the absolute distance in terms of if we go up and then we go right between these 2, like say if this was and this was another point. So yeah, let's move on to the problem. So what we're in this particular example, we're going to start from the starting position 0 and 0 on a graph, and we are going to give the commands of up 5, down 3, left 3, and right 2. So first of all, what we want to do is we initialize the starting position as 0 and 0, and we also, just for the sake of this example, we initialize the end position as 0 and 0. So what we're going to do first of all is let's execute this much. Now we have this list of tuples. We're going to call this actions, and this is the actions that we're performing. So each tuple contains an action and the number of steps in that direction. So it contains 4 actions: up by 5 steps, down by 3 steps, left by 3 steps, right by 2 steps. So now we're going to iterate over each tuple, and we're going to get the direction first of all in this line for each step, and we're going to calculate the number of steps it takes. So for each action, it's going to first tell, it's going to check what is the direction, which is done by this line, and we're going to find out the number of steps in that direction, which is stored in this line. So once you've gotten this, for each action, we have to update the end position, right? So what happens is, if you go up by a particular direction, so you are basically changing the y-axis, right? The y-axis. So we're going to change end position and the first index, which is basically this part of the end position coordinate point. So we're going to say if it's moving by up, then we're going to update by adding the y-axis by the number of steps. So and if the direction was down, we're going to do the same thing for the y-axis, but we're going to decrement it. Similarly, if we move left or right, we're moving the x-axis, right? So we take end position in the first index. So we take the x-axis, and if we're moving left, it's a negative, it's a decrement, and if you're moving right, it's an increment. So if there's any other action, like any other action, for example, that was given here, we say pass. So basically the only valid actions that we can pass is up, down, left, and right. Otherwise we just skip that particular action. So this is what this particular loop will do. It will update our final position. So once we've done this, if I execute this, what will get stored in the end position is basically my end position. So now that I have my starting position and my end position, just to show you what the end position will look like right now, let's just do this. So if you see here, after I've moved up by 5 steps, down by 3 steps, left by 3 steps, and then right by 2 steps, my final end position is -1 and 2. My start position, on the other hand, was, as you remember, it should be 0 and 0. It is 0 and 0. So now we're going to find the distance between 0 and 0 and -1 and 2. So we're going to first of all create a function called Minkowski distance, which does a basic function of just calculate the difference between the the end position x coordinate and the end position y coordinate times or to the power of a root. And we're basically going to do this operation that you saw here. We're going to do this, and we're going to use this root variable to specify to p is equal to 1, 2, or 3, like what p value we want to take for this Minkowski distance. So once we've done this, what this function will do is basically store this much, and it will wait for us to give us a root. So when we give root 1, it will create these, it will check the distance between the end and the starting points with the p value of 1. If we gave it 2, it will calculate Euclidean distance with p value 2. Similarly for 3, and we can calculate for any roots. So we're going to calculate for 1, 2, and 3 roots, and we're going to see what values we get in each case. So when root is equal to 1, I print a statement saying Minkowski distance with root 1 is something, and then root 2 it's something, root 3 is something. Let's see what results we get. So if you see here, the Minkowski distance with root 1 is actually 1.0, but the Euclidean distance between these 2 points is 2.23, whereas the cubic Minkowski distance with with root 3 is 1.91. So you see these 3 different distance measures for the same distance between 2 points. So in this video, by doing this activity, you will learn how to how to iterate through loops and perform these distance calculations, which you'll find pretty handy in many activities related to data science and machine learning. So yeah, this was on the project 2. Hello everyone, and welcome to another video on Python programming. In this video, we will be continuing tackling different problems and problem cases in terms of a project called Project 3, where we're going to be using regular expressions to validate whether certain passwords that have been entered, do they match certain criteria or not. So let's look into our particular question. We have a website that requires users to input username and password to register. Now we have to write a program to check the validity of passwords input by the users. Now the criteria that the passwords have to follow are that there's at least one number between A and Z, and there's at least one letter between A and Z, and one number between 0 and 9. The third criteria is that there's at least one letter between capital A and capital Z. So this first and third point basically is saying that there should be one lowercase letter and there should be one uppercase letter. Now there should be at least one character from $, hash, or the @ symbol. It should have a minimum length of 6 and the maximum length of 12. So when whatever passwords that we enter into our example, they must be comma separated. So if we're going to have an input, they're going to ask us for an input where we're going to have to input the different passwords in a comma separated way. So let's look at how do we tackle this. So for my example, I'm going to use these examples in terms of these are my password examples. If we're going to check if these are valid passwords or not. So let's copy this first of all. And now let's import the RE. This import RE is basically the regular expression module. Now in this step is going to ask us to input the passwords, as you can see here. So I will just Control V. So since this is comma separated, what it will do is it will split up each of these by the comma, and it will store them in a list. So it will take this as one password, this has another password, this has another password, and this has another password. Once I press enter, now if I want to check what's in list, what's in items, what I can do is just check over here what's in items. It's a list of whatever passwords I had entered. Each object is separately treated now in this list. Now I'm going to create an empty list called value first of all. Once I've done that, I'm going to move on to the next step. So once I've created my list called value, what I'm going to do is now I'm going to search and I'm going to check for each condition using regular expressions for whatever criteria that we have initially. So if you see here, what I'm going to do is first iterate by each item in this to check for each password. Now my first check will be a basic check for the length of the password. If it's lesser than 6 or greater than 12, then our password is illegal, so we can't be using this and we will just continue and we won't check for anything else. But if it is within 6 and 12, the length 6 and 12, then we can continue with our check. So we'll do an else statement for pass, which basically moves on to this next block. Now once we've done this, what we will do is this first statement, what this is going to do is going to do an re.search. And re.search, as you know, is going to look for at least one instance of a letter occurring between A and Z. So this re.search followed by this. Now this is the regular expression that we have passed, and what this tells us is basically the square brackets, we're looking for anything between A and Z in terms of small letters. So if this condition is not met, then again we continue and we leave this particular search because one of our criteria is not met. Alright, but if it is met, then this if not statement will not we won't enter this block and we can move on to the next check. So now we move to elif not. Now again we're using if not statement. So this is basically checking for a negative case. So anytime one of these cases have been met, it basically means that our password has been invalid because these conditions are not being met. So we're trying to eliminate all conditions, all of these conditions, so that we get a valid password. So again we move on to the next statement, which is basically going to do the search for numbers. Once again, if we find a case, a password without any numbers, we continue and we don't check this password no more because we already know it's an illegal password. Now next check will be for capital letters A to Z, and the next check again will be for these particular symbols, the $, the hash, and the @ one of these three symbols. Finally we have a search for we're going to search for a white space character. So if we actually do find a white space character in our password, that's an illegal password and we're not going to continue checking for those cases. So so this is basically all our cases. Lowercase letters, numbers, capital letters, one of these three symbols, and the existence of a white space. So once we've done all these checks, if none of these have been passed, we move on to this else statement where we just pass. And what we can do is we append the value. We append the value to we append p to the list called value. So basically, what happens is just to go through it again. If this condition is not met, and this condition is not met, this is not met, this is not met, this is not met, and if this is also not met, then we're fine. So basically, as long as we have small letters, as long as we have a number, as long as we have a capital letter, as long as we have one of these three symbols, and as long as we don't have any white space characters, we can append p to this. Otherwise, it will continue and it will break out of this for loop completely. That's what the continue statement at the end of each of these blocks checks. Anytime this condition is met, this if not condition is met, then we break through this whole for loop and we don't append p to the value. But if we actually get to this stage, then what we can do is simply append p to value. Now, finally, what we are going to do is we're going to print out all the valid passwords. So just by a quick look, you can see here, this is a valid password, right? So let's execute this and let's see what we get. If you see here, we only get one valid password, and let's look at why some of these do not turn out to be valid. So if you look here, all of the conditions are met. It has a capital letter, it has a small letter, it has at least one number, and it has one of the symbols, either $sign or the hash sign or the @ sign. In this case, we have two white spaces, one over here and one over here. So this is an illegal password. Similarly, in this case also we have an illegal password because it begins with a space. In this case, it's the same thing. We begin with a space, and also it does not have any of those symbols that we were looking for, the $ or the hash or the @. So these three are illegal passwords and they do not get appended to value. However, this does get appended to value, and that's why we get the result for only one password, which is the only legal password.
Thank you all for watching this video on Python tutorial for beginners. I hope this was useful and informative. If you have any questions, then please feel free to put them in the comment section. We'll be happy to help you. Thanks again. Stay safe and keep learning.